Hear me? Can you hear me? Good morning. Welcome to day 3 of DappCon. I hope you've been enjoying yourself. I certainly have seen a bunch of great talks. And today is no different. We have a bunch of great talks today and into the afternoon, and I'm especially excited about this morning's track. It's a little bit more philosophical, less technical than some of the other tracks that we've had this week. So to kick it off, we have Dr. Ann Brody talking about the Ethereum ecosystem, organizational culture in the Ethereum ecosystem, and then following that talk, we'll have Paul Ennis give a similar talk. So please, welcome to the stage, Ann Brody.
All right. Thank you for the introduction, and thank you all for being here today, bright and early. I'm truly delighted to be part of DappCon, and I'd like to extend my sincere gratitude to the Gnosis team and the DappCon team for putting such an amazing event together. So it's a real privilege to be able to share the research that my colleague and I have been working on. So my colleague is Dr. Paul Dylan Ennis, also known as Polar on Twitter, if you follow him. Today we'll be presenting insights from our latest paper called Tending the Infinite Garden, Organizational Culture in the Ethereum Ecosystem. So this talk is about an academic paper. And so this presentation will be part of a larger sequence, and it will be followed by Dr. Paul Dylan Ennis, who, as I mentioned, co-authored this paper with me. So I will introduce the paper, outline our central arguments and key findings, and then Paul will basically take over and provide an update on the developments that happened in Ethereum since the paper was written. So in this sense, my talk will set the stage and context for what comes next. So before we delve into the actual paper, let me take a moment to introduce myself. So for the past 7 years, I've been immersed in the crazy world of crypto, trying to make sense of how developers and other actors in this ecosystem imagine and attempt to realize decentralization and decentralized governance. So I have a PhD in communication studies, but my roots are in anthropology, and my research has consistently centered on what we call the social layer of crypto, studying the culture of public goods in Ethereum. And so Dr. Paul Dylan Ennis, who's my co-author and longtime colleague in this ecosystem, we were one of the earliest social scientists who started researching and producing literature around Ethereum's social layer. So I wrote one of the first papers on Ethereum in my field, and Paul wrote a book, and basically since then we decided to join forces and write this article together on Ethereum's core dev culture and governance. So to begin, I will give you a brief synopsis on what the paper is about and present our core argument. We focus on the role that culture plays in shaping Ethereum's governance by exploring what we call social imaginaries of Ethereum's core developers. Now, I'll explain what social imaginaries are in a moment, but in essence, we argue that in the absence of centralized hierarchy, such as with the case of Ethereum, these social imaginaries that we identified in the paper, they step in to define the boundaries of legitimacy in decision-making within Ethereum's protocol governance. So you might be wondering, okay, what are social imaginaries? So social imaginaries is the theoretical framework that science and technology scholars like to use. So I don't want to get too philosophical here, of course. There is an element of studying people's subjectivity and people's relationship to technology, but to put it more simply, it's really just trying to understand the collectively held beliefs, norms, and attitudes about a technology. And it derives its theoretical understanding from philosophers like Charles Taylor, who describes this as the ways people imagine their social existence, how they fit together with others, how things go on between them and their fellows. And so the reason why we should study social imaginaries is because it allows us to uncover the dominant ideologies and question assumptions that shape our understanding of technology. So for instance, there's a widespread belief that technology is inherently neutral or that economic efficiency should always be prioritized. And so studying social imaginaries equips us to envision alternative technological futures and pathways, and it empowers us to rethink existing directions and avoid perpetuating hegemonic structures or political agendas inscribed in tech, because ultimately technology is ideology, and we must not overlook the politics of technology. And of course, we're not the first ones to look at social imaginaries in the context of crypto communities. Many other scholars have done this prior, so studying the shared visions or stories people hold about money, power, and infrastructures. One of the leading voices in the space is Lana Schwartz, who helped bring the concept of social imaginaries in blockchain research. So she was looking at the early Bitcoin community, and she identified something called infrastructural mutualism, which is the idea that money doesn't have to come from the state, but instead can be built collaboratively from the ground up. It's rooted in this ethos of open source communities and the cypherpunk love of privacy and autonomy. But she also observed another imaginary at play in the Bitcoin community called digital metalism, which is a more individualistic hardline vision where Bitcoin is treated like digital gold. This one leans heavily on libertarian ideals, which recognize value in scarcity and independence from institutions. Now, Ethereum brought a whole other imaginary into the mix, known as the world computer, which was, of course, coined by Gavin Woods, but then it was later embraced by the Ethereum community. Now, this vision sees Ethereum not just as money, but as a global platform. It's a kind of like open playground where anyone can build apps and experiment with new economic primitives and models and reimagine how we live and collaborate. Then there's the hacker-engineer imaginary. This one channels the energy of hacker culture and DIY tech, so think rebellious, anti-corporate, and anti-surveillance. It's a reminder that blockchain didn't just spring from markets, it also carries the radical DNA of peer-to-peer networks. And so Paul Dillon Ennis and his collaborators also proposed the imaginary known as productive money. So unlike Bitcoin, where the ideal is to hoard or hodl, as we say, Ethereum's native currency, Ether, is always in motion. It's used to pay gas fees, secure the network, and reward contributors. So Ether isn't just sitting on a mattress, right? It's working. And this is where our contribution comes in. We added a new one called the Infinite Garden. Now, this idea sees Ethereum as a living, breathing ecosystem, which is organic and evolving, and full of potential. But like any garden, it needs care, and it can grow wild or grow stale. And while it invites endless experimentation, it also faces the risks of becoming fixed, and less of a garden, more of a monument. So we'll dive deeper into this later, but for now, just know it's a metaphor that captures both the hope and the tension at the heart of Ethereum's future. So for this research, here's our research approach. We interviewed key figures from Ethereum's core development group. And what's interesting about Ethereum core devs is that they're part of a porous group, so anyone theoretically can be a core dev through consistent contributions, and there are no formal barriers. So our interviews weren't limited to just developers. We also spoke to researchers and coordinators. And here are some of the people we interviewed, including Vitalik, Danny, Pooja, Tim, Alex, Ben, and Trent. And our interviews were semi-structured, meaning we had a set of open-ended questions that allowed for deeper exploration of topics as they came up. Now, I don't have time to fully dive into how Ethereum governance works, but here's a quick overview of the key stakeholders involved. So we have the core devs, the full nodes, the stakers, the media, the dApp builders, and the end users. And this structure forms what we call a polycentric governance system. Essentially, it means that multiple overlapping decision-making centers operate autonomously but interact with each other through cooperation, competition, and conflict resolution. No single entity holds control, but governance happens through coordination among these decentralized bodies. So now, having said all that, and doing some of the context setting for the research, I'll discuss some of the key themes that emerged. So the cyberpunk theme is one that was pretty prominent. For anyone who doesn't know, the cyberpunk movement began in the 1980s. It emerged from online hacker culture as a protest against the growing power of the state to monitor its citizens through digital network. So they were a group of advocates who they basically used cryptography as a route to nonviolent direct action and social and political change. So we found that some of these values still permeated in the worldviews or imaginaries of Ethereum devs. You know, we had quotes by Ben Eddington stating things like, "We are for decentralization, we are against political control, and we are for credible neutrality, and making Ethereum robust against capture in all its aspects." And so while it's no surprise that Ethereum's roots are tied to cyberpunk ideals, what stood out in our findings is how many of the people we interviewed see themselves as part of a broader lineage of the cyberpunk heritage. And this traces directly back to the infrastructural mutualism social imaginary that's grounded in open source collaboration and decentralization. So there's a deep resonance within Ethereum core devs where they view their work as an extension of these cyberpunk principles and broader historical lineage. Now, another key theme that emerged during our research was conflict resolution, specifically how core devs manage differing perspectives within their group and within the wider Ethereum community. So our interviews took place around the time of a major Ethereum protocol upgrade known as Shapella, which went live on April 12, 2023. And this upgrade allowed for participants in Ethereum staking mechanism to withdraw the ETH they had locked up during the transition from mining to staking, which was a huge milestone for the ecosystem. So many of the developers we spoke with emphasized the clarity of the decision-making process, reflecting Ethereum's collaborative governance approach. Despite some setbacks and maybe back and forth discussions on the technical side, we found that the considerations were relatively straightforward, as Alex Stokes put it, and the process was pretty streamlined. And Danny Ryan also reinforced that decisions were largely based on rough consensus, meaning that complete agreement is not required, but a general alignment is reached among participants. And also, Ben Eddington has highlighted how decisions are generally made through discussions where dissenting opinions are welcome and heard. You know, this very much aligns with how developers work, which is based on this pragmatic engineering ethos that is committed to excellency and precision. Another key theme that emerged was market pressures. So one of the key research questions we had for developers was to understand the extent to which market pressures influence the decision-making of core devs. And what we found was that after Ethereum's transition to staking in September 2022, developers did not initially prioritize enabling withdrawals of staked ETH. However, other participants within Ethereum's polycentric ecosystem, notably stakers, media, and end users, felt that unlocking staked ETH should be the top priority. And so in response, the core devs adjusted their focus, deprioritizing other upgrades and shifting their efforts to enable withdrawals through the Shapella upgrade because they wanted to deliver on that promise and they felt that the imperative to deliver on that commitment. So we specifically found Ben Eddington's remark important because he emphasized how developers have a degree of autonomy from market pressures, and they do not allow to sway them from their core mission, stating, "Mercifully, we've been free of commercial pressures. Core devs are pretty resistant to being told what to do, and we will make our own minds up." Okay, that's pretty cyberpunkish, right? Okay, so now we come to the term infinite garden, right? So this is the imaginary that we are sort of contributing to the broader literature of imaginaries. So the infinite garden, this term was coined by Aya Miyaguchi, which was the former executive director of the Ethereum Foundation, and it perfectly captures the essence of Ethereum's ethos in Aya's own words. She describes Ethereum as a protocol for human coordination. Coordination is a game, but not that one is played to win. Coordination is more like tending a garden, where one works only so that the garden continues to thrive. So this analogy reflects a temporal dimension to the thinking of Ethereum core devs. Social imaginaries provide a way for understanding our place in time and space, among others, and within history. Beginning in 2020, Ethereum's co-founder Vitalik Buterin introduced what is often referred to as the Ethereum roadmap. However, it's important to note that this roadmap is not an official or formal document. Everyone must follow. So rather, it collates various long-term research trends of Ethereum's protocol development, and the roadmap converges towards a sort of endgame, the point where Ethereum's protocol will be so mature that it will no longer require major upgrades and its development will stabilize. So for core devs, their primary task is tending the infinite garden, and just like any infinite garden, there is always maintenance to be done, but at the same time, seeds are being planted for the long term. So you might be wondering, okay, so what? Infinite garden, great. What does this all mean? Okay, well, I think this is interesting because while clear structures of processes and practices in the Ethereum exist, such as EIPs, all core dev calls, and research forums, we found this particularly social imaginary important because beyond EIP1 and a README text, Ethereum lacks a formal constitution or governance document. And these social imaginaries, we argue, serve as the essential enabling conditions for Ethereum's governance to function seamlessly. So in the absence of formal guidelines for off-chain governance, these imaginaries play a vital role in defending the boundaries of acceptable actions and behaviors. As a result, core devs lean heavily on these implicit imaginaries to ensure cohesion, and within the Ethereum community, they guide them by fostering a shared sense of foundational values, long-term alignment, and nuanced understanding of the ecosystem's collective expectations, which is important for a collective without a formal hierarchy for maintaining legitimacy. Which is to say, also, let's not overlook the role of culture in Ethereum's governance. So the infinite garden suggests an imaginary, it's an imaginary that suggests a dynamic, ever-evolving ecosystem where growth and transformation are ongoing, but a key challenge we discovered was for core devs in maintaining cypherpunk values as the ecosystem grows. And these concerns reflect an underlying anxiety. As Ethereum grows, the original cypherpunk ethos could become diluted. For the core devs, this growth signals success, but it also invites the possibility of new visions of Ethereum that may diverge from the foundational values they aimed to embed into the protocol at the origins. So these are the findings of the paper. The paper is currently in publication, and of course we are always happy to continue the conversation and hear out your ideas. Feel free to reach out to me or Polar on Twitter. This is my crypto Twitter. I will now hand it off to my colleague, Dr. Paul Dylan Ennis, who will speak with you on the developments that occurred in Ethereum since this paper was written. Thank you so much.
Hello, everybody. I'm extending the talk. It's a bit of a double act, this, between Anne and myself. I'm going to talk about Ethereum's evolving social layer. Okay, so in case you just arrived, so some people may have missed Anne's talk, which is basically the comprehensive overview of the paper. I'm just going to give a little summary, like a very quick summary as I see it. The paper is called Tending the Infinite Garden, Organizational Culture in the Ethereum Ecosystem. It's submitted to the Journal of Cultural Economy, which is basically the only journal in the whole of academia which is sympathetic to crypto. So give them some love. If you ever want to read any academic journal, that's where to go. It's in revise and resubmit, so we've done our revisions, we've resubmitted it, and now we're just waiting for some other academics to sign off on it. This being academia, it takes a very long time. This article would have been started maybe 2 years ago, the first seeds of it, maybe a year and a half on it to do the interviews and the work, and then even now we're still waiting, right? Such is life of an academic. It's basically the opposite of crypto. Everything takes much longer. So in the paper, what we did is we're trying to find some imaginaries, pre-existing imaginaries that were identified by academics, and then see if we could discover a new one, which is what we do. We find the infinite garden imaginary. As Anne explained, imaginaries is just a fancy academic term meaning the way things go on between each other, the expectations we have of each other, and how we lend legitimacy to decision making. It also involves an idea of what the future would be like, the socio-technical future, what the cultural endgame might end up like. We interviewed a bunch of people. It's basically a who's who of Ethereum core developers, as we call them in the paper. So Vitalik, Alex, Ben, Trent, Pooja, Alex Stokes, etc. Right? So it's a very high quality group of people to have talked to. Yeah, so that's the general idea. And then what I'm going to do is talk about how things have gone since, right? What's the deal with Ethereum since this point? Now, up until maybe 5 years ago, every academic paper on crypto was the same. They basically went something like this. The crypto people say things are decentralized, but did you know they're actually centralized? It was the most boring thing you could imagine as an academic. Every paper went the same way. But in recent years, there's been a bit of an evolution, and so now it's more common to understand blockchain communities as polycentric. So this is the term, the term of art in the industry, meaning multiple overlapping decision-making centers, what we would call stakeholders, right? With some degree of autonomy, engaging in cooperation, competition, conflict, and conflict resolution. Now, the first thing that struck me on rereading the article is that we really focus, as you saw with Anne's paper, on this idea of cooperation and conflict resolution. When interviewing the core devs, you get this very strong sense of high trust amongst each other and the sense that they feel that all issues could be resolved, right? Rough consensus can always be reached. As Vitalik says, we simply talk it out, right? That's the general gist that you get from these interviews. Now, what we missed is the competition and conflict because, or at least in my estimation, the reason we missed this is because we were so focused on one particular stakeholder group. So we were just talking to the core devs and not taking into account the other stakeholders. And I'll do a stakeholder set list a little bit later on. And so we missed the beginnings of the coup, the shakeup, right? The revolt against the Ethereum Foundation that happened. And maybe we would have seen that if we talked to more people. Now, the reason we did this is, again, something to do with academia, which is, from our perspective, this is all very familiar, right? You're talking about the Ethereum Foundation, you're talking about core devs. To academics who read these journals, they have no idea what you're talking about. You have to pick one group, you have to simplify things, and by necessity, you end up distorting the situation to some degree. Another thing I think that really struck me is if I was writing this today, or me and Anne decided, right, we're going to write a new article today, we'd probably start off by focusing on the Ethereum Foundation, right? That's where all the drama is, that's where all the excitement is today. Whereas at that point, right, when we were writing this article, that wasn't really the case, right? The Ethereum Foundation was something we didn't talk about. It did a lot of stuff in the background, and now it's become an entirely different beast. So if you're working at the Ethereum Foundation, we're going to be watching what you're doing. So not to freak you out or anything, but that's what we're doing. Okay, so stakeholder expansion dilemma. Another aspect of the paper that stood out to me is, this is a term that I guess that I'm trying to introduce. You can see in the paper that the core devs are aware of this, right? They know that what's going to be the big issue in the coming times is the desire of the wider stakeholder set to voice their concerns and to influence the core development process in some kind of way. And what is this going to involve, let's say from the cultural perspective? Well, it's going to involve a challenge to the traditional cypherpunk value. So here's Alex Stokes. It seems that things have gotten bigger. I expect they'll keep getting bigger in some form or fashion. So as it happens, it'll be harder to maintain alignment. How do we incorporate the interests of these stakeholders into development without compromising our cypherpunk values? I don't think it would be easy, right? All the signs were there. In retrospect, in reading this article, you can see that subtle awareness. Now, the other starting point that I would do, or we would do if we were starting a paper now, is we have the perfect beginning for a new article because, of course, all core devs, for those who don't know the kind of governance calls for Ethereum, are being reconfigured. So this is a major change, a really excellent starting point for any future academic article. And this is going to involve a few things, one of which is the flagship, right? The EIP is having a flagship or like a theme, basically. So that's different. And then also the idea of including the stakeholders, right? So the stakeholders are going to have more of a voice, and so this would be a perfect way to begin. Now, in Tim's post, you can see a recognition that the categorization of the stakeholders would be the most important thing. And so what I'm going to do briefly is just talk about what I consider the stakeholder set in 2025. Now, there's a real metaphysics of stakeholder set generation in Ethereum culture. Anybody who's worth their salt in like Ethereum social science thinking or like a philosophy of Ethereum, whatever, has their own stakeholder list. Vlad Zamfir has one all the way back in 2016. Vitalik has one, of course, right? Tim Baiko has one in his governance talks. Trent has it in his commons work. Blockchain Gov, the other academics, are rivals. They have and then I also have it in Absolute Essentials of Ethereum, and then Anne and I have a stakeholder list in our paper. Now, this is a very rough list, kind of thrown together on Fileverse, so that's why it's kind of maybe, I'm still learning how to use it, so it's not the prettiest slides yet. Shout out Fileverse, by the way, and Excel. This is how I see the core devs as the presumed stakeholder set today. We know that these are grandfathered in, they have to be included. But there are issues around the core devs today that I think are interesting. So the core devs up until the last call effectively, right, the way in which decisions will be made is that the chair of the ACD would effectively go around and tell people, here are the options, and then everybody would chime in, and then if there was rough consensus reached, then that's the decision that would be gone with. But you could see in the last call with EOF that we saw some stakeholders appear in the call, complicate matters such that it had to be shelved, and so that's something from an academic perspective that I think would need to be discussed when it comes to the core devs and the wider stakeholder set. Does everybody get to pitch in a little bit? The researchers, here the interesting thing for me is the remnant of Aya's reign. A couple of things, calling it the infinite garden was probably a bit wrong-headed, right, because that's fallen out of fashion. But subtraction, right, the process of subtraction, is Ethereum Foundation still in this process of subtraction? Is this something that's still being pursued? Or have we switched over into this idea that the Ethereum Foundation is essentially the guiding entity, as Christine Kim has been raising in her newsletter? The organizers, okay, so Ethereum Kayherders, the Protocol Guild. And the chair of the ACD is always an Ethereum Foundation person. This is something, again, that Christine Kim brings up. It's a very, very powerful position, right, between Tim and Alex. They're essentially the people who decide when rough consensus is reached, effectively a little bit on a vibey kind of way during the calls. And that's something to be interrogated, although my position is actually it's better just to keep them, right? They're obviously very competent at it, but it's worth, from an academic article perspective, bringing up. The Ethereum Foundation, a can of worms, here represented by my favorite, Xiaowei. So the Ethereum Foundation, at the time of writing this article, was effectively something we didn't really mention that much, and now has switched into this, as mentioned, this guiding role. To me, that's the most fascinating question, the most fascinating difference between then and now. So the EF is something we didn't talk about, to the EF is now very much guiding what's happening. Okay, another group of stakeholders who may or may not be included, the end users and power users. So the average Joe and Jane, represented here by LDF, who volunteered for this. Someone who just wants Ethereum or ETH to go to 10K. And then the power users, who I've kept as Dr. Nick here, but of course that's now controversial, right? He's a bit of a defector. So these highly experienced and sophisticated class of Ethereum users. So we could also say have HASU, specialist people. Now, I've been arguing for a long time that this is probably a group of people who are too messy to have involved in core governance, but it is fascinating to me that we've never figured out a feedback mechanism. Now, in articles in CoinDesk all the way back in 2023, 24, why don't we have some way for them to signal whether they agree that the EIPs, the theme, is the correct way to go? It seems something relatively simple to do. It could be done online, and it could also be done, say, at DevConnect or DevCon, and non-binding feedback. I don't know why we haven't done this. And by we here, I'm talking broader Ethereum community. Okay, our three, the groups that will definitely be in, and I'm going to skip past them because of time. But these are the groups that are, I suspect, most likely going to be included in future core governance discussions, and they are a complete mess, right? It's really, really complicated when you begin digging into it. So you can have a Nixo-style home staker, but you also have Chorus One, you also have Lido, you have relays and builders, and then the builders themselves here represented by Lawrence. Shout out to West Ham. We have, I could see you guys there. Right, so it's everything from, say, more aligned entities like let's say Dune Analytics or L2B, all the way to centralized exchanges, right? So where do we have the criteria to say, like, to demarcate the boundaries of legitimacy in the imaginary sense? That's perhaps where a Xiaowei-style DeFi punk criteria setting may become important. The roll-ups, who are now kind of in the cold culturally, but are the most integrated into governance. I feel actually that's probably the most existential topic we aren't really addressing, that we have long had this idea of the roll-up centric roadmap, and now we're back to scaling the L1. Healing that bond sounds a bit hippie-ish, but it is something I think we need to talk about at some point. Maybe this is the way that we go about it. The ambiguous stakeholders, those of you who know me know that these are my two, let's say, my ideological enemies, right? The media and the investors and VC, in particular types of media, not say nativist media like the Daily Gwei or Bankless, although Bankless is obviously way better, but the Blockworks Extended Universe, right? That kind of group of podcasts where it's the VC talking heads, and I think there's a complicated question there that I'm going to talk about. I don't believe they should be included in protocol governance, but they are part of the stakeholder set, and we probably should begin including them to some degree. Now, the other part that I want to talk about is today, obviously, if we're talking about imaginaries, we have to talk about the emergence of this new imaginary, which we can call the pragmatist imaginary, or which I'm calling the pragmatist imaginary. Today, it's called Tomasism. Last week, it was Dankradism. I've got the blessing from Dankrad. Now I have to get the blessing from Tomas. The way that I see it, it's like a Dread Pirate Roberts situation. If you're pragmatically minded, business-minded, it will change each time, depending on whether they may or may not be in the audience. I did see him a few days ago, but I was not confident enough to go up and talk to him. So today, it's Tomasism. This is someone who is interested in Ethereum's competitive position. So there's a bit of a repression here. When we say competitive position, what do I really mean? We mean Solana, right? That's the real threat. That's what we're really talking about. So maintaining Ethereum's competitive position, bringing in institutional app orientation, all those strategic initiatives, and thinking very much in the near term, right? So when you think of this Tomasism or Dankradism, I'm very much thinking of somebody who sees the job as like a 2-3 year timeline threat. I do believe this group is Ethereum aligned, to evoke that term. And they have an interest in the values, but they tend to minimize them, and they tend to use very specific language, security, privacy, and censorship resistance, which comes from P. Cav Versacchio's Ethereum Cypherpunk Manifesto, where those are the 3 principles, but we don't tend to get much detail, and we do tend to see certain terms disappearing. Decentralization, permissionlessness, in particular, less and less said by this particular group. Now, I do also think that the pragmatist turn is in a productive relationship with what I like to call the Shawway, or OG cypherpunk, the other imaginary, meaning Vitalik, Shawway, civil culture people who are the long-term thinkers, right? They're the ones who are really obsessed more with the 10-year plan. After this week, so I was thinking okay, what's the best situation that we have at the moment? And I do believe the situation more and more is probably one where we need to stay out of each other's way. It's temperamental. There are people who are more pragmatic. There are people who are practical, pragmatic, leave them to it. And then the OG cypherpunks leave them to it. Don't get into each other's way. And then maybe things will be okay, right? So maybe things will be fine. Why not both, to put it another way? Okay, my favorite group in the more negative sense is this group, the other pragmatist imaginary. Now, if you're not a culture vulture like myself, right, who spends time listening to Ethereum-adjacent podcasts, you may not be super aware of this kind of thing. But there is another imaginary when it comes to Ethereum, post-ideological pragmatism. This is a term that comes from their world, right? It's not my term, they use it themselves. And in this group, I think the core difference is that they don't really care whether Ethereum is second or first, right? So it's not about Ethereum beating Solana, etc. It's just that ETH, the asset, performs. ETH could be in the 5th position and Solana second, but if ETH has gone to 10K and the portfolio has gone up, the post-ideological pragmatist would be happy, right? That's the difference between them. They are also wildly disinterested in the values. They dunk on them on the podcast completely. The famous Unchained headline, crypto needs more builders, fewer values, right? To me, the kind of worst post-ideological phrase. Now, this group, I think, is very influenced by specific media, by crypto, Twitter, and also the podcast. I won't get into it because I can see kind of the time ticking down. The short version is to just say, right, mimetically, my only goal this week was to introduce the term CTVC, Podcast Industrial Complex. And I encourage people to use that term as much as possible under their posts. They are onto me. They've started to follow me. And they have endorsed Blockworks Extended Universe. So now I just need them to endorse CTVC, Podcast Industrial Complex, and all is done. So what is the mindset that you will see on these podcasts? Well, for me, it's very familiar. It's business school thinking. So I see it as a business schoolification of a crypto culture. So I'm a business school lecturer, so that's, I can see that they were business students or finance students who are now applying the kind of thinking to our way more interesting polycentric cultural imaginaries, right? They're trying to reduce us down to business school. Do not let it happen, right? You do not want to exist in a world that's like KPMG, Deloitte. That's what we're escaping from, right? So how do they think? They think ETH is a product, right? We just figure out like what ETH is as a product, everything will be fine. That is Ethereum's primary mission, according to John C., and that's not how I see it. So ETH is a product, the Ethereum Foundation is a company, right, in this thinking. Ethereum itself is a company which has revenue, right, real economic value, the cursed term of the Blockwork Extended Universe. And then North Starism, a startup cultural term. It's from entrepreneurship and marketing. My colleagues used it for many years, and I was really surprised to see it actually turn up in our world. So we have to reject product thinking, we have to reject company thinking, and we definitely have to reject North Star thinking, if only because they're too bland for us to live with. So don't let it happen. Okay, that being said, this is my things I thought about this week. Slide, so it doesn't really fit, it's just thrown together very, very quickly. So it is clear, right, that we have these post-ideological blockchains, at least when it comes to Solana. So what should we do? My position is we need to be aware that defections are coming. Nick is the canary in the coal mine. It is almost certain that people are going to begin leaving for Solana over time. Also, I think we need to be aware that there are these Solana super teams, right? These Solana super teams embedded in places like in Dublin, where every day I go to the hacker lounge and there's maybe like 10 people there. They're all under the age of 25. They're a permanent presence. They meet every Friday. We need to have something like this. And then a warning from Bitcoin governance. If you want to see what's happening in governance, look at Bitcoin. It's always 2 years ahead of Ethereum. And while it's good that the Ethereum Foundation is taking on this very robust and muscular role and so on, that's only going to work until people kind of turn on it. So we have introduced into our sort of sphere something of the populist versus elitist dynamic, and in Bitcoin at the moment there is currently a populist revolt against the elite, and that's going to come for us at some point. Okay, so I'll end here just by saying if you're writing today, it would focus on the new governance process, a wider stakeholder set to interview. We talk about Solana and we talk about the pragmatist imaginary, but it being academia, you can expect to see that in maybe like 3 years or something like that. So, okay, I'll leave it there. Thank you.
We're going to forego questions and let Paul go. Thank you so much, Paul and Anne, for those 2 fantastic talks. Thank you so much. Real-life Ethereum ethnographers. How cool is that? All right, so next up, we're going to continue the theme of having more philosophical kind of social discussions about Ethereum. And we're going to bring up onto the stage Alberto Granzotto to talk about designing decentralized treasure hunts on Ethereum. Give it up for Alberto.
Buongiornissimo, Dapcon. How are you doing? It's quite bright in here. I get a bit more tanned. So my name is Alberto. You can call me Albi. And today I'm going to talk about how to bring THC to the EVM, or how you can design decentralized and on-chain treasure hunt challenges on Ethereum. Before we start, a few words about myself. I'm a time traveler at Social Distortion Protocol. I'm also the founder of the Ethereum Foundation with an I. I invite you to join us. Go to the website and there is a link to our Telegram channel. I'm also a freelance software engineer because it seems you need money to live in this society. So I work with artists, and with them I develop on-chain fine art, and also with lawyers, and with them I develop also legal DAOs, let's say. You can find a list of my works on my website, granzotto.net. But let's go back to Social Distortion Protocol, or SDP. It's an organization established in the year 2045 that is in the future for you. And our future is broken like beyond repair, so there is no way for us to fix it. And what we do instead is we time travel. We time travel back in the past, that is your future, sorry, your present, And we do like this kind of experiences to show you how the future looks like if you don't fight. And some people call this kind of experiences game, some other people call them art. We like to use the term experience. And the experience I want to talk about today, it's an experience we really, really like that is called THC, or Treasure Hunt Challenge. A treasure hunt challenge is also called scavenger hunt, but it doesn't allow you to make any fun like acronym with it, so we went for THC. And it's a game that you play on a physical space, can be like an event, a conference, a building, a neighborhood, a city. The game is built around a narrative, and it's organized into levels, like many classic games. You go from level 1 to so on till the end. And your goal as a player is to solve physical puzzles to progress throughout the game and to finish the game. This is a high-level structure of how a treasure hunt looks. You have a master plot that is surrounding the whole game, and the game is divided into chapters. The first chapter is, of course, chapter 0, and where you have, inside that chapter, you have a quest that is some text that gives you the context of the story and at one point points you to a puzzle. A puzzle is a physical, most of the time is a physical thing you need to find and solve it. And once you solve it, the puzzle will release you a solution that is just a piece of text that would allow you to move to the next chapter, and so on. We have also side quests, so some chapters, they have these other things you can solve to gain more points, but they're not needed to finish the game. While if you want to finish the game, you need to go linearly from chapter 0 to chapter n. One very important thing for us as game masters is the onboarding. The onboarding is the process of taking an attendee at an event and convert them to a player in the game. And instead of, again, attending the event, they will then just spend time with our puzzles. We do this by crafting letters and envelopes that we hand out to people at the conference. And you receive this letter, it looks kind of nice. Inside there is this letter that is inviting you to play the game, and you will find also a link that will, when you open it, will open our Dapp, where part of the game is developed. And we use this kind of envelopes, also these other ones. I don't know if you, any Germans here, if you have this one in your mailbox, congrats, you're a bad boy. The game works like this. So after you open the letter, I said that there is a URL. You open the URL, 99% of the time you open it on your phone. And this is where the game starts. So you have the onboarding phase that I just described. Then you open the website and you start reading the first chapter. Then you locate the puzzle, and ideally you solve the puzzle, you get the solution, and you use the web application that is on the left side here to submit the solution. And then the game progresses to the next chapter where you will read again a new part. You will read the quest, find the puzzle, solve the puzzle, and so on. There are some nice side effects to this kind of experience. So first of all, you explore the venue. The game, again, develops over the venue. For example, it can be an event, as I said already. And we make the game so each chapter will touch a different part of the location. You also connect with others. And we had so many examples of people that started the game by themselves, and they ended up finishing the game in a team. And even most important, you learn new things. We have people doing lockpicking for the first time because they had to solve a puzzle, or also people starting creating their first smart contract on Solidity because they had to hack, let's say, for a side quest, a puzzle that was on the Ethereum blockchain. And I want to keep talking about the puzzles now. And this is probably the most time-consuming part for us as game masters to create a nice THC, because they are in a way connected to the location where we deploy the game. This was at ETH Berlin, and it's a ball pit, and we put some balls with a password inside, and you had to basically spend quite some time to find these special balls in the ball pit to find the password. Or this is actually super fun. It's a chessboard And you had to solve a chess puzzle and move the pieces physically on the board to make the board automatically open. Because we had some RFIDs under the board, and again, we like also to play with hardware, and this is what this board would do. This one is one of my favorite because it's quite weird. You have a keyboard, MIDI keyboard, connected to a birdhouse, and you had to play the right tune in order to open the door of the birdhouse and get the password. And everything we do is quite do-it-yourself. Some people mistake what we do for bombs, but this is not a bomb, in case you were wondering. Or this other one is called the Vibrator. That is, I think, the first sex toy connected to the Optimism network. And you had to interact with a smart contract in order to activate the Vibrator, and it would vibrate you in Morse, the password. So you had to hold it in your hand or somewhere else to get the password to get to the next level. Thanks. And of course, like, this game is played by many people at the same time. And it's also fun to see where you are at compared to the others. So we developed also, of course, a leaderboard where you can see all the addresses at which chapter they are, and also how many side quests they solved. And once you finish the game, or you finish all the side quests, we also release on-chain art, on-chain NFTs, developed by some artists we collaborate with. And again, what we love on-chain stuff, so also the NFTs are on-chain SVGs with no external dependencies. We run these, as I said already, we love THC, we love this kind of game, and we released the game several times over the years. We started at the Congress, the Chaos Communication Congress, and then we also deployed the game at ETH Berlin 3 and 4, and DevCon 6 and 7. And we did this also, I want to mention Daedalus Industries, that is another organization, and they developed all these crazy also like hardware puzzles that I also show you in the section before, and also really they're quite amazing. But today I want to talk a bit more about THC as in Treasure Hunt Creator. That is the open source framework that we developed to create this THC, these treasure hunt challenges on the EVM. It's open source. You can find it on our GitHub, social-distortion-protocol. The 0 is very important. Otherwise, you go to our competitors. And /THC. The framework is divided into two pieces. There is a dApp, that is the front end. And there is also the back end, that is the smart contract. There is nothing else. So we don't have any other servers spinning around. It's just like these two pieces. We try to keep things as, again, on-chain and decentralized as possible, so we avoid having our own servers, let's say, running the game. The experience from the dApp, as I said before, the dApp is your navigator. It's what you use to explore the game and go from chapters to chapters, and also this is what you use to submit your passwords, so your solutions to the puzzles. When you first open the game, with the web app, there is no registration. So you start, and you're already, in a way, registered because we create a burner wallet for you on the phone. And given that it's a burner wallet and we don't have the address ahead, there is no balance in this burner wallet. But in order to submit solutions, we just use Gelato Relay Network. So we sponsor, basically, your transactions that are sent to our smart contract. So you need nothing. You don't even need a wallet installed on your phone if you don't have one. And the other thing that is also important is game assets. As I said, we only have two pieces, the dApp and the smart contract. So the game assets are built in the front end in the dApp. And I remind you the structure of the game. So you have each chapter has a quest, a puzzle, and a solution. And in that case, given that everything is, again, in the front end, in the dApp, you don't want players to be able to read the chapters that they're going to play later. So what we do is we take each quest and we encrypt it using AES with the solution of the previous chapter. So chapter 1, the text, is in your dApp, in the dApp, but is encrypted with a solution. So if you don't find the solution, you will never be able to access this kind of text. On the other side, we have the smart contract, and as a reminder, we have, again, multiple solutions, solution 0 to solution n-1, because the last chapter doesn't have a solution. And here, we are analyzing how we're putting the solutions in the smart contract. Of course, we cannot put this solution in clear text, because otherwise you would be able to decode it from Etherscan or any other tool you want. So what we do instead is this. We take a solution, let's say solution X, and this is something we do offline before publishing the game, of course. We take solution X and we hash it using kekak, and we use the hash to create what we call a solution wallet. So we initialize a wallet using the hash as a seed of the solution. And we have two things. When you have a wallet, you have a public address and a private key. We take the public address and we stored it in the smart contract. And after we do this process for all solutions, our contract is ready to be published. So keep this in mind. We have a smart contract with all the addresses of the solutions on-chain now. Then there is this other phase that is the submission phase. You, as a player, represented as a nice pink skeleton, because maybe it took too long to find the solution. And we run on the front end the same algorithm I showed you before. So we hash the solution using kekak. We create a hardware wallet, but this time, instead of caring about the solution address or the public address, we care about the private key. Why? Because we needed to sign the address of the player, so the burner wallet I told you before. So we take the wallet of the solution to sign the player address, and what we get is a proof that that player found that solution. So we take this proof, RSV, and then using the wallet of the player, we submit it to the smart contract. At this point, the smart contract starts the verification phase. And what happens is that by receiving this RSV, this proof, the smart contract is able to run an EC recover using as data the player address. And at this point, the smart contract is recovering the signer. And if the signer is a valid solution, then the player can progress to the next chapter. Otherwise, it's rejecting the transaction. And this is crucial, again, because we don't want solutions to be public on-chain. And this is some kind of, I guess it actually checks all the check marks of a zero-knowledge proof. If not, let me know. But for me, this sounds like zero-knowledge proof. It's not super fancy. I mean, it's just public key cryptography. But still, it works very well. And it's very cheap in terms of gas also. In order to prepare all the game assets, publish the DApp, and also deploy the smart contract with all the solutions, as I said, encrypted, we need to, there is a lot of tooling. The process is actually quite complex. There are different steps you need to do in order to deploy your own treasure hunt challenge. And we don't want you to roll your own THC because it's too complicated. So we developed another framework called CBD that is the THC companion. And CBD stands for Continuous Build and Deployment, and this is another part of the framework that you can still find on GitHub, on SDP/CBD. And this is taking care of, basically, all these intermediate steps you need to publish the game. There is one thing that is actually quite crucial. When you deploy the game, and all the quests are basically in the front end already, and maybe you need to change something because something is not clear, or like a quest is not as clear as you think it was, or for example, something changed in the venue and you need to modify a part of a chapter. All these small edits, they require the pipeline to be run again, the pipeline to build all the assets. And CBD is taking care of this part, basically rebuilding all the game assets, and publish everything on-chain. That's all on my side. I have 2 minutes left. I will quickly, can I go back here? Yes, nice. I want to quickly mention that this kind of game is also a DIP, that is a DevCon improvement proposal. I invite you to check the original proposals here. This is from 2020. This is DIP 4. Same year, 2020, there was DIP 11 by Daedalus Industries that I mentioned before. And they submitted also improvement proposal for DappCon to create this kind of escape room, crypto onboarding escape rooms. And then in the year 2024, we decided to merge our efforts, so SDP and Daedalus Industries, to make more like a wider, let's say, proposal called the AP36, that is game of capture and escape, that you can also read at that URL. And now I'm really done. Yes, you can find me on Twitter at VRDE, and if you want to follow SDP, go to Distortion Proto, where the first O in distortion is a 0. That is crucial. Don't fuck it up. Thank you, guys. Take care. Questions, though?
Yes, we have time for questions. How did the Zuckerberg hunt go? Did you find Zuckerberg?
Yes,
you
again,
did.
we found Zuckerberg. That was the very first game we deployed. It was not exactly this format. It was more like a geocaching. So you had to find QR codes that were hidden in the event, at the Congress in that case. It was a primitive version of THC, and it was very simple, but people love geocaching, and that was the original, let's say, the seed idea that also guided us to create these THC games.
They just had a geocaching treasure hunt in San Francisco that they were talking about on the news. Someone won something like $10,000. People love geocaching treasure hunts. Yeah.
In our case, you don't win $10,000. People are also happy with, like, I don't know, once we gave as a prize a piece of wood. Mm-hmm. I mean, it's nothing, but given that it was part of the game, for whatever reason, they liked it. Stickers. But, I mean, if you play these guys, don't expect to win $10,000. That is not even the money we make, so it's also quite expensive on us to make these kind of games.
Yeah, of course. Any questions for Alberto down here?
That was a great talk. Thank you, Alberto.
Thank you.
I remember a year or so ago that there was Crypto the Game or something like that that became very popular. It was even acquired by Uniswap or something like this. So it seems that playing these games with on-chain mechanisms is becoming something of a trend. Would you say that? And like, where do you see the future of social distortion going? Like, what's your idea to maybe scale this? Or maybe you don't, maybe it, you know, what's your vision?
So, first of all, we have no vision. That's also part of SDP. We don't have, we just live day by day, to be fair. We have another game we deployed time ago that I want to do again. We like this idea of like on-chain pop-up games. And what you mentioned before, by the way, try to answer your question about on-chain games, I think is a super cool trend. There are people doing a lot of really cool games, on-chain games. What we like is this kind of on-chain games that you play in a real physical space to connect with other people. So we want to focus more on these kind of experiences. And if we have, let's say, a plan for the future, is try to develop more these kind of ideas of in-person on-chain games, because I think they're quite fun.
Other questions for Alberto? If not, we'll let you go. Thank you so much, Alberto, for such a great talk.
Thank you.
Take care. See you. Ciao.
Thank you, guys.
We'll take a very short little break, and then we will continue. I'm calling this track The Relational Aesthetics of Ethereum. I think that captures the talk so far. So we will have another great talk in about 2 minutes. Ethereum ecosystem, please welcome to the stage Pentacle.
Hello. It's still very bright, by the way, that light. It's still really, really bright. Hello, I'm Pentacle, and full stack devs suck at design. Right, I'm just going to try and find this button here. It's the green button. I can save them. I have saved them in the past, and I can save them again. So the problem is that I can't see my slides down there because I don't have my glasses on. So sometimes devs make design decisions just because they can or because they have to. That can mean that your app's going to go completely off-brand, looking at you, Lawrence, with your squashed logo. It's gone like that. You can get weird UX patterns. And when I worked with developers before, I heard this term bike shedding a lot, didn't really know what it means, but now I do. So you can go off-brand when you have this many colors to choose from. It gets confusing. You have to remember them all. This is a recent incident we had, actually, at work. Don't put form inputs below the submit button just because you can or because someone else did it. And I tried to get ChatGPT to draw this up for me, and he refused. So actually, sometimes the AI is right at UX, and your full-stack devs aren't. He was trying to draw all the form bits below the submit button, but refused to put it on the screen because it should never go below the submit button. Now here's a good story I heard yesterday as well. UX to the developer, here's my design. Dev, no, I think we need to move that icon. UX, well, this is the logical placement. Here's the design system that's in place, and here's the reasoning behind it. And the dev was like, well, let's get AI to make the final decision, not the designer. Why are they there? How do I know this? So in a previous life, I used to work in enterprise software, and my job was to clean up divs, basically. I removed a lot of Bootstrap, and I put in semantic HTML and hand-rolled CSS, basically. And so what that did was we were taking away all the design choices away from the developers so that they didn't have that cognitive overload, also so they didn't fuck it up, basically. And the result, people stick to their jobs, designers do design, developers do the development. And why does this happen? Well, just because you can, you control the code base, you know, you're the developers, doesn't mean you should. If this piece of graphic design here doesn't make any sense to you, then you're not a designer, basically. Then don't do design. So how did we get here? Well, how did we get here? We have the tools, we just forgot how to use them. Because HTML is only for junior devs, and real devs just use lots of divs, which is why God invented JavaScript. And you can see here, actually, the HTML person is just the HTML guy, and to be a developer, you have to be full stack or better. Otherwise, you're just the guy. So, click. Here we go. But where we're going, we do not need 3 UI libraries to build our apps. That's shadcn to do an accordion. Or, actually, you can make one with semantic markup, and then you can put your styling in your global CSS, and it makes your code a lot easier to read. Cognitive overload for developers is massively reduced. You can see what you're doing. You don't have to scroll all over the bloody place. But also, CSS is also just for juniors. So God had to invent styled components to make CSS difficult as well. And things like CSS and JS, because otherwise you're just the CSS guy, not the full stack developer, who is more important. Right, yes, and this is, I have seen so many code bases where you have your TypeScript files, oh, sorry, I thought that was seconds. You know, you've got all your TypeScript files nicely arranged in your big directories, and in all of it, you've got your index.tsx, lovely, all very nice and organized, and in those, you have a style.tsx file, and in each of those files, you have every piece of UI in there, so you could have one button in every single file. I've seen this happen. Because there's one on one page, and they're like, well, we'll have 12 instances of our button-styled components, and then you start getting drift. And that's when your design starts cocking up, basically. And so I'm here basically to make life easier for developers. If you make things less complicated, your design is going to look great, and you don't actually have to design anything. And we also have a new entry in our full-stack developer portfolio here, should we say, of devs. We have Claude, who loves to add lots and lots of markup to your code. So I have now trained Claude it's illegal for Claude to add a font color, padding, or anything like that. It's just pure semantic markup or JSX. I get a load less cruft in my code, and it looks way better. I'm like, look, mate, look at the CSS, don't touch it. We don't end up with lots of different designs. So it's a global CSS, or get out of here, basically. The design just happens. If you want fancy stuff, you can do your magic sparkles and your beautiful 3JS. That can all come later. But the way I design is I basically get a wireframe into my app, get people to test it. So a little primer here. If you're sort of a developer, you don't have a designer sometimes, this is just a good little checkpoint to look at. As little design as possible is the main one, and everything else basically falls out at the back of that. So, excuse me, just going to have a sip of water and shake like a leaf. Anyway, I'm fine. Yes, so great little checklist here if you're particularly a developer with no designer. But here's our CSS guy. Now, it's amazing what he can actually do. So as I've said, I work purely with semantic markup and CSS. Global CSS means that the designers can take ownership of that, or somebody who's in charge of design. The instant design comes out of the box, basically. Oh, what's that? Lets the developers go fast. You don't have to wonder about overload of design choices. What's our brand color? I've forgotten which tailwind blue it is. And then also on the design system that I'm building, I've put in minimal utility and layout classes so that we don't need tailwind. Tailwind has got very weird lately. I can't operate it anymore. It's very complicated and lots of different bits of code I have to add just to create my own classes. And then variables for app customization. So if you have a suite of apps, for example, you can change it pretty easily. So we're going to go through this list of what is good design and how does CSS and HTML assist that. One moment, caller, for a drink. Right, that's better. So, being innovative, well, what you want to do with your products is get PMF, basically, the mythical crypto PMF. So in order to get that, you want to test early. And in order to test early, you want to get your app out fast, instead of languishing over it and going, oh, it's not perfect. This is what CSS can do for you. I actually built these basic tabs out. Sorry, I can't see that. My eyes are not very good. But I built these tabs out just using CSS. They're actually radio buttons, a bit weird. But it's super lightweight code. And you can see here the markup, it's not full of cruft. There's not like a million tailwind colors and shadows and drop downs and all sorts of that kind of thing. You can see what you're coding, it makes you fast. You get out to test early and you can embarrass yourself in front of your users. So this is what I'm working on at the moment. The old Pentacle project has become Searchable, if anybody knows of Pentacle. Not just me, a project name too. So we have one minified CSS that rules them all. I haven't actually put it in here, but the CSS is broken down into element names, and then it all gets bundled into one. And then each app has theme variables so that we don't kill everybody with boredom, having the same design for every single app. We can change things at this global level, and then at a local level, basically. And also just really easy to do dark and light mode, which is normally really hard and complicated. But CSS, if you're minimalistic with your CSS, you can do it very quickly. Oop, right, sorry. Anyway, quick tip for developers, function first, bring your code to the surface. I also do quite a bit of back-end work as well with data. And I just like to think about how that interfaces with my front end and how much front end I can actually get rid of to let the back end come through, because that's actually what people are interacting with. It doesn't have to be all about design personality. Your brand can be very simple. Don't design it, let it design itself. Here's an example of that. I mean, it didn't really, but it's about taking things away. Get your product working and then see what it's telling you, and take away as much design as you possibly can. So good design makes product useful. Yes, so this is kind of referring to the product in the product, so I think about my CSS library as a product. So inside the product, empowers devs, like it gives them more time, it's less confusing, you don't have to think about design, you don't have to think about centering divs. Horizontally and vertically, it gives designers control over things like color palettes, make it super simple. You can control like global border radiuses, global padding, all in one place, which then in turn tidies up your design. And it's self-explanatory because even junior developers know HTML. So, boop. This is just a quick drive-through slide. Don't let your users get away. So make your product useful. Put your information within your interface. Don't let this guy here go off to your marketing website or you'll get on. Bye. Aesthetic talks about this. So that is basically how I control light and dark mode, super minimal amount of colors. Your design will look way better. Make things minimal by default here. That's a card that's used across multiple apps. And it's a few lines of code, basically. Then you can add some chaos. Once you've got your wireframey grid stuff in, then you can kind of add some swooshy animations and make it weird and interesting and a bit overloaded, that one. Right, this is an example of very simple design that had a bit of chaos added later. This actually took 2 weeks to build. And it's really simple. It's 3 pages. It's in Helvetica, but all the work went in, and this was going to be animated, but that was too dangerous. So, but this is a piece of 3JS that's quite a long animation, and it's got a very specific film grain effect over it. So that's where the energy went into after we really nailed the design down to literally nothing. Right, yep, so making your product understandable, again, kind of product in the product with your code base being part of that, make it understandable. It's a lot faster to be able to code semantic HTML, means you don't have to make up styled components and invent a new taxonomy that may not line up with what the business thinks, and then everyone has to learn a new language. With all millions of divs as well, things just get confusing. So semantic HTML actually gives you so much just out of the box. That's my continuation of the He-Man theme about brand colors, got cropped off there. And also with semantic HTML, you just get accessibility out of the box as well. And also for people who are using keyboards to navigate or sight impaired, again, their screen readers can read semantic markup. They're not reading your divs. Yep, quick tip also, follow, where's my screen? Sorry, yes. Follow human patterns, eye tracking, things like reading books. It's kind of a well-known design pattern. Start up there, read down, finish the page, press the submit button at the end. Don't put the input after the submit button. Good design is unobtrusive. This is Viper that we did last year. And it's just a very simple grid. It's got a simple animation in it, super old school, UL, LI for the footer navigation. And to give it that elegance, we just put a simple scroll behavior smooth, no JavaScript required, good old HTML, and it looks very, very nice. Keep your design honest, be upfront, tell your people that you've all unsubscribed them, basically. Oh shit, I'm running out of time. So be upfront, don't hide information, don't do dark UX patterns, never pre-select a radio button, that's the worst UX crime. Good design is long-lasting. This is from 1923. And HTML also is never going to go out of fashion, as Tim has proved in his motherfucking website. There's no dependencies. It's just going to run, basically, and it works. There's no buttons, though. So good design is thorough down to the last detail. Again, just create a simple grid. Don't have millions of different paddings and alignments that Claude has given you. Just strip it all out, basically. Literally have nothing, and it will look better. Here are some examples of that. You can see where the H1s are. You can be a bit weird with design. Grid system is a good example here of just like design is aligning up. Oop, right. Be environmentally friendly. You can have a small amount of code. Less is more. There's a tiny amount of elements on that design, but an element of being handmade makes it interesting. So this means that you can be consistent. And as backend developers, or whoever you are, you can just get away with a handful of colors, and it looks freaking awesome, really, and you can use your code to inspire your front end. But I have ideas. No, don't. Just remember, as little design as possible. But also, as John Maeda says, great design makes things clear. But simplicity and complexity also need each other. So again, that's back to that principle. Start with something really simple, and then add some beautiful design elements. This is something I did for Joseph. Sneak preview. You can see just H2s and paragraphs in here, but a fiddly CSS for the borders so that it works in responsive, so you don't get double borders. And again, this is all completely stripped back to absolutely nothing, and a handful of CSS, basically. So that's it. I finished early. I erased the last slides. Yes, remember, you can just not design things. Thank you. Thank you very much, West Ham. That's not a step. Oh.
Do you want to do some quick questions, or it's totally up to you?
Questions?
Do we have
Why is
any
your
questions?
logo squished on your website? Yes. I know, it's okay.
You're behind some of my favorite designs in Ethereum, so great to have you on stage. If we don't have any questions, then we'll let Pentacle go. Thank you so much.
Thank you.
We'll take a quick 5-minute break. morning. We have Florian Glatz talking about hope and reclaiming Ethereum's future. Please give it up for Florian.
Thank you. Hi, everybody. Thanks for showing up at this early hour. So I was asked to talk about whatever I want, and the reason was that about a year ago I held a talk at the Ethereum 10-year Jubilee meetup, where I was not all too positive all the time about, Ethereum, from a good place, obviously. And so I guess I'm invited to just share my thoughts on, how I see what's happening. I hope it's interesting. So it starts with a little bit of history. Being in crypto used to be really simple, at least when you joined early. You would just go to local Bitcoin and Ethereum meetups to find other lost souls who had really no desire to have a normal job. And it was really a unique experience. I just shared 2 photos here. One, literally on the day the network launched, we had this big rainbow on the sky over Berlin. That was kind of cool. And then shortly thereafter, I was on an Ethereum meetup, and funny enough, Meinhard, who's standing there in front of the network dashboard of Ethereum, now sits here in the first row, so that's very cool. Hi, Meinhard. You were the leading miner, I think, on the Ethereum network back then, for like a few weeks. So it was simple to be in crypto because there was no moral implications, I feel, at all of doing this. It was a nerdy hobby. And I feel this has changed, and I want to just sort of linger a little bit on how it's different now to be in crypto. And I feel there are more ways than ever to do harm when you touch this technology. And to some extent, you should be able to harm yourself when you touch crypto, because you're only truly free if you can hurt yourself in whatever you do. But I think what none of us really had on the radar is the fact that just by swapping tokens on Base or using Coinbase to cash out, you're now paying for a military parade in the United States, right? That's kind of weird. I didn't expect this to happen, and obviously there's probably a lot of context why Coinbase did it, but in the end they still decided to sponsor a military parade. And I just remember how there was an ethos in crypto that was like universally shared, which is like, we don't like physical violence and the monopoly on violence by the state. So pretty awkward. Now, I want to raise the question, how can we reclaim Ethereum's future? And I just want to say off the bat that I don't have any answers either. I don't really know, but I have some opinions, like probably most of you, and so I'm going to share them. Since I started this space, everything was always very technical. I tried to condense it into a formula, what I think Ethereum could use more of instead of less for the next 10 years. And I sort of condensed it into humility, openness, and plurality. And I just want to share what I think these words could mean here. Starting with humility, the reason I got, I think, one-shotted by Ethereum back in, I think, 2014 when I heard about it, was really Vitalik's epistemic framework that he developed posts. It just totally blew my mind how differently you can look at the world and understand things, understand causal connections between things, be it in finance, philosophy, how the internet works, accounting. Like, he was able to synthesize things in new ways that created genuinely new explanations for why the world is how it is and where we should go. And today I feel we kind of forgot a lot of that, and we're like in this, to me, low IQ range of like fighting about cypherpunk and DeFi punk and the current thing punk, and I'm like, what the fuck is even cypherpunk? Like, is it even a good ideology to adopt? I mean, I don't know, I'm not a historian on cypherpunk, but when I read, my Twitter feed, it's everybody's saying, yeah, Ethereum should be more cypherpunk again, or now it should be DeFi punk. It's like, what the fuck is this even, And the best, I think, epistemic framework that I found in my I guess, 40 years of being on this planet, is what's being referred to as fallibilism or a fallibilist mindset. I stumbled upon it through David Deutsch, a really great philosopher and physicist. He co-invented quantum computing in the 80s. And it's the idea that you can be infinitely optimistic in this world just by virtue of the fact that errors are discoverable and fixable over time. So just as much as problems are inevitable, so are solutions, provided that criticism stays free and knowledge remains conjectural. Meaning, as long as we stay immune to any kind of ideology, be it, socialist or fascist or cypherpunk or this punk, but we just stay epistemologically humble, we can solve every problem that comes our way in this industry. And I don't understand why we need to play the stupid game of trading one ideology for another. I just don't understand it. Next one, openness. Obviously, Ethereum is an open network. I think Ethereum is one of the most open infrastructures you can find on the web to build on. Obviously, that's its premise. At the same time, I feel over the last 10 years, we've acquired some sort of neo-institutional rot throughout the industry, which means like this layer of professional careerists and middle managers who just gatekeep things, I think, in this ecosystem. So I don't want to go too deep into this because it's a complex topic and to some extent unavoidable, but I feel we have too much gatekeeping in Ethereum, and I think that might be part of the reason why other ecosystems seem to be accelerating faster at the moment, because maybe there's less gatekeeping in other places. Just putting that one out there. And lastly, plurality. This is something that sort of has been with me, lingering with me now for a while, and obviously there are books about plurality, and I'm far from an expert on this philosophical stream of plurality and so on, but I do think it's important. I want to mention it here. Here's a picture of David Clark. There's this famous interview, I think from 2012 or 14, or I don't know. He's being interviewed on Bitcoin. And in this short segment, he says, well, what I learned as the designer of TCP/IP is that all things that we think of as specifiable or technically constrained very quickly end up embedded in a social ecosystem, which in some sense defies the simplicity of the protocol that you've designed. And I feel in crypto and Ethereum, maybe specifically, we've always had this expectation that just by virtue of designing a simple protocol that has, some incentives maybe well aligned, we now solved, the real problem of rolling this out into the world. And we have not. And I feel Ethereum, if anything, should become more embedded in the world and, adopt a more pluralist mindset and not be so dogmatic, which goes back to this epistemic humility about, well, is it fully decentralized? Is it not fully decentralized? Does it follow this current dogma or that current dogma? I feel this has been holding us back now for too long, and I think we should be more open to various ways of doing things. So that leads me to this Ethereum slide, which sort of looking back, obviously it's not a correct or the only way to look at the last 10 years. But I feel that in the early years, 2013 to 17, we really rewarded the early believers in this idea of a new settlement layer, decentralized, open, permissionless, and programmable, Turing complete, right? That was the one differentiating factor to Bitcoin. In 2018, we rewarded the early, DeFi plumbers laying the financial pipes to make it possible to swap the tokens, to take out loans, all that stuff. Afterwards, we rewarded, and I think most recently we've seen it with stablecoin issuers, the people who really believed that we should bring fiat on-chain and stocks on-chain and securities and all the stuff. I feel these people are being rewarded now. And the open question is, well, who will be rewarded next? What do we want to see in this ecosystem develop more of? And I feel that if we blindly follow down this, cypherpunk stuff, I'm not sure we're making the right decisions. Because at least, and that's probably very debatable, but this idea of, trust no one, verify everything, only trust in the numbers, might lead us to build a low-trust society as opposed to a high-trust society. But I think we're all much happier as humans in high-trust societies. And there is this paradox in crypto where if you have a high-trust society, you probably don't need a decentralized ledger in the first place, right? You could do it, right? You could count stones like people did it thousands of years ago instead of, having some ledger in the cloud. Paradoxically, I think the way the world is developing, we need to develop infrastructure where you don't have to trust no one, but I'm not sure it's a good North Star to have culturally and philosophically in terms of what kind of society do we build. So I feel the opposite of trust no one is build bridges. And I feel Ethereum needs to build more bridges. Personally, I've been a bridge builder in this space now for 10 years. And it's been fun and frustrating. The first, bridge building I've started doing was back in 2017 when I founded, I think, the first crypto lobby organization in Europe. I mean, it was in Germany at the time. And then a couple of years later, I founded with other great people here in Europe the first, I think, community focused crypto lobby organization in Europe, in Brussels, called the European Crypto Initiative, EUCI. And we've been building bridges to regulators where, most people in the space think it's not worth talking to regulators. We've been educating them on DeFi and, giving, spend thousands of hours in calls and meetings with regulators, explaining them why what we do matters and why there is some deep moral truth and justification in what we do, like some inherent goodness that this world needs to sort of move forward. And with this kind of signaling, we are able to reach people far beyond sort of what we should be able to reach and impact, which is great. And lastly, sorry for shilling my projects now, I suppose, but that's an example of what I consider bridge building is a Web3 social application that I've been now developing for over 3 years called Common Ground. And the idea of Common Ground, again, is to bring people from all over not just crypto space, but kind of the Web3 space, together on, in one environment, in their own communities, and be able to, collaborate better, exchange knowledge, and retain knowledge better, and so on and so forth. I feel building bridges in Ethereum has been a pretty, ungrateful job for the last decade. I don't want to complain, but I think there wasn't too much support. I think now might be the time where we want to, spread our aperture, make it bigger, and bring, more attention to these kinds of efforts too, not just the technical development. That's pretty much everything I wanted to share in this little talk. Thank you very much for listening, and happy to answer any questions if you might have them. Thanks.
Thank you, Florian, for your provocative talk. And any questions? Right here, down front. Just, here's your microphone.
Hey, Florian. Thanks for the shout-out. So do you think you moved the needle on regulation, or did you just kind of spend a lot of time and they were like, thanks, but we'll do it the other way?
Actually, yeah, we did move the needle a lot. Let me pick two examples. I think the biggest one is that we managed to exempt decentralized finance, so DAOs, decentralized protocols like Aave and so on, to exempt them from this regulatory burden of this European regulation called MiCA that entered into force earlier this year. There is a paragraph in there, recital 22. It's not even a real paragraph in the text. It's like a preemptive exclusion that says, well, if your project is not operated in a centralized way, but fully decentralized, you can ignore this entire regulation and continue doing what you do in this sort of illegal space, as Gavin Wood called it. And that's kind of ridiculous that we achieved this. to me, because, I mean, crazy. So yeah, when I think about that.
Did you write those lines?
Pardon me?
Who wrote those lines?
So I wrote a long report on how this came into the final text. The suggestion came through the Portuguese team inside the council. But then how did the Portuguese, so there is a long chain of causality how to find that. But I would love to actually share this. I've long thought that crypto should have some sort of, retro PGF, but for public policy impact. Frankly, we were told that this would not be a good idea because that would make political outcomes sort of purchasable or sort of like monetize them. I understand that viewpoint too. So I don't really know how to solve this. But yeah, thanks for asking that question. That's a great question, yeah.
Other questions for Florian? One of my favorite aspects of Ethereum culture is its willingness to critique itself. So thank you so much for your great talk.
Okay.
Please, a round of applause for Florian. And next up, we have a talk from Denise Holm on funding in the Ethereum ecosystem. So please give it up for Denise.
Hi. Hi. Good morning or guten Morgen. I'm Denise. I'm co-founder of Divvy, and I'm here to share a little bit about our thinking around builder funding. So, I'm glad you can see these slides. So, as an ecosystem, as a community in Web3, we know that billions of dollars have been given out to as incentives, grants, programs, retro funding, hackathons, to fund builders over the last, 10 plus years. Yet, we know also that all those builders that have received funding have kind of failed to deliver the user adoption and the on-chain usage that we expected from that funding. And so we have billions of dollars spent or euros spent, and there's no product market fit. Users still don't know where to get started, how to join, and how to start getting value out of this ecosystem and all the products we've created. There's only like 30 to 60 million crypto holders, so these are really passive individuals who hold crypto, and a very small percentage of them, you can see on this chart, are actually active trading, exploring, and getting value out of Web3 every day or every week. So what's the problem? The problem is that grants are not rewarding the long-term impact and delivering the products that we want or we envision will bring the users into the space. Billions, again, spent, hackathons, organized, a lot of overhead. We see this quote here that after 2 weeks or a couple of months after Bangkok, DappCon, there were only 2 out of 80 dev participants in a hackathon. They're still actively building, right? So we have created this culture of bounty hunting in hackathons. So what's also happening beyond hackathons is that the grants process has become really political. It's very subjective and resource intensive. The builders that are rewarded, they are the ones that maybe know people on the grants teams that evaluate and make decisions on grant disbursements. They have to do a lot of networking. They have to become really good writers. And all of this is energy and time that builders are spending on navigating the grants process rather than building and innovating on UX to deliver the products that we want. So what we've come to the conclusion is that Web3 has a growth problem because it has a broken incentive system. The incentives that we've been putting out there, they are rewarding the wrong behaviors, and they're creating an unsustainable growth loop for Web3. So let's talk a little bit about this Web3 funding trap. The first part is that, as I mentioned, the grants programs, hackathons, they're not really delivering the incentives to those that create value and are driving on-chain usage. They are funding the incumbents, so big projects that have an early mover advantage or that have great connections within an ecosystem are the ones that get funding the most, and then they are the ones that are able to move forward and continue innovating, leaving others behind. So the builders that are left behind, the smaller builders, the ones that are trying to get into the space, they are focused on optimizing for grants, right? If we think about a hackathon, there's so many bounties at a hackathon, and hackers try to build products that apply to, or apps that can make them eligible to apply to as many bounties as possible, rather than focusing on the user problem or on the vision that they want to execute on. So start optimizing for these broken incentive systems to try to get some support for continuous building. And so what happens is that more is spent on these hackathons, on these grants programs, and the ROI starts to go down because the spending goes up, but the on-chain usage, the number of users we see on-chain, the number of transactions we see happen, keeps going down. So the ROI decreases for the ecosystems, the foundations of layer 1s, layer 2s, and there's less funding out there for builders. And so when funding dries up in one ecosystem, what do builders do? They are burned out, and then they migrate to the next ecosystem where funding has started to emerge and try to get this early mover advantage there. Okay, so to recap a little bit this funding cycle that I just described, the top projects get the funding earliest, and then they start to form these moats, right? The projects that get this early funding, they are the ones that are able to innovate faster, and the other ones are left behind. So the competition is no longer an even playing field. The smaller builders have to do this Canadian beauty contest. What does that mean? It means that they're optimizing for what they think the grant committees are going to vote for, or what one of the members is going to advocate for internally, instead of focusing on building and shipping results. They're focused on what's going to make them win the next grant contest. And so how does this end up? The early movers, those incumbents that have the moats, they have an efficiency advantage because they received all that funding up front. They are likely, if they are a top mover or early mover, they had funding from outside the ecosystem, like VC funding. And so they're able to move fast and evolve, but that's really a handful of builders. The rest, they're not able to compete. They're not able to innovate on the user feedback that they receive, and so they're able to deliver less on-chain usage through their apps. The ROI keeps dropping, and then the grants just start drying up, as I mentioned. And so small builders, innovators, they're completely burned out. They are not able to respond to the UX challenges of their users and really evolve their products. Instead, they just move to the next ecosystem, as I mentioned. They build very fragmented products, and there's just a lot of unintuitive user experiences out there. So these burnt-out builders, these poorly built apps, it means we have no new users in Web3, right? We've seen liquidity and users migrate from one chain to another as these kind of come up. They are new and they're exciting, but there's no new users and no new usage really coming on chain. So this is the growth cycle that we're in. It's kind of like a vicious cycle, in my opinion, and it's hurting our growth as a community. We have these misaligned incentives and these poor builder experiences and the poor growth outcomes for Web3. So we have two comparisons here, like grants and retro. They're kind of different types of grant funding. Grants fund intent. They're slow, competitive. The application process for certain grants can take a builder multiple weeks to complete, and the ROI is really unclear. For retro, it's all about getting visibility, and so that's what's rewarded rather than the on-chain impact. Very political and unpredictable, and that's what really leads to ecosystem hopping. I was chatting to a friend yesterday who's an app builder, and his opinion was that retro funding is nice for the devs of the builder team of the project, because those funds, the impact has happened such a long time in the past, By the time they get the retro funds, this go into the, let's say, the DAO or the app treasury, the organization's project's treasury, and then they pay out bonuses to the devs. And as a dev, that's really nice. But in terms of creating a flywheel that will bring more value on-chain to those chains that are giving out the retro funding, that's not really there. Because the incentive, the paying for that retro funding happens so much after the impact. And so it's not really generating this flywheel of continuous on-chain growth. OK. So it's on the builder side, it's really no fun either. So it's not just on the ecosystem side that they spend a lot of money. Builders are reporting that getting a grant is extremely complicated. I mentioned how long it takes to do the application process and submitting all the data and reporting, although it's on-chain data, has to be submitted anyways. But there's also this bureaucracy to it. Here in this tweet, another friend reports that it took so much paperwork to receive $232 of funding from Optimism and Cello. So it's a lot of work, a lot of bureaucracy for very little payout, and something that Web3 supposedly should be able to do really efficiently, right? Like pay, especially a builder, would have been, in this person's opinion, more efficiently via PayPal. So that's kind of like sad, I think. OK, so moving on and like reimagining how this all could really change or should change to drive that flywheel that I mentioned of like paying for impact or incentivizing impact, on-chain impact that then can turn into more on-chain impact. So imagine if builders can ship fast, find product market fit, get user feedback, and actually iterate on the user feedback, and then grow their products and their users' on-chain usage or traction faster. That's kind of like the perfect product flow. Imagine if builders could focus on building instead of focus on applying for grants. They could receive incentives automatically because all the things you want to incentivize is on-chain traction, right? Like we want on-chain growth, we want more transactions, more users, more gas usage, and so that should all be tracked on-chain because it's a public ledger. And so there shouldn't be a need for reporting, for applying for these things. It's all transparently out there. And if this were to happen, then builders could really monetize their usage and use that way of monetizing to like fuel more usage of their products. OK, so I'm with Divvy. As I mentioned, I'm a co-founder of Divvy. And Divvy, we're trying to do exactly that. Divvy is the first on-chain protocol that allows ecosystems like layer 1s, layer 2s to pay builders, app builders, only when they drive on-chain results, on-chain impact, on-chain usage that is measurable on-chain, avoiding grants, avoiding the guessworks, the politics, and the overhead. So I will talk a little bit about Divvy now and how it works. So here's the vision. The vision is this three-stakeholder kind of ecosystem where the protocols, layer 1s, layer 2s, DeFi protocols, they launch an on-chain incentive campaign to unlock builder growth. So this is an incentive campaign that defines exactly what on-chain growth means to that protocol. Is it number of transactions? Is it number of users? Is it gas consumption? Anything that can be measured on-chain. The builders sign up for this campaign, they register on-chain, and they start driving building apps that drive that on-chain impact, so that are really delivering on the growth that the ecosystem is incentivizing. And so they can do this permissionlessly because it's on-chain, so they don't need to know members of the teams that are funding these incentives campaigns. And the builders are building these apps, are able to innovate on their user feedback, and are therefore driving users very efficiently through go-to-market efforts to those apps and to the chains that those apps are built on. And those users are the ones that are bringing more value on-chain, new value on-chain, and more usage of the chain. So the idea here, you see here on the right side, is that incentives for builders become really smart. They're really transparent because they're fully on-chain. They're fully based on that on-chain growth that we really want to see as a community. They're permissionless, so it doesn't matter who you are as a builder. If you're driving that on-chain impact, you can get the incentives. You don't need to know anybody or be located in a specific place or be able to attend a conference in a beautiful city like Berlin. And it's outcome-based, so it's only paying when the outcome, that on-chain growth that we want to incentivize, happens. It's not for anything that happens. We're not paying for anything that is happening before the on-chain impact. There's different programs for that. The idea here is to really incentivize the actual growth. So how it works, again, in the framework of these three stakeholders, the protocols, they define the outcome, as I mentioned. We call it the on-chain KPI. They find a rewards contract. This is a smart contract. We call it a reward pool. They deploy it, and they set the duration of this rewards campaign. The builders, they integrate Divvy through our Builder Hub. It's about 10 lines of code, just a couple of snippets, and they start onboarding users to the product. They don't have to do anything else about the funding. They just start driving usage to their product. And the users, as they're onboarded to these products, they transact, they bring value on-chain, and all of that user's activity is measured by the Divvy protocol through that integration that the builders did. And so Divvy is able to attribute all of the users' on-chain actions and usage to that builder. And that is what determines how much funding the builder gets. So based on that verified on-chain impact that the users have through the apps, the app builders are receiving incentives for that verified impact directly from the protocol through the Divvy campaign contract. So we have a couple of campaigns live already. We've learned so much. I'll share that in a second. But first, why do these growth teams, unlike layer 1 teams, layer 2 teams, on the protocol side, why do they love it? They love it because there's no overhead. They don't need a team of 10 people to reach hundreds of builders, to incentivize them, and to even understand the type of impact that these builders are driving on-chain. It's very scalable because the Divvy campaign, because it's permissionless and it's on-chain, can serve 5 builders or thousands of builders. Anybody can sign up, and it's really high ROI for the growth team because they're only paying when the builders are driving the on-chain growth, the on-chain impact that is defined by that KPI. Any funds that aren't used, at the end of the campaign, the growth team or the protocol team can claim back. So they really keep the full control. It's very, very automated and efficient for them. On the flip side, for the builders, why do they love it? It's very transparent, same reason, but it's very clear what kind of incentives they will get for the impact that they will drive. They don't have to do the politics dance or game. They don't need to be fluent in a language that's maybe different to their native language to be able to apply to the grant. So all of that time-consuming grants application process and reporting is gone. It's very transparent attribution, so they themselves can understand, I got this much in incentives because I drove this much impact, or my users drove this much on-chain impact. It's all transparent, and all that data is available through Divvy app. And that's what results in the builder's long-term commitment to a protocol. They have predictability because these campaigns keep going live. These protocols launch multiple campaigns, they iterate, and they know that they will be able to continue receiving incentives based on the impact that they drive because these campaigns are super transparent. So with Divvy, we like to say that Divvy helps grow the Web3 pie for everyone, for protocols, for builders, and for users. So the way this campaign works is that the top used apps, so the apps that drive most on-chain usage, they're still the ones that get the most, right? It's proportionate to how much on-chain usage they're driving. But it's not just the top builders. Every builder that is driving on-chain usage will get a proportionate share of the campaign pool. They just have to register for the campaign. So all participants in a campaign get something that is pro rata based on their impact. And so it's very transparent and fair. It really incentivizes post-impact rather than making guesses on who is going to have the most impact or grow the pie the most. So what's the result? There's no early advantage, there's no moats. Everybody can sign up at any point in time during the campaign. Any builder with an app that is live on mainnet can sign up. There's more funding available when the ROI goes up because it becomes even more efficient for the foundations, the ecosystem growth teams to fund this campaign and so continue to fund the builders that are driving the most impact. And the small builders will win more. Again, there's no politics, there's no overhead for them. They can really just build, ship, and earn. So here are some of the protocols that are using Divvy today and some of the ways that they're using it or planning to use it. Some of these are not live yet. Vana they're creating data DAOs, and so they're L1 for user-owned data. Plume is an RWA chain who launched recently. Plume is looking, their mainnet was literally a week or two ago, so they're going to use Divvy to incentivize their testnet builder community to deploy on mainnet really fast, rather than wait for, I don't know, months. It can take a long time. It's kind of like putting a carrot in front of the builder, be like, if you deploy fast, you have all those rewards, all these incentives to claim. Tether is planning a campaign to drive circulation of USDT. I'll dive into the Celo public goods, the Celo DAO campaign in a minute. We also have one with Zisk, and we're also experimenting with builder communities to grow our own builder community that is participating in multiple campaigns with Scout Game. So this is the Celo DAO campaign, Celo public goods campaign. There's 105 builders. I think the campaign is like 4 weeks in now, so some of this data on the chart is a bit outdated. 50,000 unique users referred or participating or using Celo as a chain through these 105 builders, and a ton of gas usage. So the KPI that Celo Public Goods is incentivizing is gas usage on Celo, because that's Celo's revenue model as a layer 2. Celo Public Goods knows all the builders, so they're doing all the builder registration and onboarding. And I have seen already the first month, if you compare the first week of the second month in purple to the first month of the campaign, gas consumption has already doubled for the top builders. So it's really like providing that flywheel. Like if you provide incentives to builder, they'll just drive more on-chain usage in the next round. It's very easy if you're a protocol or a growth team to launch a campaign. You define the KPI, you define the budget and the duration of your campaign. We, the core team behind Divvy, can help you implement what we call the impact rewards function, so how much you're going to provide incentives per unit of impact. You found your smart contract, deploy it, and then we go into builder onboarding, and it's all then automated on the Divvy dashboard from there. The builders to integrate some snippets of code. Some people report that it takes like 2 hours, maybe half a day, depending on how Web3 natives the app builders are. And then together we grow the pie. So the builders build, the on-chain value grows because they bring more users, and Divvy is able to track and attribute all of those users' on-chain usage to that builder in real time, and builders can go to the Divvy dashboard and claim rewards at the end of each reward period based on all of that traction that they drive. So this is how we are rethinking Web3 funding. We're moving away from hype and from politics, from manual, like outdated process, into impact-based funding of builders, automated so they don't sink in time and paperwork. They can sink in, or not sink, that's not the right expression, but like invest time in evolving their UX and their product. And what is really nice is that it's permissionless. So no, builders don't need to know anyone. They can just start experimenting, or they can be really further along their builder journey and their app growth, and they can join Divvy's campaigns at any time. So the idea is to forget retro, and for builders to build, ship, and earn. So if you're a builder, you should head over to app.divvy.xyz. You can see all the live campaigns and also past campaigns there, depending on which protocols you're building on. You can even sign up for some of the campaigns now. You can join a Telegram community. That's what the QR code is here for, and get updates on new campaigns that go live, or follow us on Twitter as well, at Let's Divvy. So we're ready for the next evolution, which is one where we don't fund hype, we fund outcomes. Thank you.
Thank you, Denise.
Okay.
Funding and before you go, we have some questions with the crowd.
Great.
If you can spare a few minutes. I was just going to say, funding in the Ethereum ecosystem is a design space that has interesting challenges. And if we have any questions for Denise before we go to lunch, now is your opportunity. If not, we'll let you go then.
Okay, thank you. Thanks,
Thank you so
everyone.
much. Thank you, Denise. And we'll see you at lunch. In fact, we'll be back here after lunch. Vitalik, Joe Lubin, and Martin will have a fireside chat, and we'll have a bunch of other great talks in the main hall. So we'll see you then.
Hello everyone. Welcome back, and hope you all had a good lunch and you are hydrated. To start the next series of talks and panels, it will be led by Jordi Belina from Polygon, and he will give a talk on ZK proving in real time. So please give him a round of applause.
Well, hello. I want to talk today about Zisk. Zisk is a project that we have been developing inside Polygon, and it's very much what we call a ZK VM. I mean, it's a ZK prover where you can build circuits using a high-level language like Rust. I mean, it's, let's say, the modern way of writing ZK circuits. And today, here in this stage in Berlin, I would like to do a really important announcement that just happened last Friday, and is that Zisk, we are spinning off Zisk from Polygon. So we are becoming an independent and free project. We are a team of 7 developers plus myself, and we decided to keep this project outside Polygon. Still committed, of course, to being open source. We believe that this is a really important project for the community and for the space, and we are very committed to this project and to this technology, and that's why we decided to spin off. The big motivation for this is, in one side, Polygon wants to, wants to be focused more in the aggregation layer and in Katana and other products in the high level. Okay? And they want to be free to choose any ZK technology that's available. I mean, they don't want to be committed to a specific ZK. And in the other side, from the Zisk perspective, we don't want to build a product only for Polygon. I mean, we want to build a product for anybody that can use it in the space. So spinning off this makes a lot of sense, because we can start being in the space of the provers, competing. We are an open source, I mean, I don't like even the word competing, but at least being in the space and working in the space for having a better ZK proving systems. We, as I mentioned before, we are a set of 8 persons. We moved out of Polygon. We took all the intellectual property, all the knowledge. We have been developing this as a Polygon Hermes, the Polygon ZK VM. We took all the knowledge, all the know-how of the ZK. We have been building for the last 2 years. The last year is the specific disease, but for the last 2 years, the development of a new proving system. And this is the part that's spinning out. Okay, and as I mentioned, our huge commitment to being open source project. This project is going to be Zisk. It's going to be MIT, Slice, Apache, and it's going to continue with that license. I would say probably forever. I mean, on that. Here, of course, you can follow us. These are some credentials I will mention later on. But yeah, this is an important moment for us. We are very excited, and for this project, the team is very excited and very committed to this. I think that here we can advance. We already did a lot of advances in the space. The people that have been following us in the Death Proof channel or in the press, they saw that we are already contributing a lot to this space. Why proving in real time is important? As I mentioned, the most important and most differential thing of the Zisk is that we want to generate proofs as fast as possible. Until now, the proofs we are trying to minimize the cost. But with Zisk, it's not only about minimizing the cost, but it's also about minimizing the latency. It's really important to generate proof fast. Here is, I don't care if we need to put 2 servers, 4 servers, 20 GPUs, whatever, but the idea is to generate proofs in parallel so that we can generate these proofs real fast. Why is important this fast? Well, these are the main applications. Of course, if one of those is in the rollups, normal rollups, they will verify, they will have to prove that the state is valid, and so that you want to do that fast. This is more clear, for example, in the aggregation layers. If you want to communicate any chain, one to the other, you need to commit. You need to commit to a state, and you need to prove that that state is fast, so that these funds can be used in the other chain, in this bridging, in this connection between chains. So it's really important that these proofs are generated really fast, okay? And this was designed from the first day with that in mind. It's how much we can push this technology so that we can build this proof fast. I will show you later in this presentation the numbers that we are getting together, okay? But the goal is to be able to generate Ethereum blocks in real time or even less, okay? As faster as we can. And of course, this technology is also very important for, let's say, new generation consensus algorithms. The Bean chain Ethereum is one of these examples that the ZK is used in the consensus algorithm, and this become a really important piece. And for that, it's also really important to generate these proofs really fast and pushing hard on this technology. Some properties about Zisk. Zisk is, I mean, as I mentioned, Zisk is designed from scratch to run in a distributed way. The idea is that we try to parallelize as much as we can so that we can generate the proofs faster. There is one specific piece, one small piece, that's the execution itself that cannot be parallelized, and we try to optimize that piece as much as we can. At this point, this piece is, let's say, 15 times faster than any other prover in the space. And in the other side, you will have like GPUs and everything is parallelized so that we can always put more resources to be able to build the proof in a constrained timing. We are 128 bits. For me, this is really important. We have seen in this space that, for example, there are some projects that are lowering this requirement to 100 bits and even lower in order to get performance. I think that we cannot accept that. The standard in the industry, even outside the block, I mean, in the world is at least 128 bits. We can increase that, but we cannot lower that. Okay, so we are stick to these 128, and we are going to be hard pushing for these 128 bits. Zisk is also fully open source, and when I'm saying fully open source, that means that we are open source not only the code, but also the GPU code. So everything of the development that we are doing in an open way. We are a community project, and we want to keep this open source. I believe that in the space there is no place for companies or groups that are doing closed source in the space. So here we are fully committed to that, and that's one of the core values that we are pushing here. Okay? RISC-V is the only one in the space that's 64 bits. This is a design, it's a RISC-V 64 bits. Current compilers are 64 bits, and this is good, for example, if you want to create proofs, for example, in Golang or in C#, that they have their own compiler and they compile it to a 64 bits architecture. So this is one of the reasons for using 64 bits. Also, there is some optimizations, and it's better from the optimal perspective to use 64 bits, especially when you do memory copies and other things like that. And the other part that's important is that Zisk is, it's not just a ZK VM. I mean, it's really a full prover, a full ZK prover that has one specific applications that's a ZK VM. Okay, but it's a full stack for building proofs. So the Zisk, you can use it also for proving other things that are not a ZK VM or doing other kinds of ZK VM. Okay, this is a full stack. See that the proofman, if you want the prover itself, this is based with a PIL2. PIL2 is an evolution of the original PIL from the Polygon ZK VM. It's a much more advanced, and getting all the experience of PIL, we just create this PIL2 with much better properties. We also have the recursor. We have all the technology for aggregating proofs and really fast and compressing that in a single proof. The aggregation circuit right now, it takes only 150 milliseconds, which is really low. It's the lowest in the space. And it is also an important technology that's part of the full stack of Zisk. if we look a little bit internally how this works, so the idea is that instead of having a big monolithic proof, as we had, for example, in the first versions of the ZKVM, here what we have is we have a lot of subproofs. If you want to call it, we call it airs. Okay, a lot of pieces, so that a lot of them are specialized, and then we aggregate all these proofs, all these subproofs, if you want, all these airs to a single proof. This is specialization. Of course, we have the main processor. This is just take care of executing of verifying the main processor execution. But for example, we have some other state machines, some of them, for example, that are focused in doing arithmetic operations. Some of them are doing for Keccaks, others are doing for binary. There are some of them that's taking care of the memory, the ROM. So we divide this, and the idea is that we can have many of each. For example, if we have running a program that requires a lot of binary, probably instead of having one instance of binary proof, we may have 2, 3, 4 of them. So we can have as many of that. So we have this idea of variable proof, or a proof that can be as big as you want. I mean, we are not limited for a big hard-coded code. I mean, we can add more subproof as we need. This is translated in a way that so if you want to create, for example, a bigger block, the result is that you may need to generate more of these states, so that you may need to put more servers or more GPUs to generate those blocks, but the time is going to remain constant. So no matter how big is the block, that the time generation should not increase, or at least should not increase substantially. Okay, so that's one of the important ways of seeing that. You see that this is quite a modern architecture. Okay, as I mentioned before, everything is based in a language for writing all the arithmetization. This is a PIL2. It's a very flexible and very competitive. This language allows us, for example, to audit the arithmetization in a very compact, in a very easy way. We saw that this is we got all this experience from the ZKVM, and this give us very good results. So auditor teams, they can focus in a relatively small number of lines to verify, because we have this language. But in PIL2, we added everything that we missed to add in the first versions. I mean, we are generating the constants inside PIL. We added all the language for these multiple state machines. So we have all the logic for connecting all these state machines in the same language, and many other things that make this language. It's simple in some ways, and at the same time more flexible on that. Okay. What else? Well, as I mentioned, the Zisk, when you have all these state machines, you have the arithmetic state machines, the main processor state machines. So how it works? Well, it works very much like a normal, let's say, hardware embedded machine. You have a processor, you have a ROM, we have a RAM, and we have arithmetic binary. You can understand those if you want as coprocessors that are handling certain operations for doing that. Okay, and the core part is this, what we call this bus. Okay, this bus is what connects one state machine to the other. How this bus works? Well, the idea is that we are using one technology that's called log-up, okay? And the idea is, have what we call it, this bus, is that when there is one state machine that wants to assume, for example, the main state machine is not proving multiplications, okay? So when it has to do a multiplication, it adds something to the bus. This addition, what it does is saying, okay, I'm assuming that this multiplication is proven in the right way, okay? And in the other side, in the arithmetic state machine, what you are doing is subtracting from the bus. So I'm proving, so what was assumed in the main state machine, now I'm proving that, so I'm subtracting. Okay, so everything that any state machine is assuming, and there needs to be like another state machine that's subtracting. This is done in 2 stages. So what you are adding and subtracting to the boss depends on a challenge, because you do a commitment and then a challenge, so you can modify, okay? And at the end, the sum of whatever is in the boss needs to be 0. So everything that's assumed needs to be proved, and that means that everything that's added needs to be subtracted, so at the end, the result is 0, okay? And this is the technology that allows us to connect all these state machines, okay? An example of that is, for example, this is the the ideas of Pragmatic arithmetic, okay? So this assumes it adds to the boss, and then the arithmetic is subtracts. But this allows us, for example, let me just go to the, this allows, this is wrong, but in the case, for example, in the arithmetic, for example, one trick that allows us to do, and this is an example, is imagine that in the binary, we have some operations that are quite usual in this thing. For example, when you are adding 0 plus 0, 0 plus 1, or 1 plus 2. This happens a lot of times in the program. So one trick is, instead of proving all these small operations, you can have all these frequent operations in another state machine that they are hard-coded, so they are much cheaper to prove it, and you can prove it by doing that. So the thing is that they are subtracting to the boss this part, and you can select which one you want to subtract. Okay? The same thing happens, for example, with the mem align. The memory, so when the processor is doing a memory operation, there is one state machine that's subtracting the memory, okay? But this memory is very optimized because it handles alignment, all words of alignment operations, which is the normal operation the normal processors do. Okay, but what happens when there is a non-aligned operation? Well, we have like another, let's say, intermediary state machine that's kind of a mem-aligned. So this processor, it's assuming a memory operation, a non-aligned memory operation. This mem-aligned somehow solves, it subtracts from the boss the mem-aligned, but at the same time, it's adding 2 new mem-aligns, so 2 new access to the memory that are aligned and then are subtracted for the normal memory. Okay, so this allows us to combine the things with this bus. Okay, the same happened, for example, for the processor. I mean, the processor, you can have what we can sometimes is the continuations or the inner continuations. Is that you can divide the work in many chunks. So each one can be one proof, but how you connect one with the next. Well, the idea is very much the same. At the end of the processor, we add to the bus the state of the current, of the processor, and at the beginning of the bus, we subtract that from the state. So it's a way of connecting these things. And the same thing happened with memory, but when we have memory, instead of dividing that by the clock, the execution time, we can divide by memory address. So we can take all the operations in one range or in one state machine, another operations of another range is another state machine, and the state between ranges is also added and subtracted to the bus. I mean, it's not a time division, but it's an address division. But the idea is very much the same, is using the bus for these internal continuations. Okay, these are the numbers that we are right now. If you see here, this slide is got it. But anyway, so mainly we have like 4 stages for generating the bus. One is this execution part. This execution part, we are really, really fast right now. So we are able to execute 1.5 gigahertz, probably 2 gigahertz with, let's say, overclocked and other better hardware. But that means that, if you want to prove an execution, you need to execute that, okay? But if you are RISC-V, you need to emulate that, so this is a little bit the limitation. So the technique that we are using, that's very much about transpiling. We are converting RISC-V instructions to Intel instructions, okay? So this is, we have a very, very, very high efficiency on that, okay? So that's why we are able to execute this part that that cannot be parallelized. This part is really, really fast. Okay, and here we are good. This takes less than 1 second. This slide is moved. But anyway, the witness computation, this is the part that probably we are working more. This is the one that we put less love in the last weeks, but we are working hard. These 6 seconds probably can be at around 2-3 seconds in the next version, but this is okay. We get the minimal trace of the first execution, and we are now creating, we are actually writing all the polynomials that we need to prove. All the evaluations of all the polynomials that we need to prove. All this port is already in parallel, okay? And in general, it's a CPU work, and this is running in parallel. Then we have the AIRS building, and it's a proof itself. This is built in GPU, and this is highly parallelizable, okay? And this is, of course, you need GPU power. This is where the real power is, but this is highly parallelizable, and this is 7 seconds, but it can even be lower than that. And there is a final that's quoted in the slide, but it's a final one that's aggregating all this proof, okay? The aggregation, or aggregating, currently I think we're aggregating 3 to 1, so aggregating 3 proof to a single one, this just takes about 115 milliseconds, okay? So if we have 1,000, let's say 1,000 AIRS, aggregating these 1,000 AIRS, this is log-n, this will take about 1 second and a half, 1 second, 1 second and a half, 2 seconds to aggregating that. So when you add sum up all together, you see that we are in the numbers of real-time proving. I think that we are currently, with these 6 seconds, we are maybe at 16, 17 seconds, but when we get better with these 6 seconds, we probably will be below the 12 seconds. That's the real time. And we probably can get even lower because there is still a lot of optimizations that are working. So I mentioned this is what we're working, optimizations, finishing precompiles. Here, of course, there is some cleaning, documenting, auditing and formal verification. This is important that we are working on. And yeah, this is where we will need some help. This is we are as a small project, a small team. We are focused in creating that, but auditing is expensive, generating the GPUs is expensive, but we hope that with the help of the community we can improve and get better on that. Okay? Come follow us here. This is a public announcement that we do with this spin-off. So we are very excited and hope that in the future we can be a reference in the ZK proving. And that's it. Thank you very much.
Thank you, Jordi. So we have a couple of questions. If anyone has, we have some time. You can ask, and we'll have a mic pass around to you. So, yeah.
Nice talk. I had 2 questions. The first one is about, when you split the memory into several pieces, how much is every coprocessor? How much memory does a coprocessor represent? And do you split it per region? For example, ROM, code, data, or is it just a section of memory, a fixed size?
When we are talking about memory here, it's very much about data. The code is what we call the ROM, so it's a different state machine. So data or RAM, if you want. Okay, there is the input special memory that's for the input data, but what we call the data is data, and what we divide by address. Okay, and maybe we take from 0 to 1 megabyte, or from 1 megabyte to 2 megabytes. We can adjust the size of these state machines. I think that currently is 2 to the 18 or 2 to the 19, but this depends very much on the hardware. So we can do bigger or smaller. All these state machines are highly adjustable. So the idea, the optimal part here is try to do the state machines as bigger as possible that they fit inside the GPU. This in general is the optimal. I say 2 to 18, maybe it's 2 to 22, but it's depending on the configuration of the hardware, we can adjust this so that we optimize the time and the cost for that specific state machine. But it's a region on the memory. The memory we divide it by regions because the way to prove memory is that you sort the memory. So you sort the memory and then you prove individually each of the address, all the reads and writes. And because they are sequential, then you can prove it with a single register. Okay, and then you switch the memory address, you get in the register, and that's the way you can prove in a state machine that's proving the full memory.
Thank you so much. Thank you so much, Jordi.
Thank you.
And please give him a round of applause. So up next, we'll be listening from someone who believes that everything should be decentralized, and I'm pleased to welcome Sebastian, who will be giving a talk on Gnosis VPN. So please give him a round of applause.
right, thanks for having me here. And yeah, so first of all, sorry for the ones who are coming for a talk. I'm not here for a talk, this is DappCon. I want to show how we bring the D back into dApps. I'm Sebastian, I'm VP Technology at Gnosis, and I am the founder of Hopper. And what these two things have to do with one another is something that I'm looking forward to talk to you about. So yeah, this is about Gnosis VPN, and if we're talking about how we bring the D back into dApps, we realize that the D, first of all, stands for decentralization, but there's also this narrative that I really appreciate quite a lot that Vitalik brought recently of defensive accelerationism. In short, we have these wonders of the technologies that we all work on, but we want to roll that out to the planet in a safe fashion, being mindful that the greatness of the technologies that we all work on is also used by bad people and might have consequences. So one important thing for me is privacy, or anonymity, if we talk about data being sent around. The most fundamental of those, in all these peer-to-peer systems where data typically goes across the wire, right? All peers have to talk to other peers, and I talked last year here at DappCon on what could go wrong in that, is, yeah, data transport. So I talk about Gnosis VPN, and I'm here today to show a new version of Gnosis VPN, which is still a proof of concept. It's still pretty early, and yeah, this one is, as of now, available in what we call unrestricted proof of concepts. So yeah, I'll dive right into that. Now, yeah, vpn.gnosis.eth, what is this all about? Let's first look at what's happening behind the scenes. How do we claim to bring the uncensorable open internet in the most anonymous fashion? So Gnosis VPN is building on the Hopper mixnet. What does that mean? On the right, we see a artistic representation of a mixnet which comprises of many nodes which send packets to one another. And as you have trouble kind of figuring out how these packets are being routed, that is exactly what we want to achieve, not just for you, but for powerful corporations and state-level actors that are trying to spy on us. They are trying to undermine our digital interactions that we have on every single day, at every single second, with every service that we interact with. And yeah, so what is happening is that we build a network which allows you to route packets that are being relayed by other peers in the network, and they're not just rerouting your packets, they're mixing it up in other traffic that looks indistinguishable from your packets. And on top of that, mixnet infrastructure, which you can use for any sort of packet routing application, we are now building a VPN that ultimately aims to be an application on your laptop or on your mobile that you can use just like a normal VPN, but it is the most anonymous fashion that you could access Web3 infrastructure. Now, what do I mean with Web3 infrastructure exactly? And it seems to me that there's some clarification that's necessary. So first of all, it means to no user tracking of any kind. I thought, what a stupid thing to put on here. That's obvious, right? It seems to me that it's not always obvious, right? We have to be respecting the privacy of the individual. And that starts there, and it continues with the technology we utilize, right? It means committing to not using a centralized RPC provider. Now that is tough. How many people here are running a DApp now? Just quick check. Nice, wonderful. Thank you for doing that. Thank you for supporting decentralized networks, right? We are mindful of the fact that this is hard, and we'll later on briefly talk about how we want to roll that out at larger scale. For the ones who maybe still have friends who don't run a DApp node at home. It also means, for the folks who actually build dApps here, not relying on centralized indexers, because I think that is a disgrace. Relying on centralized infrastructure that you blindly trust is not what we set out to build here. It also means beyond indexers, not any other APIs that you leak user metadata, because there's always some provider which can capture data from your users that can be used against your users. Now, I heard from Dapp developers, I don't care. Well, the user does care. The user does care, and there's laws and regulations increasingly in place to try to protect your users in case the developer doesn't care. Now, let's take a step back here, and as developers, try to improve that. Now, that all sounds painful. I know, right? I know that we want to build fast, we want to ship products, and we want to get there ASAP. And I argue that it is possible. It is possible to build these applications, and what I'm showing here, although it's a proof of concept, tries to give a first glimpse of how that can actually be rolled out. So briefly, what we'll be looking at is shown here on the right-hand side of this screen. We have on your user device a Gnosis VPN client. Currently, that's a command line application, but again, this is DappCon, so I hope you're fine counting that as a Dapp. And currently, this comes with an entry node to this Hopper mixnet. That's what I showed before, this packet mixing infrastructure that you gain access to, that routes and reroutes your data packets towards the Gnosis VPN exit node that gives you the actual access to the internet, fetches information from a web server, and sends it back through this mixnet to your Gnosis VPN client that is locally running on your machine. So yeah, so how does this look like and how does this work? Well, I would say, let's see. This is an actual live demo, and I hope that it works despite the hardships of trying to build a Web3 product. All right, so currently there's an onboarding on GitHub, and the first thing that I'll skip over, just because of shortness of time, is you need access to a Hopper node. I have access to my Hopper node here. That's one of these nodes you saw in the animation that is kind of relaying packets to all sorts of people. That's the web interface that it exposes to me. And yeah, we don't need to understand what it does. It has a bunch of Hopper tokens. It has a safe, because every Hopper node is a safe. By the way, great infrastructure to build with. And this is the entry node that I will collect to route my traffic to the internet. All right, so I have that one. That's good. Now let's see what we need to do. Like, what we need to do is, you can do this, all of this is publicly available. So for the ones who want to play along, vpn.gnosis.eth.limo is the starting point. So what I'm going to do here now is, yeah, I will just run this installer. So I'm downloading a binary which is installing Gnosis VPN binaries. And this one is basically asking me for a connection to my Hopper node. If you remember, in the animation I showed you before, this needs to get access to the packet mixing infrastructure, so I'm going to give it to it. It requires a port for me to connect to, and yeah, it will now download the binaries that are required to run this. So we have two binaries here. One is the VPN, and the other one is some controller interface. Controller, for the ones here that are using VPNs, allows you to say which server do you want to use. Do you want to be in Germany? Do you want to be in Spain? Do you want to be in the US, or wherever you want to be? Who here is using a VPN, by the way? Any casual VPN users in the room? Cool. All right. I hope to convert you all towards Gnosis VPN later on this year, once this maybe becomes less painful. Or for the ones who have higher pain threshold, you can try it out right now. All right. So let's see what's going on here. This one created a folder for me called Gnosis VPN. So I'll go there. And first of all, I'll start the VPN app. It's basically what it's telling me up here, right? So I'm just going to start the Gnosis VPN app. And I'll pass it a config file. So that config file currently tells it which exit nodes are around, and yeah, starts doing that. Doesn't do much yet. The second thing that we will now start is we have this config app, right? So we have this Gnosis VPN control app, and that's what's used to configure my VPN. So we can ask it for a status. So my Gnosis VPN app, it currently tells me, okay, the connection is down, I'm not connected to anything, but I know of a few exit peers. And the first thing you see here already is these are not DNS names, these are not IP addresses, these are Hopper peer IDs. Yeah? So these are kind of nodes in this Hopper peer-to-peer network that I can connect to through my Hopper node, and therefore I'm not connected to any kind of centralized infrastructure like DNS, or any other services. It's all trying to be reliant on information that I have available locally. All right, so let's initiate a connection. So let's tell it to, you see the commands that this Dapp here has available, Gnosis VPN connect, and I will connect to Germany. So I copy this PRD. If you find this command line interface a little bit cringe, yes, there will be a UI. We had a team last weekend at the Web3 Privacy Now hackathon already working on some, but I'll stick to command line because I know how that works for now. All right, so I'm connecting to a peer. Let's see what our actual VPN app is doing. It's setting up a VPN connection from my entry node via some intermediate mix node. So currently I selected only one mix node towards this exit node that I've chosen here. What you might have seen is that up here there was a VPN icon popping up. That is because this client application established a WireGuard connection, and I have the VPN running. Currently, I'm not using it yet. So if I check out my IP address here, I see, this IP address. Interestingly, kind of funny, like this venue here is its own ISP, so I see what I'm connected to. Now let's go ahead and let's set up a proxy to use the actual VPN. So I'm using this in Firefox. I'm configuring the proxy, and let's see if it works. I'm trying to get my IP address again. Okay, so something went down here. Currently, it's trying to reestablish a new session. Probably it's going to take a few seconds before it reestablishes a second. It seems that worked, so it took a few seconds longer. And indeed, we see I'm currently connected to Frankfurt. So I established a VPN connection through this underlying mixnet, exposed it as a proxy into my browser, and I'm connected to the VPN. I'm just going to open them side by side, so if something breaks or some of the nodes in between goes down, I can see what's going on. Okay, now this is a VPN, and there's maybe some performance issues, but let's see what we can actually do. Like, can we use this early POC version already for something? So I'm going to try to open, something like Twitter, and yeah, we'll see if this one can actually be used to route traffic. Well, and the answer is right now we can't really. So what I'm going to do is I'm going to connect to another server. So I'm going to connect to Spain. Let's see how that one is going. Spain is an entry node. So you'll see that my VPN connection dropped off here, and my VPN client tries to establish a new connection. And yeah, it seems the session got opened. I have a WireGuard connection open here. And yeah, awesome. Okay, it seems that we were loading part of a video of this live stream here. Let me reload that. Yeah, okay, awesome. It seems we have a live stream running here. There's a bit of a lag. But yeah, so that's the unrestricted POC of Gnosis VPN. Thank you. Yeah, I'm kind of happy that this worked. It's a bit meta. I'm connected now to Hopper via Gnosis VPN. Okay, what did I want to talk about? Let's get back to this one here. By the way, this page now, again, very meta, is being loaded through Gnosis VPN. Let's see if that works. Yeah, cool. All right, where was I? I showed you the demo. Now, what is going on here? How does this compare to your existing VPN and other VPNs? So we have something that's rooted through this mixnet in this multi-hop architecture, which makes it surveillance resistant. So if there's anyone who tries to spy on you, yeah, they're going to have a way harder time. I'm not saying it's impossible, but I'm saying it's way harder. And how does it compare to a VPN? So quick recap for the ones who just use a VPN without wondering what it actually does. You route your traffic from your node via somebody else's server to the wider internet. Okay, that's not great. You just trust somebody else's server. With Tor, you basically do the same thing, but there's kind of 3 servers in between, and you trust that the first and the last are not colluding. In case of Gnosis VPN utilizing Hopper, we trust that just one mix node along the path is honest. Now, something that we're excited about coming soon is kind of unblockable exits that you cannot find and cannot get in touch with, as well as residential IPs. So currently, this is operated by Gnosis exit nodes. We want to enable all of you to run exits if you choose so, and if you want to earn tokens for doing so, of course, to judge if you want to expose your home IP address for other people to use and earn money with that. If you want to do that, it will be available soon. And so some of the things that I'm excited about going soon, and just to spend a few minutes on what's coming next and why this is not really a fully fledged application that at least most of your friends can use, is, well, you needed this separate Hopper node, right? This interface that I showed you, that's not exactly useful if you want to install an app and have to set up a safe, bridge money over to Gnosis chain, and wrap Hopper token to WX Hopper token, and so on. There's a bunch of work there. But what we're working towards is have what we call edge nodes, which are running inside your device, which are not used for packet mixing of other people's traffic, but which are used to integrate the direct access to the Hopper network in one application that you can install. That leads over to the second point, have kind of streamlined UX for the whole thing. And finally, for the people who are interested in more of the cryptography behind it, I invite you to look at this. We have we have some RFC on that, on this anonymous return path, which is actually super cool. You can connect to an exit server and say, hey, give me this website like x.com. And the server responds something, but they don't know who you are. It sounds kind of weird, right? You're getting something back, but they don't know what they sent it to. So you can imagine it like you give somebody an envelope, and it has a return envelope in it where they pack a payload in, send it back. They have no idea where it's actually going until it comes to you, and with the next request, you do the same thing. So something that will be available very soon. And just to give some glimpse of why we're not there yet, but that will be available soon. And lastly, Gnosis VPN is, as mentioned, running on top of the Hopper mixnet. The Hopper mixnet is relying on settlement infrastructure called Gnosis Chain. Why Gnosis Chain, actually? When we started this, we looked at a whole bunch of chains, and what properties do we want? We want something that's actually very resilient. So like, Base and all of the other kind of centralized L2s are obviously out of the picture, because VPN and anonymity infrastructure is something that many people don't like. And when you can go to Coinbase and say, hey guys, you're not allowed to do that anymore, otherwise we ban you from our next military parade, that's not great, right? That's not great for actual resilience infrastructure that makes the Web3 for me. So Gnosis Chain is a very decentralized chain that is also, at least currently not heavily used. That makes it kind of convenient for us. So we have predicted gas prices and so on. That's great. I did mention already, every Hopper node is a safe, or more specifically, is connected to a safe to separate your operational concerns, like the DevOps fiddling, from the finance. Finance is like, okay, I want to manage money, and I want to manage the risk and access to money. And safe is basically what we use to separate these two areas of concerns. And finally, the underlying transport that we leverage is libp2p, an infrastructure that's used in the space by most Ethereum nodes and those chain nodes, as well as IPFS. And this work has been supported by Gnosis DAO, GIP98 and 122, that enabled that. You will see another GIP coming soon. We're setting up a new entity that is offering this product. And this new company will belong 100% to Gnosis DAO, in a commitment to build this in the open. Obviously, all of that is free and open source software and under ownership of Gnosis DAO. Yes, so with that, I would like to close here. I invite you to check it out. Again, vpn.gnosis.eth. If you still need a centralized resolver, that's .limo. And with that, I'll close here, and I'm open for some questions.
Thanks. Thank you very much for the talk. My question is, you said no user tracking of any kind.
Yes.
And my question is how we balance this idea, which of course I think everyone that's in this room today agrees with full decentralization, with the need of security, for example. I think that as much as we agree with decentralization, we still want to have our kids protected of a sexual abuse or of a terrorist attack that is being coordinated through a fully decentralized and untrackable VPN.
Yeah. At Hopper and at Gnosis, we believe that, you know, bad things happen in the world and we do not want to support it, right? And it is indeed challenging to balance these two. So we will, for the Gnosis VPN, which you can run on your Dapp node, and that's what's happening right now, if you try to access some bad stuff on the internet, it will not be available. So the exits are, you know, censoring bad things, and that's already implemented right now. To protect people and also to protect node runners, because frankly what's happening here is you're exposing your home IP address to anybody out there. There are obvious issues with that. So we give you the tools to censor whatever is legal in your place. Beyond that, I mean, I see actually, I mean, again, I think that is an issue and we give people the tools to protect themselves and protect the network. I am more concerned about the marketing side of the story, because marketing and growth people typically want to know what's the user profile, right? And yeah, I mean, I think we have to just not cut corners and, you know, engage with our user audience to try to understand it instead of tracking all. Like tracking all is a sledgehammer that always works and you can use it for everything. Tracking is fantastic. I say user tracking is a low effort way of getting what you actually want to get, because you don't care about all the tracking. What you care typically about is understanding user behavior. And I claim that is doable in other ways than just full-on tracking. Any other questions?
What do you think the throughput through the HopperNet might be? How many users can be connected with reasonable speed?
Yeah, great question. So first of all, it is going to be slower than what you have today, right? So, okay, I'm going to push it a bit, but I'll try it anyway. So let's see. So this is actually going through like 3 Hopper nodes, and it seems that I can get to around 1 megabit per second. Okay, we're getting a bit more. That's enough for HD video streaming. Maybe it's not yet enough for 4K, but you can get speed. And again, this is a POC. I think this can be improved over time. Now, that is on one user, to answer your question, right? So that's what I get. And the second part of the question is kind of what does the network provide? So first, some property that is very cool. We talk a lot about scalability, right? And Jordi just had like a very wonderful contribution to Ethereum scalability, which is very tricky. These networks, like Hopper network, scales really nicely, which is perfectly horizontal. If you want more network bandwidth, you just need more nodes. And currently, we have in a network, let's see, around 300 to 400 nodes, which, yeah, I mean, currently this is actually more limited, like in the Gnosis VPN, you're limited more by the user device because your user device is what creates the packets. So you see here, we have around 300, 400 nodes online right now. This one, since you're bounded more by the compute load on your entry node, which does path selection, packet creation, and return packet creation, actually, it should scale well also with the number of exits. I can't give you exact numbers, but I am pretty sure that the first couple of thousand users, we are fine with a relatively small network of a few hundred mixed nodes. But again, I also think that this is Web3 is actually kind of cool for that, because as you have more usage of that, the return of currently, like you earn around 10% APR for running a node and relaying traffic, that will go up, right? It's not just, this is not an investment sort of thing, right? You don't put in money to earn more money. This is you're relaying traffic, and for that you earn. And if you relay more because there's more organic users that pay for this, you will earn more, and that's why I'm kind of hopeful that this will kind of always find its own balance.
Can we all please have a round of applause for Sebastian?
Thank you.
Okay, so you can already see now we have a talk on Futarchy with by none other than Robin Hansen, and he will be joined with Kevin Selters. So please give them a round of applause. Thank you.
I'll be talking jointly with Kelvin here. He'll talk in a few minutes. In 1981, a Jeffrey Wernick ran a whole company using this concept of Futarchy, I'm going to explain in a minute, for 3 years. He used it to decide who to hire and what features to add to the software he wrote. And after 3 years, he sold it for a lot of money. He's been an investor ever since. But apparently, nobody else has ever heard of this thing. I heard about it last year. So I have to give him credit. But I came to this field long ago when there was a time before the World Wide Web, I don't know, you know that? And that people hadn't even imagined the web, and I was with part of a group of people who were imagining the web, and then I had some doubts about that, and then I started, how else could we do the things we were hoping to do with the web? And I imagined, oh, maybe betting markets could work for that. And so I started to write about betting markets, prediction markets, as a way to aggregate consensus and deal with social problems in the world 35 years ago. And then roughly 10 years later, I had the insight that, well, the main value of information is to make decisions, and so the main way to make prediction markets valuable is to put their information right next to a decision, and so that originated the idea of decision markets, again, which I'll explain. But I wrote about that 25 years ago, 26 years ago now, and not a lot happened for a really long time. And then 3 years ago, a secretive government agency in India started to actually use it for decisions. And 2 years ago, this organization called the MetaDAO started to make its major decisions using this governance mechanism. And they've made 69 decisions since then. They have 13 customer firms. And then in the last year or so, a number of firms, new firms who I'm advising, have been starting to explore this concept of what I'm calling Futarchy, decision markets. And they include Buttery and Futarchy.fi and some MetaDAO in addition, and in these last few days and the last few weeks, I've been hearing from a lot of other people doing other projects that I'm not directly involved with. So this is now a thing which makes me really happy after only 26 years waiting for it to get tried. So in general, I'm missing a slide. Well, we can use it on this slide. OK, so the key concept here, if you just focus on the top of this slide, is we have some organization with an outcome we care about. So for a for-profit company, it might be the stock of the company. For crypto, it might be the coin. For an election campaign, it might be the chance of winning the election. We have an organization with some goal, it could be an individual too, and we make an asset that tracks this goal. So for the stock, for the company, the price of the coin, and then we can have a market in this asset, as you well know, and that's the unconditional market for this asset. And then at some point, a decision will be a possibility of making a decision will come up. Well, there'll be a proposal, and we'll want to know, do we approve this proposal? Do we like this proposal? Is it a good proposal? So then the key idea is we now make conditional markets. So in an unconditional market, you just trade, the stock, say, for cash. But a conditional market, you make the trade, but the trade will be called off, canceled, as if it never happened if a condition isn't met. So here we're going to trade the stock, say, for cash. In one market, the trades will all be called off if we don't say yes, if we don't approve the decision. But then in another market, we will say the trades will all be called off if we actually make the decision. So we have a price if yes and a price if no for the decision in terms of the asset that we're tracking the value we care about. So this might be, for example, firing the CEO of a company. And we could say, what's the stock worth if we keep the CEO or if we fire the CEO? And then at some point, we will end these conditional markets and actually make the decision. And the idea is to look at the difference in prices between these two markets as the information about what decision to make. That is, we keep the CEO if the company's worth more, estimated by speculators if we keep them, and we dump them if it's worth more if we dump them. That's the key idea of Futarchy, just basically speculators making decisions about what to do. And so you'll be the decision will be based on the difference in these prices in this period here. And as I said before, actually, all innovation is a combination of some simple, elegant ideas and a lot of messy details. And what I've worked on for many years and want to focus on and talking to you about is that we've been spending a lot of time thinking through the messy details to make this elegant idea work. And so I want to spend some time walking through some of these messy details with you to show you that we have thought through a fair number of them. Okay, so first, let's think about the details of subsidizing these markets. So if we just set up these markets and we do nothing else, there's a strong risk that nobody will trade. Nobody has an, there's a vast number of possible markets in the world that just don't exist. Nobody trades in them, so there has no prices. We don't want that to happen to us. So we need a way to induce people to trade so that they believe they all have a profit from trading here. And a straightforward way to do that is to make a subsidized market maker, because the profit from any one trade that changes a price from the current price to what you think the right price is basically proportional to liquidity of the market times that price difference squared. So when you offer liquidity in a market, for example, by directly subsidizing it, you offer a price for information. You're saying, we're willing to pay for information about this topic. So the higher liquidity, the higher the price you're offering is. So the first point is you need to offer something. You should be offering something because the information is valuable to you, the organization. And so pay for what you want. But we have several other complexities here. One is that we're going to want to measure this price difference in some period. And in that period, we actually don't want much information coming out. There's going to be people we call manipulators who are trying to influence a decision, and they want to pretend to be informed traders. They want to look like they know something, but they really just want to push the price. So we'd like to have a period of time where informed traders are not showing up. So anybody who's trading them, they look suspiciously like a manipulator, and people who want to counter that for a profit can identify them and squash them. So how do we make a period of time where not much information comes out? Well, the key point is to have other periods before and after where we're offering a much higher price for information. We say, hey, if you've got information, please come to these other times and get paid for it then. So here we have a high price before and after this key measurement period. And in this key measurement period in the middle, we have the dotted purple line. That's manipulators would actually add liquidity to the market because, and so we're trying to make sure the total liquidity is low in this measurement period, and so higher before and after. We also want people to sort of we want to pay the cheapest price we can for the information, and if there are two people who know the same piece of information and they know that, then if we slowly lower the price, they're going to be in a race with each other and hopefully sell it to us at the cheapest possible price. Also, the very first price is pretty ignorant, so we don't actually know what that is, so we are going to be not saying so much about that. So, not paying very much for that. So anyway, there's a number of details about how you set up liquidity to make these markets work. Now I want to tell you about another sort of technical problem, which is that if the market is giving advice to decision makers who know more than the traders, you can have what's called a decision selection bias. So this is a modestly complicated diagram, which no longer has my step-by-step pieces of it.
You have time, Robin, you can go.
Right? No, but I'm apologizing for the messy diagram. It was supposed to show you these pieces one at a time. It didn't do that. Anyway, so the key idea is, imagine we have the fire the CEO markets, and imagine, therefore, the true state of the world is the value of the company if we keep the CEO and the value of the company if we don't. And this is the two-dimensional space I'm showing you. And a point up in the upper left there are points where it's best to keep the CEO because the value of the company is higher there. And in the lower right area is the points where it's best to dump the CEO because the company is worth more in that case. Now, we're going to imagine that the decision makers who are actually going to decide this, what if they know the exact point, But we, the market, don't know the exact point. We are uncertain, so we might have a uniform distribution over this yellow area. That's what we know. Now, according to our information, the average of that area is below the line, saying, on average, it's best to dump the CEO. And that's what our average information says. But if we know that the actual decision will be based on more information than we have, then we're going to have to make some conditional expectations. So what if the shape of the information was this region? It still says, on average, fire the CEO. But if we're going to think, yeah, but if the point is above the line, then we're going to condition on being in the red area. So we take the average of the red area, and that's the price we're going to get the stock conditional on keeping the CEO. And if it's in the yellow area, the value of the stock conditional on dumping the CEO is the average of the yellow area. So if we take those two lines in the intersection, they're actually up in the keep area, which says the markets are saying keep the CEO, when our best information is to dump him, which is the decision selection bias. So the key problem here is that we have this bias. Now, it only shows up in some situations, clearly. It's not a thing that always shows up, but we still don't like it. But the key problem here was that the market speculators were wondering, what do the decision makers know? Because they will make the decision based on more information than we, the speculators, have. So a direct fix for that, for example, if the market just makes the decision, then the market can know that the market won't know anything more than they know if they know they're making the decision right now. So you need to make the time of the decision really clear. Right now is when we're making the decision. What do you say right now? And then we don't have this problem. Now, if the market's advisory, we can also avoid this problem by, again, making the time really clear and then making sure all of the insiders who are decision makers who have special information, they're either allowed to trade or they're allowed to have friends who are allowed to trade that they can tell. And then we make sure the market has all the information that they have. Now, there's other kinds of messy details, which are actually typically more the obstacle for implementing these things. So imagine this is the C-suite of some organization, and there's an autist at this table. What does that mean? Somebody who knows the company really well, but they have no idea what political agendas people have, what people want to hear or don't want to hear. They just blurt out whatever pops into their head regarding any topic that shows up at the table. They won't last long at the table. Why? They might be a trusted advisor to somebody else at the table, but they won't last very long there because they will just be very politically disruptive. People can't count on them to say the things that fit in their agenda. They will just be disrupting things. But that's what prediction markets do, unfortunately. They are just the autist at the table. You turn them on and they just tell you whatever they think. Whenever they change their mind, they tell you that, and it doesn't fit very well in organizational politics. And that's one of the key obstacles we often have. I could go through other examples here, but I think I should hand it over to Kelvin.
You can go, Robin. You can go.
We have less time there. Yes. Anyway, but so imagine a project with a deadline. Often, the person in charge of the project says to themselves, if I fail to make the deadline, what will my excuse be? And they'd rather have a good excuse if they fail than actually learn the answer better. And so the usual favorite excuse is, look, we were going along just fine. At every project meeting, everybody said, we're going okay, sure, we're going to make the deadline. And then at the last minute, something weird happened, came out of left field, so strange, it'll never happen again. That's why we failed. But hey, nobody should be held accountable here. We should just forget about it because it was so strange. That's everyone's favorite excuse. But if you had a prediction market on will we make the deadline going for the last 6 months, and it kept saying all the time you're not going to make the deadline, you lose your favorite excuse. And people often would rather have their favorite excuse if they fail than actually learn more about how not to fail. So the promise here, the high-level promise is the world has a lot of bad governance. As an economist, I can tell you a lot of huge areas of life, law, medicine, education, all sorts of things are screwed up really badly because we have bad governance. And the main problem we have in bad governance, I'd say, is it aggregates information badly. And we have this wonderful institution, speculative markets, that's spectacular at aggregating information. So Futarchy is a way to take advantage of the power of speculative markets to make governance more informed, which then makes governance more competent. And the promise here that crypto is now at the forefront of pushing is that the world could pioneer, test, and then field much more competent governance, which would then let the world solve many of its key problems by handing the problems to governance systems and saying, do solve. That's the promise that is here if we can achieve developing this technology and making it more widely accessible.
Right. So which one is? Some other applications we're going to skip over. Right, so Robin explained the idea behind Futarchy, and I'm going to go very briefly on a very simple application for Gnosis DAO. I know many of you are GNO holders, and I want you to be able to join and contribute to making Futarchy real, starting on Gnosis DAO, and also very soon on the whole Ethereum ecosystem. So let's go. So we're launching this project called Futarchy25. So I'm cas.eth. You can follow me. You can follow us on X. So first, a bit about our story. So we had this previous project called Quiver. It was a futures exchange, leverage trading, and we did this experiment. We always wanted Futarchy for ourselves. We wanted to use it for ourselves. We did this experiment on the election, the US election last year. We did run these futures markets for Bitcoin, and we run these markets for Bitcoin if Trump was going to win the election, if Bitcoin if Trump was not going to win the election. And we had these speculative markets estimating in these two different worlds, right? So what would be the difference in expected price for this asset, Bitcoin? And the markets were consistently telling us that in this world where Trump was going to win the election, the Bitcoin price was 12% higher. This was the estimate on our conditional markets. So of course, that's not a good enough reason for anybody to vote in a candidate or not. But this is what the market estimated, and it was actually a pretty good estimate. The estimate from the markets was 700, and when the election actually happened, 1 day later, the average price was actually 900. So it was pretty close, like less than 0.5% error. So this is like one experiment we ran before, and now we are running Futarchy.5. So we're just announcing this private launch for you guys. I want you guys to try it out. We just have it ready today. And we just created our Discord today, and I'm going to share the links with all of you. I want all of you to join. And so here's how it's going to work. This is a test for you guys to learn how to use this. On Gnosis DAO, we are starting out with milestones. So Robin mentioned about proposals, and of course, we want to use Futarchy to make decisions. That's how we get value from conditional markets. We want the markets to tell us what decisions we want to do, right? So in prediction markets, usually the information you're getting is what kind of thing is going to happen. Where in Futarchy, we want to use the markets to get more like what should happen, rather than what is going to happen, right? So we want to know what the thing is best, and according to some metric. And there are many ways of doing these different kinds of metrics, but the one that is more logical, more natural, it doesn't have to be the only one, but for a for-profit company with a token, the token price is often a very simple and core metric. So we are going to we have these milestones that you can trade on GNO, on the Gnosis token, conditional on the milestone being reached and the milestone not being reached. So we just have these two milestones now, but we're going to have many more. So first milestone we have now is will Circle deploy native USDC on Gnosis chain. Right, so if you think this is important, you can come here and you can put your money and you can buy some GNO tokens conditional on this happening. And then if it doesn't happen, you get your money back, right? So this is how our website looks. So we have Gnosis DAO now, and we want to have many more DAOs very soon. So yeah, so let's go on this one and see. So this one is the one that is going to end in a couple of weeks. Will Gnosis Pay achieve more than 2 million euros in weekly volume? So we're getting very close to that, and we think that's potentially an impactful milestone for Gnosis. So let's see what you can do here. So here is a description, putting some snapshots here. You see there's a spot price that is a reference. So first of all, you can go here and see and click on Dune and see what the track record is for volume for Gnosis Pay. You see it's getting very close to 2 million. So let's see if the next 2 weeks we can reach this 2 million euro milestone. So we're getting very close, but I'm not sure if we're going to do it in 2 weeks, right? But let's go. So here's the thing you can do. So it's important to separate this from a prediction market. Even though we do have a prediction market, you can go and you can trade on the prediction market outside. And there's this, right now it's trading at 38%. The core idea here is not for you to bet on whether the Gnosis is going to reach its milestone or not at the given time. The most important thing is for you to bet on what's the impact it's going to have, right? So this is the spot price of GNO, and the probability that the milestone is going to be reached is just a reference. What matters is the yes price, what's going to be the price if the milestone is reached, and what's going to be the price if the milestone is not reached, and therefore the impact is calculated based on that. So just to show you how it works, you have this charts. You can see the yes price and no price varying over time. The spot price is the normal price of GNO, and it's usually in the middle between the yes and no prices. I'm going to finish up in a few more minutes. So usually the spot price is in between the two yes and no prices. If it isn't, it means you can make a profit by doing an arbitrage. You can buy the yes and the no prices. You can buy both the yes and the no and merge them together and get the spot price for free. So let's imagine here that you think it's getting very close and Gnosis is not actually going to be able to make this milestone in the next couple of weeks. But you still think Gnosis is doing great. So you don't actually think that the GNO price is going to fall in a couple of weeks, just if they reach, they get very close to the milestone, but you don't think it's going to fall. So what you can do, you can go here and say, okay, the no price is undervalued. I'm going to buy this no token. So you're not actually betting on whether Gnosis is going to achieve or not the milestone. You're betting on if they don't achieve it, I'm still going to buy Gnosis. I don't think the Gnosis price is going to fall. You can go here. If no, buy, and here you're going to buy 100 using 100 SDAI. And then there we go. You make a trade. You're going to have a position like this. And if the event doesn't happen, you're going to get 1.09 GNO. You just purchased GNO at a discount, right? And if the event happens, you're going to get your money back, right? So here's how it works to make a trade on a conditional market. So this is the same kind of conditional market that you need to make a trade on a proposal instead of a milestone, right? So yeah, so price did not fall, you made a profit. That's how it works. You can potentially buy for a discount, or you can buy for a small premium, but then you get ensured that you're only buying this world where the milestone is gonna succeed. So I want to thank our partners. So we are using Klados as our resolution oracle. We are using the Seer contracts we are using the Seer contracts as routers, and we are also using integration with CalSwap, and something really important. So right now it's a testing, it's still in beta mode, so please use with caution. We haven't, the audits on some of the proxy contracts are still ongoing. So right now there's about $2,000 on liquidity on these markets, so it's good for small trades for you to try out. Eventually you want to have like $200,000 liquidity on these milestones and several $1 million on the proposals. And some people ask, well, how are we going to have this much liquidity on proposals? And the answer, the key to that is CalSwap. So you can actually get a significant, we have this, we're going to be getting some of this liquidity from Gnosis that is normally on the GNO SDAI pool. And we're going to be splitting up into the yes and the no pools. And you can do that because if you want to buy some normal GNO, we can just use CalSwap, and the CalSwap is going to buy them for you, and they're going to buy the yes and the no versions automatically and merge them together, right? So it's a way, so in practice, you can provide liquidity to conditional markets to inform your decisions and not reduce liquidity on your regular trades. So this is a core thing on how we're going to be able to get like $1 million of liquidity on these markets. Yeah, so thank you very much. We really want to, so this is just the beginning. We're going to do much, much more. There's so much that we want to do, and this is just the beginning of the journey. So please join us. I want you guys to actually get your phones right now, if you can. And I'm going to leave this open while we have questions. I don't know how much time we have for questions. I went a little bit over time. So this is just our Discord. We just created this morning. So you're going to be the very first to join, and the people who are joining here, I'm going to give them, everybody's going to get a special role for OG, DappCon. So please join. We want you to contribute with milestones. What kinds of things would make you want to buy more GNO? What kinds of proposals do you think would be good that would make you want to invest more in the Gnosis ecosystem? And of course, if you have your own DAOs, we would love to talk to you about how you can have this on your DAOs as well. So thank you very much, and thank you.
Thank you so much, Robin and Kelvin. Let's open it up for questions, maybe one or two. We have one there.
So nobody questions that prediction markets extract information. Over here. Hello. Okay. Nobody questions that prediction markets extract information and incentivize the extraction of information. And they can be used to incentivize things. But here you're flipping the mechanic around. You're trying to use prediction markets to make decisions. And the slide, for example, you showed earlier with like the distribution over the CO being dumped or the CO being kept, you're basically saying that the prediction market is, as a noisy estimator, is estimating the actual underlying distribution of the outcomes, which itself is a stochastic event. So you have to first prove like that the prediction markets can actually approximate that distribution. The distribution could have fat tails, in which case it may not even be stationary. You have to prove that you have enough participants in the prediction market that can fairly approximate the tails of that stochastic event. And from a point of view of decision making, not having fairly approximated tails, that means that like your decision making process could be completely off, even though you're calculating an average over a prediction market.
Can you hear me?
Yes.
So you're holding very high standards, perhaps you're an academic, to this process, but notice the world is full of organizations and people making decisions all the time where they haven't proved any of the things you're saying. People are just out there making decisions on the seat of their pants using many very crude inputs. That's the vast majority of decision making in the world. They don't prove any of those things. But we have a standard decision theory that says how to make decisions is basically to maximize your expected utility across your outcomes. So if we can make decision conditional estimates, those are exactly the sort of things people should have for their inputs. And the fact that there is a price reflects some expected value over possibilities, because trades have to pick a price, and they do represent an average over possibilities in the trader's minds. So I would just say this is much better than what people are usually doing.
Not perfect, but
and it's just
better.
giving the usual mechanism of decision theory. Decision theory says make conditional estimates based on each possible option of what you think will happen, and that's what the markets are doing here. That's what decision theory says to say.
Thank you. Maybe another question?
Yeah, no, unfortunately, out of time. Thank you so much, Robin and Kelvin.
Thank you very much.
And with this, let's welcome the next speaker, Paul from Circles.
Amazing. Hi, everybody. Very happy to be talking to you guys today. My name's Paul. I'm with the Circles team, and I want to talk to you about the Circles Web of Trust. This is not an introductory level talk. Martin yesterday gave a presentation on this. There's been several workshops. In fact, as I guess you all know, it's been hard to kind of evade us in this conference and over the last couple of weeks. Instead, this talk builds on the understanding, the basic understanding that we hopefully all have about this protocol. So let's just recall what Circles is about. Here are the core 3 rules of Circles. Everybody can come and create an account. There's no gatekeeping. And then as soon as you have an account, you're going to be enabled to create your own personal CRC token at a fixed rate of 1 circle an hour. And all the Circle tokens that are being created by everybody suffer from a sort of constant evaporation, which is called the demurrage, at a rate of 7% per year. And on top of that, we have the notion of trusting, users trusting each other. That's just a relation that is sort of registered on chain. And by Alice trusting Bob, Alice is kind of communicating to the rest of the network that she is willing to accept Bob's circles at face value. And so if we think about it, we have 1 rule relating to money creation, 1 rule relating to money destruction, and then 1 rule relating to money flow, by which I mean if you sort of took a snapshot of all the balances, the third rule would kind of govern the dynamics of how these circles can then move about. And in this talk, I'm not going to be caring at all about the first two rules. I'm only going to be interested in the third rule. And all these trust connections, they produce a trust graph, and people get really excited about the trust graph. We talk to them, we ask people here, what do you like about circles? And we often hear that the trust graph is what they find most exciting. And I think there's several reasons for that. One of them is that people just love graphs, full stop. One of them is that people really dig the idea of kind of curating and engineering their personal currency. And so, projects like Trust Lines or Ripple Pay have always excited lots of people in the community. There's also this social and local nature of trusting. So Circles is fully sort of breathing decentralization and sort of giving sovereignty to the user, sort of not just at the tech stack level, but also clearly at how the protocol works. And people get really excited to think about secondary use cases, things they can do with this trust graph that go beyond just the Circle currency. But the trust graph also brings up questions. It brings up some questions or kind of confusion. There's questions like, why do we need the trust graph to begin with? And whom should I trust? Just in practice, like somebody comes up with a QR code, should I scan it, should I not scan it? What should be the criteria based on which I decide? Is the graph providing a proof of personhood? If so, how strong is that guarantee? And if not, what is it providing a proof of? And I think we, as a team or the community, we're also not yet quite decided. So there's conflicting advice floating around, such as trust all accounts you think aren't bots, or trust those who you think will provide the most value to the community. Trust the people you trust in real life. Or don't trust accounts by people that you believe might run a second account. So they all kind of pull in the same direction, but they target different underlying criteria. So this talk tries to sort of help answer these questions. It's just sort of my 2 cents on these questions. They don't represent necessarily the views of the Circle team or kind of what we're going to be rolling out or whatever. It's just me thinking about them. But why I think it matters to kind of have this discussion and think about it is because A, lack of alignment on these questions among the Circle's user base undermines trust in the protocol and hinder adoption. So if it seems like an arbitrary thing, everybody's just trusting based on different criteria, how can this become sort of the next big on-chain money? And B, if we're really committed to thinking about secondary use cases, things that we can do with this trust graph, I think we need to be sort of confident in the properties of the graph and the value proposition, right? So that if everybody's doing things based on different criteria, what is it that the trust graph is encoding? So the main points I kind of want to drive home over the next 15 minutes or so is that A, what we prove depends on our collective trusting strategy. And that's kind of a truism. I mean, of course that is true. But what I mean is that if what we're after is a proof of personhood, then depending on the collective accuracy of our beliefs in the personhood of others, we might achieve that. If our criterion is something other, another property that is sort of hidden that we want to provide proof of, then again, depending on the accuracy of our collective beliefs, we might do that. If all of us are doing different things, then probably we're not really proving anything. The second point I want to drive home is that there are some good reasons, in my view, to kind of move beyond thinking of what we're doing with the web of trust approach in Circles as providing just proof of personhood. And the third point is I want to quickly talk about how groups, which are a new construct in Circles v2, allow us to go beyond the web of trust approach. So let me start by addressing my view of the question why we have the web of trust and the trust graph in Circles in the first place. So I think that within Circles, the web of trust is primarily a technical solution to a technical problem. Circles is an ambitious project, and we kind of want to have the cake and eat it. We want to have a currency that is universally accessible in the sense that everybody can create an account. It should be democratized. The issuance should be democratized in the sense that all of these accounts can start participating in the money creation but we also want what I would call sound tokenomics. And I know this is a loaded term, sound tokenomics. I here mean something very modest by it. I mean the rate at which a person should be able to produce circles should be 1 an hour. Not more, but not less. And so if you're willing to just take any 2 of these, then it's relatively easy to see how you can do it. But getting all 3 of them under one hood is kind of difficult because of this obvious Sybil attack that you kind of open up for. And the Web of Trust is meant to address this issue. So when Martin, for example, gives this kind of advice, what he's getting at is that here's obviously an account that has on the media, is anonymous, we don't know who they are, they have no form of sort of verification, and they evidently have at least two accounts on Metri that they're sort of mixing up, right? I mean, so there's several red flags right there for why we think they are not using the protocol as intended. Right, so now how does the Web of Trust approach help us address this problem in detail? It helps me to think of, sort of construct a kind of a toy model, a mental model that I use to think about how we as a collective use our beliefs about the personhood or the properties of other people to kind of produce a currency that is universally accessible, issued democratizedly, if that is a thing, and also has sound tokenomics. So let's take the example of an online community that wants to set up a currency with democratized issuance and universal access. And the community knows that it's somehow infiltrated by accounts that have some hidden property, which, for lack of creativity, we're just going to call bad. They're just sort of bad accounts. But bad could also be a person. It could also be, people with, I don't know, well, things that you can't see, like certain chromosome structures or something. And we're going to define the tokenomics of the currency that they're going to come up with as sound if these accounts are somehow successfully occluded from the economy of this online community. So in thinking about what they should do, they come up with sort of the toy rules of circles, which look as follows. First of all, give everybody some circles. And they're all non-fungible tokens, right? Everybody gets circles. In the second step, each of the participants in the community gets to decide whom to trust based on some strategy. So they have sort of articulated a strategy and they decide, well, this is how I'm going to trust. And then third, they're going to sample a random good exchange partner. So this is this red arrow here. And so this is how this sort of day looks, or this round looks from the point of view of this one player, but now they all participate in this game. And the task is for the good accounts to come up with a collective strategy such that the economy among them is liquid, but bad accounts are isolated. So we can now kind of formally evaluate the quality of a given strategy by liquidity, which I'm going to take here as the average fraction of their circles that good users can spend, right? Spend with the transaction partner that was chosen, and adversarial exposure, which is how many circles can bad accounts pay good accounts. So we now have a mapping from every possible strategy to the quality of that strategy. And there's a simple optimal strategy, which is, well, all accounts just trust each other, and none of them trust any of the bad accounts. That's a perfect strategy. Liquidity is 100%, adversarial exposure is 0%. So far, so good. The only catch is that to come up with that strategy, you need to have known who is who in the first place. So that kind of begs the question, right? But people might not have full knowledge of this hidden property, but they have informed beliefs. They might have interacted with them in the past. So, they might have applied sort of Bayes' rule or whatever, and they might run around with some indication of whether a given account has that property or doesn't. And one possible strategy that they could kind of agree on is that each of them samples their trust as a function of their current beliefs, and they update them accordingly. Right? So here we have these accounts kind of having sort of roughly correct beliefs. And you can then show in this toy model that if there are islands of knowledge for every account, this strategy will work well. So what do I mean by islands of knowledge? I'm not going to tell you, I'm hiding sort of technical lingo here. But so quite clearly, the Web of Trust approach in this sense, and this toy model, builds on the wisdom of the crowd. And it can only work if the crowd is wise in that sense, right? If they have no clue who's who, then that approach is not going to work. Now, a couple of interesting properties of this approach are that A, beliefs don't need to be optimal for a strategy to work well. Here we have sort of a circular trust network, and so that is not the same. Sort of this person here, do I have a pointer? No. The person on the bottom left, she's only trusting the one at the top, but not on the right. So because she might have not have interacted with them, but nevertheless, they get good liquidity and good adversarial exposure. Now, this approach is also naturally resilient because you can have subsets of the economy, like the two accounts here at the bottom, that if they have accurate beliefs and they can kind of shield themselves from other parts of the honest set of the network that have fallen prey to bad accounts, they can get sound tokenomics going among them, and they are not sort of exposed to the bad decisions of others. So to summarize, the web of trust approach works as follows. If a collective agrees on some property X of people that people should have that they want to include, and they hold collectively accurate beliefs about the excellence of others, and they also choose their trust relationships according to their beliefs, then we can achieve, then we can have the cake and eat it, right? That's the kind of idea. Now, what's the implication for circles? If we, as a collective circles user base, want to have sound tokenomics mean for us 1 circle per person per hour, independent of what that person is, what they do, we know how they live their lives, whatever, then what we should be doing, we should trust all those accounts that we are confident represent the primary account of somebody. And that's the only criterion. We shouldn't consider any other information. But we might, of course, decide to go beyond that. And so I want to kind of quickly just introduce the idea that what we should be after is maybe not proof of personhood, but proof of economically trustworthy personhood, right? So if, I'm going to sort of tell you what I mean by that, but if that is what we're after, is then what we should be basing our trust decisions on is we should trust those accounts that we are confident represent the primary account of somebody. We're still interested in personhood, but we're not just trusting any person, we're trusting people whose integrity we believe we can rely on when it comes to sort of trading or dealing with them economically. And I think this is sort of an interesting way to look at it, at least for me, because I think it builds sort of on the strengths of the approach, right? I mean, personhood, to my knowledge, is sort of pretty much a binary property that people either have or they don't. But economic trustworthiness is super fuzzy. It depends on what you mean by it. So it requires human judgment. So that's exactly what a web of trust approach gives you. And that's not something that an iris scan sort of can even attempt to substitute. It's intrinsically relative, right? So the fact that different people have different understanding of what trustworthiness means isn't really a problem, right? It just means that you're going to be dealing with people who ideally share sort of a similar idea of this fuzzy concept. I think there's really lots of secondary use cases. So the idea of us being able to produce a trust graph that isn't just proving personhood, but something stronger is very interesting. And whoever of you was here when Sebastian gave his talk, and we talked about how can we sort of choose which nodes we should let expose our public IP address to, and we could sort of choose this you kind of incorporate this graph, then I think this is already one interesting use case. And I actually think that a lot of us are already doing that. A lot of us are basing our trust decisions already not just on the question of, is this a person or is this their primary account, but to what extent can I rely on them? So as a simple thought experiment, if you are not sure which of the two camps you would fall into, what is your sort of circle strategy, you consider the following example. Let's say there's an account that runs a whole bunch of Sybil accounts, and that gets discovered. So now, what do? Do you entrust all the Sybils and not the central account, or do you entrust all of them at once? Depending on the sort of where you fall, you've already made a decision. And I'm not saying one is necessarily better than the other. I just think that sort of both valid properties we might be after. All right, so that's a lot of sort of theoretical blah blah. Let's try and evaluate this question looking at the actual Circles user base. So as Circles in the team, we have a blacklist of around 12,000 accounts. And these have been, I mean, they hold around 26 million Circles right now, and that was last week. And we put together this list essentially based on trustworthy personhood. So for example, if we discovered a network of puppets, we didn't just include the puppets, we also included the puppet master, the account that actually drove this thing. And just to clarify, this blacklist, I mean, is not limiting anybody on the protocol level. You know, we as Gnosis, we cannot censor what you guys are doing on Circles. But of course, we own groups. We run groups, and as owners of these groups, we can make decisions about letting people on this blacklist in or not, right? So this is important to clarify that we have no sort of backdoor entrance in sort of sanctioning anybody here. Right, there's two groups that are kind of prominent in the current scheme. There's the Circles backers, so the group of those people that have put their money where their mouth is, and there's and sort of invested $100, and they hold around 1 million Circles right now. And there's the Metric Core group, which is a sort of a loose group of 800 people. I think today it's actually 1,200 people, and they also hold around 1 million Circles. And so we weren't very careful in who we let into the Metric Core group, but the backers, of course, they have an incentive to be very conservative with their trust. And here's sort of the numbers for the adversarial exposure, by which I mean how many Circles could accounts on the blacklist today channel into either one of these two groups. And we can evaluate this in terms of absolute numbers, but we can also evaluate this relative to the total holdings of the blacklist accounts and those of the two groups, respectively. And the answer is that for the backers, we're actually looking pretty good. The backers have successfully sort of shielded themselves from the blacklist. There's only sort of 2K out of 26 mil that can go in there. For the core group, the numbers look slightly more concerning because the absolute number is 91,000 Circles, and that constitutes around 7% of the current holdings of the core group. So either we are pretty bad at putting our blacklist together, or the Metric Core group isn't aligned on what they're basing their trust on, or they're not doing a very good job in trusting accordingly. Right, before I finish, I want to talk to you about one way that if any of you was now sort of starting to be concerned about the web of trust, or like, you know, sort of, does this mean that sort of it undermines the sort of Circles project overall? I think the answer is a resounding no. And one of the reasons for this is the existence of groups that we introduced. So, for example, protocols like Proof of Humanity or Self.zk, they can create groups and Circles that dynamically add all accounts to the group that have gone through their protocol. And now vendors or other accounts can start to decide to accept only their group Circles. So by doing so, you can decide that you're only ever going to get paid in coins that have been minted by people who've gone through some protocol, right? And so there's also, of course, a hybrid strategy where you can decide to sort of rely to the web of trust to some extent, but you also want to kind of incorporate information from external protocols. So that goes to say that Circles, in my view, is the language, not the book, right? I mean, of course, we built the protocol based on sort of opinions and convictions, but it's an open protocol, and you know everybody can build stuff on top of it. We can't force people to choose certain criteria for making their trust decisions, but I think it's a good idea to start coordinating this to kind of drive the value of this project. And yeah, with that, I'm done. And if you still haven't created a Metri account, please, this is your chance, and I'm open for questions.
Thank you so much, Paul. Before we open for questions, I just want to say that the next fireside chat will be about 10 minutes late. Not every speaker is here yet. So we'll start about 3:20 more or less.
Does that mean I have to take questions for 15 minutes?
Yeah, so you're going to have to take questions. Let's go for it. I see many hands. Yeah.
Hi, Ivan from Reactive Network here. Thank you very much for a clear and interesting presentation. So the question is, from my understanding, trust cannot be expressed as just one number. So let's say me and Bob has 10 transactions, each worth of $1,000, right? I can be confident that if I deliver the goods without an upfront payment, he will pay me later $1,000, right? But if I deliver goods for $100,000, in that case, Bob might reconsider and not pay. So I think you've probably thought about that, and it would be great to hear your thoughts.
Yeah, I mean, so I think in Ripple Pay and in trust lines, this sort of additional degree of kind of quantifying your confidence of the trust or something like this was present. And it's absent in the V2 of the protocol. So right now, trusting somebody is a binary decision. I think we definitely have voices in the team that are in favor of doing that, and I think the sort of Bayesian view of looking at everybody running around having sort of these degrees of belief between 0 and 1 about everybody else sort of pulls in that direction. But at the same time, I think the protocol is complicated enough as it is, both in terms of UX, but also in terms of just technical implementation, and I would assume, I wasn't the one making the decision about this, I would assume that we've made the decision in favor of sort of UX and that, and sort of we'll maybe see something like that on top of circles in the future.
More questions then. One there.
I enjoyed how you talked about the concept of trustworthy personhood as a way to define humanness, or a form of humanness. Right? There was an opinionated view on what constitutes humanness. In the instance where, like, let's say in the future, I form a relationship with an agentic AI that feels aligned with me, and that agent then creates a Circles account, and I want to trust that agent, does that pose a threat to the protocol, to the Circles protocol?
No, I mean, again, we don't write the rules, we don't impose the trusting. If you get a collective, like a critical mass of people who share your feelings about how they should trust each other and what sort of sound tokenomics means for them, then you just do your thing, right? And so we can't control that. We do have something we call the Circles etiquette, and we've made a decision to say that Circles is primarily a currency created by humans. And so for now, we say, AI agents can be part of the economy, but they should have organization accounts. And they can be paid and they can transact, but they shouldn't create. And so this is, I think, our current stance on this, but this is sort of what the future will see, and whether anybody will move away from this. I mean, it makes total sense to think about this, yeah.
Okay, maybe one more question. No more questions? Oh. Okay. Oh, I see one there. No? Okay. Yeah.
So my question is, with the current graph, so on the Circles white paper, there is this discussion of this possibility that maybe there's going to be a fractioning into different subgroups where there's a subgroup of people who trust each other and their currency is worth $1, and there's another one group that currency is worth 20 cents, and there's limited liquidity between the two. This is a possibility mentioned on the white paper. I want to ask you, with the real data, is it actually happening or is it not happening?
I think the short answer is we see that it's kind of happening. We definitely have groups on there that trade at different prices right now. And we're making sense of the details of this. But fundamentally, I mean, what Kelvin is referring to is something we refer to as liquidity clusters in the paper. So basically, any group of people where there's a trust graph between any two people, we kind of have a guarantee that at equilibrium, the prices of their tokens should be the same. But when you don't have those trust graphs between all connections, then you can have this sort of bifurcation or sort of triplification and whatever. And yeah, I think we have this right now.
Thank you very much. I just want to comment that I think this is actually very interesting and not a problem. I think it's actually very interesting that for this thing to happen, it's like seeing economy in the real world is really
I agree. I mean,
exciting.
so in the white paper, we're like, yes, the main goal is for this to become a globally fungible currency, and it's all going to be one price. But it was sort of almost pedagogical, the decision to present it as that, because that's sort of the simplest way to think about it. But of course, reality is always more complicated, and I think there's an interesting future of circles in which we do have a handful of these groups. I think we shouldn't have as many as users. That would be sort of, not the intention, but there can definitely be a handful. Thank you.
Cool. Thank you. All right. So just a few minutes, we'll set up the stage for the fireside chat, and and they'll come on stage. Just a few minutes. Martin from Gnosis, and Vitalik from the Ethereum Foundation. Please give them a welcome.
guys are going. You're going to be on the sides. You guys are in the middle.
You're over there. Yes. All right, yeah. Hey, everyone. Cool. Let's directly jump into the discussion. So one of the first, the first DappCon was in 2018. So, well, it's been a few years, 7 years. And back then we already had a similar panel, and we were asking the question, okay, who was on the panel? The two of you, and I'm not sure who not Robin, but some unnamed person. I need to look it up who the first person was. Yeah. But yeah, so we were already asking back then the question, what would success would look like, and also what could go wrong. So kind of what are what are the potential positive outcomes, and also how would they be measured? And maybe that's my first question into the round is, if all the things we are trying to build go right, what measurement or what societal KPI would change, and in what way? And then of course we can connect it to, has that already happened? So maybe, directly starting with that one with Joe.
Sure. Metrics that would indicate that we've succeeded would be applications being used, lots of applications being used by consumers and businesses. Truly decentralized applications. We've got a giant internet and a giant Web 2 out there. A lot of Web 2 is pretty exploitative, and so Ethereum is now scalable horizontally and vertically. It's quite usable. It's going to get very usable with AI in the interfaces. It's affordable, and in most of the world, it's now legal to use tokens, to issue tokens, to participate in DeFi, and that it's going to get increasingly legal. It's going to get legal to build applications and not worried that some regulator is going to come after you. And so I think the broadband moment is here, and we're going to be able to move Web 2 applications to their replacements on Web 3, and it's going to be more economically and politically empowering for people, because builders are going to be able to build of, by, and for the community rather than in an adversarial and exploitative relationship with the consumer. So giant population moves from Web 2 to Web 3.
So I hear kind of course, adoption. The second thing, but I think we do agree that adoption, or that's not the only thing we care about. We want to, and then the second part was, you say the relationships are less exploitative. Can we try to boil that down, or just measure that in some form?
Right. I mean, I think like the one sort of meta metric that I would use to like critique metrics is basically if what we as Ethereum had done is basically sold the rights to the Ethereum name to Sam Altman for $999, and then the project just shut down, then like by that standard, would Ethereum be extremely successful today, right? And obviously, if you define
could have been
right, exactly,
he almost won.
If you define the metric too naively, then there would have been totally lots of Ethereum users, and we'd be talking about like Ethereum for militaries or like whatever it is the AI people talk about, right? And obviously, of course. This is like we do have like specific outcomes in mind, and so I mean I'll propose one. Let's take averaging over like all of the different pairs of countries. How long does it take for the just either any person or potentially we could even say like a politically disfavored person to send a transaction from one country to another country. What delays do they incur? What % of that transaction do they lose? Like basically measure to what extent we've reduced global, the inequities of global finance. And I mean, arguably, you could even say there have been some successes, at least if you take a sort of, like post hoc or go propter hoc bias, and you look at like, hey, look at what PayPal fees were like in 2013, and like look at what both crypto and non-crypto is like now. And then do a similar thing across other categories of application. So I don't think that would cover everything, but that's like.
Let me give you 3 metrics. The internal one is investment relative to customer revenue. For a long time, we've had a lot more investment than customer revenue. That has to change to become a stable industry. So we hope to see customer revenue go way up to match investment. Second is prices. One of the things you might hope is you're going to reduce the prices, as you just said, on some key services people have in the world, and we will see the effect of crypto as this was the era that made the transition between high prices and low prices for some key financial services in the world. But the third metric I would most hope on is there's some new things that we're going to generate, new products, new features, new things you can do that didn't exist before crypto, and people look back and say that was the era where they started to make things. Crypto is really inventive and innovative compared to many other industries, and that's my biggest hope for crypto, is that we will invent stuff that lasts. And this will be the era people remember of invention.
We've invented lots of stuff, but do you feel like the roughly 10 years of the speculative phase in our ecosystem were necessary and reasonable, and we're now, all those things that I mentioned, we're approaching our broadband moment where we can have people build things that are actually useful, that will garner revenues. We'll still have a lot of investment and a lot of speculation, but I think we needed all of that crazy investment and speculation in order to build layers and layers of enabling infrastructure. It's hard to move a society from top-down command and control to bottom-up decentralized trust.
I remember, I think 10 years ago in Hong Kong, I took Vitalik to task and I said, look, you guys are doing way too much tools and platforms. You need to have end customer revenue. And he, of course, the whole field ignored that and spends all this time on platforms and tools. And I sure hope you're right that we needed to do that and we've finally done enough and we're finally going to use it all. But I'm worried a bit because this habit of tools and platforms is pretty strong. So somebody needs to get in the habit of end customer revenue.
Yeah, the whole field didn't ignore that, or maybe they did if you don't consider Binance to be part of our industry. So there were lots of people that went straight to product and revenue. And if that was all that we did, then we wouldn't have a chance of decentralizing the world.
Right. I mean, the finance bro take on this is that that was a consequence of the zero interest rate policy era, right? Which is that when basically investments were encouraged to do something that looks on the surface like caring about the long term, but actually that's very hard in practice. And so they cared about proxies, which were basically impressing the next fool who also thinks they care about the long term. And now we're in a very different environment. So this is one of the hypotheses that I see people talking about, which might force more near-term focus on its own.
I think the discussion is related to some question. I mean, we were jokingly discussing at some point whether Ethereum is more like a tech startup or more like a religion or ideology. So it seems that that kind of to some extent economic rules are different in crypto. I guess. Of course, there's Bitcoin as
So I'm an economist, economics professor, and our standard textbooks make these nice distinctions. Well, there's for-profit firms, and then there's non-profit charities or clubs. And crypto just doesn't fit those categories very well, which is striking. There was this remarkable synergy of capitalism, greed, idealism, and aspirations that has made this work. And if we can finally make it pay off, it'll be a triumph of that sort of thing in the future, I guess, but it throws out the usual categories. People often don't think you can combine greedy, even rapacious capitalism with idealism and producing grand new things that achieve community ideals and not necessarily personal ideals, but
yeah.
wow.
So if Ethereum was a tech startup, it would have failed. We talked to VCs early on, and we decided to go in a more decentralized direction. Ethereum was a vision and values-driven project, and because of its crazy, haphazard, self-selected nature, where anybody could select to be in the community and everybody could select to be an early contributor on the project. It was complicated, but it set a certain kind of ethos. And so I would call Ethereum a new kind of thing. I would call it a tech ecosystem startup. And ecosystems have their own culture, and religions are everywhere, and so it's absolutely a religion as well as a new kind of thing.
I mean, keep going. No.
Okay. So, no. So, what certainly allowed that, whatever it is, it allowed permissionless innovation, and we saw that with all the layer 2s and kind of lots of, platform building and tooling being built. And in a way, I think that was a positive. But I would say, and I think it seems to be happening more and more, that there is this innovation, and then there's innovation around those and so on. But the question is, will it I think it's not a secret, but that there is a question of fragmentation, and will there be, or are there forces that bring things together again? And and of course, is there a risk, what's the risk of failing against ecosystems that are more coordinated?
Yes, it's a real risk.
Yeah, the risk exists. I think this is definitely one of those situations where I think part of it just is that we have to invent the solution as we go, and because Ethereum is a very unique type of structure and ecosystem, and a very unique mix of goals and incentives that are aligned in some cases and not aligned in some cases. I think, in terms of we can, list strategies for trying to solve things. If we define the problem as being standardization, but that's only one of the ways of thinking about it. Basically, the way that I usually enumerate the strategies are basically, one is, of course, virtue signaling, which is basically, you have a culture where, going along with some either standards or principles is valorized, and this is something that gives you better standing in a community, and I think every community everywhere relies on a non-zero extent of that, but it's also very possible to over-index on it. Then two is some organizations, which could be the Ethereum Foundation, or potentially it could be other groups. You could even have two sectors basically doing this against each other. What the tech world calls commoditized to complement. Basically, something like the Ethereum Foundation could write the software that makes the right way of doing things closer to zero cost because the software already exists. Then a third option is just transparency, right? So to the extent that people agree, at least abstractly, that something is the right goal, then like make it more transparent. I mean, like what strategies and like what projects are actually doing what things toward that. And I mean, right now the Ethereum ecosystem has used some mix of all three. I mean, I actually think that the second strategy that I mentioned is probably one of the more undervalued ones. And so, like within the foundation, we've been like exploring the idea of doing more in that regard. Like actually, building more software packages that could be like built like that actually touch things at the user layer or like somewhat closer to the user layer that reduce the development effort of like following some standards, potentially like following along with some like shared security goals or other kinds of goals. But I don't think it has a single solution.
So every time I buy a new toothbrush, it has a different charging mechanism.
So I mean, I made a point.
I think there's EU trying to solve that, but yeah.
Yeah, that one is interesting because I did make a point of like finding the few toothbrushes that charge with USB-C, and it definitely is tricky. I mean, it's. Well, the thing that probably made it more easier recently is, I mean, actually, I mean, AI has made it easier because it's like basically like as a more powerful search engine, right? And I could say like, tell me the USB-C compatible versions of a thing, and like, you could do this before with search, but the AI-based tools make it one step easier. So arguably, you could say that this is a form of transparency.
Yeah. So. I think there is a chance that Ethereum is replaced as the world computer, the decentralized infrastructure on which nation states and major corporations and other sub-ecosystems are built. But I think the chances of anything displacing Ethereum at this point are minuscule. There's nothing out there that could replace Ethereum. Everything out there other than Bitcoin and Ethereum, looks kind of like a company. Bitcoin and Ethereum are the only two credibly neutral and decentralized platforms out there. So I would argue that the roll-up-centric roadmap makes a ton of sense. We've been in this divergent phase. We're now in a convergent phase where we are going to figure out how to make everything synchronously composable or near synchronously composable. And anyway, people are going to be building applications with SDKs and wallets and with AI agents speaking to different blockchains. And so people are just going to be using applications, and some of the backends will be on different networks. So I would argue that a year from now, it's going to be very clear. So many institutions are coming to us and wanting to build on Ethereum, to build on layer 2s or build on layer 1. A lot of that's about stablecoins and real world assets, but the applications are going to be coming. So a year from now, I think it's going to be very clear that, well, there are going to be some cool layer 1s and some cool layer 2s and some layer 3s. But really, Ethereum is going to be the major decentralized protocol substrate. It's going to be, Ether is going to be seen as a trust commodity, and from that, it'll get its monetary premium.
So one way to frame the question is, what's the consumer demand for the credibly neutral, decentralized part of these products? Because other people can offer similar products that lack those features, and plausibly they're more nimble, they can more organize marketing campaigns, maybe they have cheaper technology. There's the fear that they could displace because most customers don't actually care that much about the decentralized, credibly neutral part until there's a big crisis, perhaps, which would then make the big lesson for everyone. So then 3 different scenarios. One is no big crisis, and then people just drift to the other thing, and they lose the key thing you treasure. Another scenario is there's a crisis of some sort, whereby everybody sees the virtue of decentralized, credibly neutral because of the terrible disaster that happens with the alternative. And a related crisis would be, a market crash, because we've had many of those over the last century where tech rose and inspired a lot of high prices and then a crash. And then in a crash, some of these for-profit competitors might be swept away, but the community-based ideological group might persist longer and stronger because they have other reasons to go forward.
Yeah. So I would argue, based on who we talk to in the traditional economy, that high-valued assets and high-valued applications and protocols are going to be attracted to a network like Ethereum, layer 1, because it hasn't gone down in about a decade, and it's pretty clear that the best and the brightest are continuing to build it. We struggle with each other all the time, fighting things out to build the next evolution of the protocol. But in terms of guarantees like credible neutrality, and that it's going to be working every day for the next 10 years, those are tough to beat if you're a financial institution, at least.
I guess uptime is a metric. Yeah. So Robin, I know we're here because we all really appreciate you as an Ethereum co-founder, but I want to ask about a totally different tangential topic, which is prediction markets. This has been a big part of Ethereum lore basically since the beginning, right? And there was Augur at the beginning, and then even outside of Ethereum, Truthcoin and Paul Stortz's work, and then since then Polymarket and
So wait, there was another project. What was it called? Do you remember?
What was it called again?
Right, Omen. Yeah. Indeed. Omen is great. So I guess I'm curious, compared to your expectations of this space back then, how do you feel about the impact that prediction markets have made since, the idea and our attempts to make it happen have started?
So the audience might not know that there was a burst of interest in prediction markets in the aughts. And then many companies explored and tried, and many firms were pursuing it, and then that interest faded. And there was a period of disinterest and low activity, and then
faded
crypto.
Because of the CFTC, or the interest
faded because of just lack of business interest. That is, there were some things CFTC messed with, but basically most executives are shy about implementing prediction markets. So they hadn't been implemented well enough, not enough marketing, whatever, but product failed temporarily. Yeah. And then crypto people started seeing it as the sort of thing.
You're complaining about users not using our technology.
Right? No, it's the issue, right? Yes.
Yeah, exactly.
Can you make something users want? Yes. But then crypto people saw this as one of the key applications that they could imagine selling through a decentralized neutral platform. And so that was part of the initial appeal for many early crypto projects and platforms. And then they took a long time to actually get much user revenue traction, but that's okay for crypto, apparently. It's all right to have a long lead in, but then in the last few years, we've got this burst with Polymarket, and that's great to see. And that will certainly lower costs, because the more you pay for an infrastructure, the more you can make lower cost other things. And so I'm, of course, most excited that these lowering costs will allow us to expand into other markets. Yeah. That is, we've had betting markets for a long time at a modest cost, and lowering the cost of betting markets does increase the demand for them, but the elasticity of demand isn't that high. There's a limited demand, I think, for just speculators betting on things. There's, lower price will increase it, but I'm envious for or eager for this vastly larger market out there that eventually we could tap, of people who need to make decisions, who want advice, and there's huge value there, but that's harder to tap. That's what people were trying to tap in the aughts, and that's a harder nut.
To what extent would you say Polymarket is on the level of being entertainment, or already being used to, how close is it to being used?
For many technologies, you can sell them to different customers for different purpose, even the technology isn't different. So betting markets is basically the same as insurance. Insurance is one market, then there are just speculative entertainment. People just want to bet for fun and get the action. That's another market. But there's this third market of people who want to know things. And that's, in principle, a huge market. And hopefully, crypto can help us penetrate that, but it will require more than just lowering the cost on, say, polymarket-like tech. It requires a lot of business innovation. That is, you have to try it out in businesses, figure out different ways to do it, different ways to pitch it, collect track records, and then finally get success. So that's what I'm hoping for, but we're definitely not there yet.
Yeah. So prediction markets need users, liquidity, lots of different propositions for different prediction markets. You've been doing some work on enabling prediction markets to be stood up and monitored by AI. You want to talk about that a little?
Yeah, I mean, yeah, we do. We're always interested in this information, using prediction markets to make decisions, and for that, it is important that those who pay for this information at a reasonable cost. And it seems like AI could be a participant who, or AI agent could be a participant that can deliver information at reasonable cost, and the prediction market can be a good mechanism to aggregate all the information that all the different AI systems can produce. Yeah.
Right. That's focused on the supply. I would say the limiting factor is more on the demand side. You have to convince the customers a form of the product that they can find acceptable, because the usual default forms look like they don't like them.
Unless they're a bunch of agents.
If you can get the agents to buy, sure. But
exactly. They might be demanding it as well.
Yeah, no, they're not well funded.
The one larger other topic complex, last topic complex, is money and future of money. So obviously, kind of, well, again, Bitcoin maybe raised that question, and I think we are seeing now, big institutions at least having that form of discussion. So, I guess my question is, how will money look different in the next 10 to 20 years? And what's your...
I'd say that crypto has had this sort of fluctuating attitude toward government and regulation. Mm-hmm. Initially, the pitch was, we can ignore government because we're on the chain and they can't stop us. And then we transitioned to most firms saying, oh, we're following all the rules. We're completely compliant, don't worry about us. But the energy of making new money is somewhat of a government-defying energy. People are somewhat like, the governments have run in money for a long time, right? They've controlled money, and their national prestige is tied around their money. And so to have a non-government money is somewhat of a threat to government prestige. But that energizes a lot of crypto people. Yeah, let's take them down, like, revolution. But then people shy from the revolution when it comes to actually...
Yeah, so Ethereum was...
They go from the revolution to the revolving door.
Yeah, true. So Ethereum may have had a few crypto-anarchists in its midst, but it was much less crypto-anarchist than Bitcoin, because it was people trying to build a platform for...
I disagree. I think we're more crypto-anarchist than Bitcoin now.
More? Now we are.
Yeah.
Okay, so that is interesting. And so I have two answers to your question. One is a near-term answer, which is relevant to what you just said, and then one is a much different, longer-term answer. The near-term answer is that the world is cracking up. We're at the end of a debt and generational supercycle, Strauss and Howe supercycle. We are smashing up against the wall. There's too much debt in the system. It is clear to the world that the United States is going to reformat trade relationships, military relationships. The US is paying 25% of its budget in interest, more than its military budget. And the US wants to maintain primacy in the world politically, want to maintain the US dollar as the main reserve currency. And the way it seems to want to do that is because American politicians have made it clear that austerity is un-American, so they're not going to be able to pull back on spending. So Scott Bessent, Treasury Secretary, has pivoted and said, okay, we're going to grow our way out of this mess. And legislators are making rules, stablecoin rules, market structure rules, to enable the US to start using our rails. And so over the next 10 years, there's going to be a race to keep the US dollar strong via stablecoins. So our ecosystem is going to be lending money to the US. And what seems to be going on is projects like Michael Saylor's strategy and Cantor Fitzgerald and Tether are doing this 21 project. Our company is doing a project called SBET, or SharpLink Gaming, where they're accumulating Bitcoin, we're accumulating Ether, and I think what money looks like in the next 10 years or longer is some sort of thing that looks like a US dollar is digitized, is sitting on high-powered money like Ether and Bitcoin, and probably gold if you're holding the metal, and silver if you're holding the metal. It can be tokenized. And so I think there's a race right now to build giant pools of high-powered money. In the more distant decentralized future, I think the nature of money qualitatively changes, where it's going to look more like barter. When we tokenize all the things, you can just trade tokens back and forth. If I want to buy something from Martin, I will have a list of tokens I want to get rid of. He'll have a list of tokens he wants to accept, and the machines will do the foreign exchange calculations. So I think money kind of goes away and the machines take care of it.
One brief question I wanted to ask. So with SBET, you sometimes recently get compared to wanting to be the Michael Saylor of Ethereum. Now, Michael Saylor has stated this opinion that he believes that self-custody is something that they should not be striving for, and people shouldn't generally hold their money in their Bitcoins in banks, and self-custody is for criminals. And so, Mr. Saylor of ETH, what is your opinion on self-custody?
Well, we publish a wallet called MetaMask. So obviously, I'm a decentralization maximalist, and I think it's embarrassing that I have a lot of respect for Michael Saylor. I think he's doing some impressive things, but I think it's super toxic to suggest that that Bitcoin should be custodied. I think people are believing that, including people in the upper echelons of governments, are believing that Bitcoin should mostly be sitting in centralized custodians, and that way it'll be able to participate in some bastardized form of DeFi. And so I am worried that there will be a barbell emerging where we've got Bitcoin on the one hand, and maybe nation states get behind something centralized like Solana on the other hand, and then we've got a continued war of decentralization versus centralization on our hands.
Cool. I see the time is over. Do we have time for a couple of questions?
First of all, let's thank them. We unfortunately just have time for one short question. We have quite a bit over time, so questions? Questions? One question there.
All right. Thank you so much. Based on the last topic that you guys talked about the money topic, what do you guys think about universal basic income as an idea? What are your thoughts about circles that Martin is building?
So nice plan. I think the circle system is an incredibly cool project, and I think it is an interesting potential future of money. I like the idea of universal basic opportunity, where you're not giving everybody a bunch of capital to spend, but you're giving everybody opportunity. I think AI is going to make that much easier to implement, and so everybody should be able to put some effort in, get supported in putting that effort in, and create something that they care about.
I'd say it's an example of crypto being very innovative and creative. Like, it's a fount of these interesting ideas that I like to see experiments with. I'm not so sold on that experiment, but I don't need to be sold on each experiment to want them to be tried. I want it to be tried.
Yeah. I mean, I'm also excited about circles for a non-money related reason, which is that I think like some kind of online identity is going to become a very important thing to have. And we have plenty of projects doing wrappers of like passports and government ID, and we have WorldCoin, and like those two are both becoming quite successful. WorldCoin is over 10 million users, but there are definitely elements of centralization in at least the consequences of I think designs that have like singular identities. And to me, circles can be a powerful way of just experimenting with and even using the money aspects to help battle test a form of identity where the issuance mechanism is more decentralized and more like social graph driven. And I think this is like a third corner of the identity triangle that really deserves to be properly explored on.
Cool. Thank you.
Thank you. Thank you so much, everyone. We'll do a short break of a minute or two to set up the stage for the next speakers. All right. We're going to start the next talk. Please sit around if you're staying. Don't mess up with the noise. Okay, so next up we have Jacob from SAFE, Marina from EUCI, Patrick from Circle, Karan from Gnosis, and Monica from Gnosis. Please give them a welcome.
So welcome. We're here to talk about crypto regulation in 2025 and beyond. I have here a great panel that covers topics that have been discussed in the crypto legal space for a while now. And before I start with getting into the individual areas, I'm curious to know from each of you, what is the current state of implementation of MiCA?
Do I start?
Yes, please.
Hi, everyone. So what is happening at the moment is that MiCA is applicable. That means that when it comes to stablecoins specifically, Patrick will say more about it, it's already applicable. So it means that stablecoin issuers in the EU have to be compliant with MiCA. The second part that regulates issuance of tokens and also stablecoin, basically service providers, so CASPs as we call them, it really depends on the member state. Some member states have already implemented MiCA, or they have this deadline that has already expired, and it basically is implemented. For some, it depends. I think that the last one is going to be, let's say France is one of them, that the deadline for the application is going to be in a year, so end of June 2026. Until then, all the crypto as a service providers have to be compliant with MiCA. So that's very briefly. Of course, we have a lot of other open questions. There's a lot of discussions between national competent authorities themselves, because those are the ones that are supervising and giving licenses. And we do have 27 of them, plus 3 in the European Economic Area. So you can think that there might not be, the discussions might not be identical with all of them. And there are some open questions at the moment where we see that they might be differently answered by different national competent authorities. So this is maybe a challenge at the moment.
Yeah, from my angle, hi everyone, I'm Patrick, great to be here, and certainly a difficult fast follow for us, right, straight after Vitalik, and to jump right into MiCA, but so from my point of view, it's going well. So as Marina mentioned, for stablecoins, it's been roughly a year now. There are roughly a dozen MiCA compliant stablecoins out there. Both on the euro side, on the dollar side. We're super proud to be the largest MiCA compliant issuer for now, and we have invested a lot of resources into that. On the stablecoin side, there are still a few, I would say, discussion topics, like the interplay between the payments regulations that applies to EMTs or not. And the EBA has recently published an opinion on that, and that remains a big topic for the different national authorities on how to implement that. And I think overall what we've seen is that MiCA is being implemented as expected at the end of the day. The companies are applying for their licenses. Those tokens that have decided not to seek regulations are slowly but surely being delisted. And clarity is provided by the authorities where needed. So I think on the regulatory side, it's proceeding. On the market side, it's way too early to tell whether this entire endeavor is successful or not, right? We have to let it settle, I think, for a year or 2 or 3, and then probably come back here and look at what are the volumes at MiCA regulated CASPs. Are they able to tap into global liquidity? What are volumes of MiCA regulated stablecoins? How are they being used in Europe, and what are the regulatory barriers to that? So on the market side, I think it's way too early, but promising start.
Yeah, hi everyone, I'm Jacob. I'm helping the product team at SAFE to kind of steer the new environment, and there we're facing the challenges around interfacing with decentralized products and protocols, and if that is kind of a centralized bottleneck that might fall into certain kinds of regulations. And there I'm working with the product team, and I feel like we have found a path for ourselves, but I guess it's the challenge that it's a very modular kind of platform that we have, and we always have to dig deep into the different features that we plug into our platform, basically, and understand that they are truly decentralized and then steer clear of MiCA regulation.
Hi, everyone. I'm Karan. I'm at Gnosis, and coming more, I guess, similar to Jacob, coming more from a kind of decentralized infrastructure perspective. I think it's still unclear where MiCA is going to fit in to all of that. There's still questions around how DeFi might be caught. We've already seen diverging opinions from different regulators on how they view that, and that remains to be seen how it plays out across the rest of the member states. I think it's also too early to say how successful or unsuccessful MiCA has been, because many countries within the EU still haven't even implemented their local laws to give effect to that. So there's many places in Europe where if you try to apply for a MiCA license, you literally cannot today, because there isn't even an authority that's designated to supervise that, right? The other thing which will be really interesting to see, I think, is how many registered VASPs actually make that conversion over to CASPs, right? Because I think there's a few thousand that were registered before MiCA came into force, and there's only, I would say, 20 or so that are regulated as CASPs today. So there'll be, I think, over the next 12 to 18 months, a lot more visibility on the willingness of projects to be fully compliant, whether it makes sense for them to pursue that kind of full licensing regime in Europe, or whether we start to see more kind of regulatory arbitrage in places like the US, where there's a much more favorable environment, or other jurisdictions that are trying to attract more projects and create more favorable environments. So definitely still wait and see, but still a lot of unanswered questions in respect to how MiCA might apply to DeFi, self-custody, and other products and services that remain core to the values of decentralization.
And Jakob, you mentioned the modular system that SAFE is using. MiCA does not define what decentralization is. So how do you navigate in this landscape?
Right, so the core is obviously self-custody, so that is obviously a big benefit that we have. But then we try to help our users to interact with DeFi protocols, and there we try to understand what are we implementing and at what level. And there we have like a modular approach where we have safe apps that can be onboarded in our app store. But we also have deeper integrations, and there we're currently exploring how deep can we integrate and kind of be on this sliding scale between a perfect UX and staying, handing over to another service, clearly showing, okay, this is now the responsibility of somebody else and not us.
And Marina, you speak with regulators. You are the bridge to the industry with the European Crypto Initiative. So where do you see us moving to? There is then Savings and Investment Union that is arriving. What other regulations should builders and developers be aware of?
Yeah, so in the previous mandate, the European Commission was really focused on MiCA. They were discussing the anti-money laundering laws and the travel rules. You have heard very focused on crypto assets. Now this is done for them. So in Brussels, more or less, they have already decided this. The big decisions and the licensing is really happening on a national level. But with the new Commission, starting with the new year, 2025, they are focusing on tokenization. This part, I think, could be interesting for the industry, just because it's something that many projects are looking into, connecting DeFi, TradFi, similars. But at the same time, there are questions that are opening up, mostly on the infrastructure level. So thinking about, are there any limitations for permissionless blockchain to be used in tokenization when it comes to tokenizing bonds and shares, etc.? Of course, this is where we come in and try to explain that it's perfectly fine and this should be done, of course. But there are questions opening up. And this is a new thing because in the past, we, again, mostly discuss the crypto assets in a way, nature. So is it a security, a utility, etc.? And now we go more into the technical aspect, which is pretty interesting in a way. And you might have heard also of the recent European Data Protection Board guidance on blockchain, how to use GDPR when it comes to blockchain. And those were really strict as well. It's not a regulation, just to be clear. It's really just a guidance for now, a draft. We have responded. If you're interested, you can go on our website, EUCI, and find the responses there. But it is something that needs to be answered. And I think it does require the industry to go and talk to regulators and explain the potential of this industry, this tech, for it to be used in different industries, and specifically within the EU, where we do have a pretty strict data regulation, not only financial regulations. So it's also a topic that needs to be addressed.
Maybe I can just add to that, like GDPR is definitely one aspect. We're already starting to see other forms of regulation emerging which are going to have an impact on this industry, right? So we're seeing things like DORA, the Digital Operation Resilience Act, that has a major impact on regulated financial services providers. So that's in addition to MiCA, or in addition to payment services or MiFID, it brings a new level of regulatory compliance. And there's also proposals now to introduce cyber resilience regulations for products that fall outside of the scope of financial services, where you need to have sufficient, overview and due diligence on the entire supply chain of technology providers that make up the tech stack through which you provide your services. And that raises new questions. So if TradFi now want to access DeFi, how do they comply with those measures? Who do they go to? In many cases, DeFis are run by communities or DAOs. So it's going to present some challenges. But I think the message is that, MiCA was one aspect. GDPR has been there for some time, which there's always been that conflict between, data protection and blockchain. Now we're starting to see other elements that are also going to have regulatory impacts on the industry.
So Karan, we heard last week from the US that DeFi platforms should not have regulatory barriers. So where do you see DeFi heading the next months or years?
I'm still very bullish on DeFi as a technology and what it gives people access to. I think that we will still continue to see innovation around the world. For the moment, I think we're in a space, at least in Europe, where there doesn't seem to be too much enforcement, but there are differing opinions within different member states as to where DeFi should fall. I think everyone was under the impression that MiCA wasn't there to regulate DeFi, and so far it's not. But this is where there's different interpretations on who is an intermediary, right? And to Jacob's point earlier, does an interface qualify as an intermediary that should be caught under MiCA? And I'm not sure what the answer is there, but I think we still have a lot of work to do as an industry to make sure that we carve out a path for DeFi, because it is, true to the values of blockchain, permissionless, credibly neutral, and access to everyone, which many aspects of the traditional financial system still exclude a large proportion of the population.
Mm. And Patrick, when we see the expansion of Circle during the past 6 years, while MiCA was discussed and finally implemented, and when we see how liquidity pools and DeFi are USD-centric, where do you see a possibility for European stablecoins to gain significant market share? And is it realistic?
I'm relatively optimistic, but obviously I don't think we should expect a hockey stick development overnight. I think it's rather steady and slow growth that we'll see over the next few years. We're quite encouraged ourselves by recent growth of the EURC, our euro-denominated stablecoin, which essentially when we launched it, under MiCA officially, roughly a year ago, it was around like 30, 40 million market cap. Now at least we're at roughly 160, 170, I believe. So there has been some growth, and part of it was powered by DeFi. So I personally think that as those different worlds converge, for example, DeFi is more and more integrated into fintech, so the DeFi mullet thesis to some extent, but also into TradFi. So if people start, for example, collateralizing their crypto assets to take out a loan and finance their house or their car or whatever. I think this will increasingly happen in the currency those people use on a day-to-day basis in their jurisdiction. And here in the euro area, it's the euro. So I expect some growth there. Same for real-world payments use cases like cross-border transfers. I do think that, for example, once we build those on-chain FX pools, let's say USDC, EuroC, or other stablecoins, you will have increasing volumes and increasing usage of euro stablecoins also for that part. Even if the actual transfer happens in a different stablecoin, you need the euro for the on and off ramp. And for some corridors where the euro is particularly strong, let's say the euro area and North Africa or Turkey or like Southeastern Europe, I do think that the euro stablecoins will increasingly see usage as a cross-border payments tool. So let's wait and see. I don't want to sound too bullish, but I think there are some real-world use cases both in DeFi, in cross-border payments, in capital market settlement, where the euro will play a major role.
Are there any thoughts from the panel?
I think that's a huge opportunity also for the crypto space in general. We are also very closely looking at this, and it stands for kind of this merge of two worlds. And I think the challenge will be to kind of identify these new intermediaries that come out of our space and kind of find a way how they can best interact with the old guard, so to speak. And I think we are on the right path here, and stablecoins stand for that. There's more to be clarified on the product side, on the application side, and that's where we need more clarity that MiCA so far does not bring. But I'm optimistic that we will get there with good products.
Just to add one tiny thing, I think what's increasingly important also for MiCA and Europe is we have settled this framework, right? And so I think we should start, and increasingly we should start looking outside of Europe and find ways how to make this framework compatible with other global jurisdictions, major financial jurisdictions, because this is where then the real power sits, in my opinion. We're talking about stablecoins, crypto assets, DeFi, inherently, natively global services and products. And so MiCA alone won't take us too far. But if we find a way, for example, to make MiCA compatible with the upcoming US rules, UK rules, Singapore, etc., to allow for cross-border usage of those assets, cross-border usage of regulated services across the board, I think this is where the real power waits.
So I would like to close our discussion with some final thoughts from all of you. So if you would have some ideas for developers or builders, what should they be aware of during the coming months or years?
I think first and foremost, it depends on what you're building, right? If you're building a trading application, you're building some kind of synthetic stablecoin, or you're building a lending protocol, there's going to be much more regulatory implications in those types of products. So I think you need to have a very clear idea, first and foremost, what it is you're building. And at an early stage in product development, understand where the regulatory touch points are. Because there's a lot of evolution in the regulatory landscape today. And you might build a product which is amazing, and there's demand for it, but you might get stuck with regulatory limitations going forwards when you want to distribute that product. So my message to builders is, at a very early stage, start thinking about these questions. Start speaking to people who understand what's coming, what's already in place, so that you don't find these blockers in the future.
Maybe I would say think about the market and go-to-market strategy as well. So if you are interested in the European market, you would need to look into the regulations, as you mentioned. Think about not only MiCA, but as Karan mentioned, there are regulations that are touching upon the tech itself. There might be exemptions for, let's say, open source, etc. But it's not that if you don't have any crypto asset or similar, is that there's no regulation that applies to you when it comes to offering services or products in the European Union. So I think that the EU is quite an attractive, interesting market. It's pretty big as well, and thinking about that in advance, in early stages, could help as well in the dissemination of the product.
So I would say I'm incredibly excited about all things payments. So one thing that I would look into is, for example, stablecoin checkout experiences in online commerce. I think there's a lot of room for improvement there. On-chain FX markets, I think, are a key foundation for whatever cross-border payments might happen in the future. And then lastly, and this is potentially a little bit connected to regulation, is added services for on-chain payments or stablecoin payments, settlement of tokenized assets, services around chargebacks or fraud and how to handle all of that. Requires, I think, deep knowledge of on-chain infrastructure, but at the same time, European and international payments rules. And I think there's a lot of stuff to build there. So, and allow me one maybe shameless plug. We're obviously super excited about supporting any builders, developers in the space. We have built on Circle developer services platform, Discord. So feel free to check that out, and hopefully we can support you as well as possible.
Yeah. And I would just add, if you're starting off, don't let this complex regulatory environment kind of scare you off. I think if you're passionate about a problem that you want to solve, just get it started and don't let the lawyers scare you. If you have a good solution, you will figure out a way how to navigate this, if it's by partnering with somebody that has a license, or if it is by going more into the infrastructure route that is less prone to falling under financial services. I think there will always be a way, and don't let it stop you, and keep building.
So thank you all for your thoughts. I'm sure we have taken something valuable from it. And if you have questions, don't hesitate. We are around.
Thank you. Thank you. Thank you so much, everyone. Yeah, if you have questions, find them around. Feel free to ask the questions. We'll go for a break now and be back at 4:45. Yeah, see you soon. some sun, be ready for the last part of DappCon. And to start this, I'll invite on stage Edmond from reality.eth. Please give him a welcome.
Thanks, Fernando. So I'm going to be talking about Blue Sky and AppProto. I should be clear, I'm not going to be speaking for Blue Sky. I don't work for Blue Sky. I didn't help design AppProto. I do reality.eth, which is a smart contract oracle. I'm going to talk about AppProto because I like it. But what I've done is, if you go to my profile, Goat Navy on Blue Sky, I've pinned a link to a whole load of stuff, including some stuff by the original people who actually did build AppProto, and a whole bunch of other resources. That's not good. Do I need to point this somewhere? Not seem to be moving to the next slide here. Here we go, okay. Okay, so long ago, the internet kind of looked like this. If I wanted to publish something and share it with my friends, I would make my HTML page and upload it to my web server. And then you could use your browser to download it from the web server. This, of course, is not a peer-to-peer arrangement. It's a client-server arrangement. But it has some really nice properties that we're often looking for when we do peer-to-peer stuff. So anybody can publish. Nobody can stop you publishing. You can self-host if you want to. I think at one point I did. But normally you use shared hosting. And the great thing about when you're using shared hosting is it doesn't really matter what the hosting does, right? The hosting is unopinionated. The hosting doesn't have editorial control over what you're putting on that web server. And if the hosting does screw you, then you just like move your DNS over somewhere else, restore from backups, and then you carry on, right? So the user doesn't really notice. But then we went a different way on the internet. We did Web 2.0. And this brought us a load of stuff that was missing in like the original Web 1. That we wanted like social connections. We wanted the social graph so I could see what my friends were following. I wanted to see all my friends in one view. We needed identity built in. We needed like data structure. So on a tweet, you've got a tweet and a retweet and likes and all this stuff. And we also needed kind of resilience. So often in the early web, if your thing went viral and you got a lot of traffic, the web server would fall over. We solved that in Web 2.0 by everybody using the same like 3 websites. Right? So we had an internet that looks more like this. All your stuff goes in a database on some guy's web server. One of those guys was Jack Dorsey, Web 2.0 entrepreneur. And sometime in about 2018, he went to Myanmar and he meditated in a cave. And he came back and he read a thing by Mike Masnick called Protocols, Not Platforms. And he said, you know what? I shouldn't have editorial control over your entire life. Twitter should have been a decentralized protocol rather than a centralized server. So he got together a team of people that was supposed to decentralize Twitter. And that brought us what was originally the Blue Sky project and AppProto. So the constraint that these people had in building AppProto was it was supposed to be able to run Twitter. Okay? So that means it's got to scale to the size of Twitter. And you also have to have a user experience like Twitter. You can't say, this is decentralized, so you're just going to have to suck it up if the notifications don't arrive or something. It has to work like a normal Web 2.0 product from the point of view of the user. So they designed AppProto. Then while they were doing that, Elon Musk took over Twitter, and they ended up running a completely separate kind of rival Twitter clone built on their protocol. But the idea was always that Blue Sky would be the first application on this protocol, and a load of other stuff could also run on it. The slogan was, the company is the future adversary. So you remember Google had like, don't be evil, which was sweet. The thinking here is that if you use Blue Sky now and you're relying on some Blue Sky infrastructure, sooner or later Blue Sky is going to screw you, right? So sooner or later we need you to be able to move off Blue Sky, and when you move off it, ideally not only can you preserve your social graph and all that stuff, but ideally you'd actually preserve the entire experience. So you shouldn't really even have to notice that you're no longer on Blue Sky infrastructure. So they released Blue Sky. A bunch of people showed up. Jack Dorsey had a really bad time on Blue Sky, and he threw a massive huff and flounced and left the board. So he's no longer in any way connected. It's just in this entirely separate organization that is standardizing at Proto and is supposed to be maybe handing that off to another standards organization. So how does it work? Well, the core thing at the center of it is what's called the PDS. So this is my Web 1 slide, and I've just rubbed out web server, and I've written in PDS. So how's a PDS different? Well, it's for structured data. So everything that goes in there follows some lexicon that you've defined that decides how the data all relates to each other. It's attached to an identity, which I'll get to in a second. Your records in it are also connected to other people's identities. So you've got your whole social graph is preserved inside these records. And it's content addressed and cryptographically signed. So this means that you don't necessarily have to get your data from the place that originally published it. So if I'm hosting my own PDS, I can do that on a really, really tiny little rubbish VPS. And that doesn't matter because if my content goes viral, people aren't going to be getting it from my PDS. They're going to be getting it from some cache or some other party, right? And because it's content addressed and cryptographically signed, they can verify that it's what it should be. OK, there's a little bit more infrastructure. So if you just had users with their clients, and they were connecting directly to the PDSs, that would actually work. But it wouldn't be that performant, and it wouldn't be that convenient. So there's a load of infrastructure in between. I'll kind of skim over it. There's a piece in my links at the end by Paul Frazee talking about turning the data center inside out, which I'd really recommend. But what you've got here is you've got the relay. The job of the relay is to connect to all these PDSs and catch all of the latest changes, and then just kind of splurge them out in what's called the fire hose. So you have this kind of constant stream of all of the new changes happening on the entire network, or a subset of the network. Then you've got your app views. These are kind of back-end servers that the clients are going to use. So these will depend on kind of exactly what the client wants and what the client is for. So when we started off, this was all stuff that Blue Sky Company was running. Now we've got quite a lot of independent infrastructure. Other people are standing up relays and app views. So all of the data in the PDS lives in a Merkle tree. It's a slightly exotic kind of Merkle tree called a Merkle search tree. Again, in the links, there'll be some stuff about why a Merkle search tree was chosen and what is interesting about it. But what we're going to do is, if we make a post, we're going to take its hash, make a CID. This is a content ID that looks just like IPFS IDs. That's going to go in some node in that tree, and that will allow us then to always make a proof that is somewhere in the tree, and it will update the root hash. And then we're going to sign that root hash, and that will allow us to verify the data. For identity, there are two standards in App Proto. There's one called DidWeb. This is an old W3C standard. Basically, you put an identity document on a web server. The other is DidPLC. The idea of PLC is we want to get as close as we can to content-addressed data, right? So ideally, you could get all the data in that identity document, and you could look at the ID and verify that the data was correct. And that absolutely works for the absolute first update, and it kind of works for subsequent updates with a few slightly cursed edge cases. So let's talk about making some stuff. So the first thing is, what can we do on Blue Sky? So all of the curation and the moderation and all of that stuff is unbundled in Blue Sky. So if you're using Twitter, you have, for example, the For You feed. And that is what Elon Musk and his algorithm decided you should have in your feed. In Blue Sky, there is also a built-in feed. It's called Discover, and it's really rubbish. But luckily, you can make your own. So this is my Blue Sky, like when I'm logged in. I've got a bunch of different feeds that I've added. I've taken out the Discover one because it's awful. I spend a lot of time on likes of likes. This is something that some guy in Japan made. It's just like things that people whose stuff I like at one remove, which turns out to be actually a really good algorithm. It's really simple. I've got quiet posters. This is people who I follow who don't post very much, and I want to see what they do post. And of course, you can also do like thematic stuff. So if you want to see stuff about goats, you can make a feed of goats. And this is really easy to build. So you make a program that's just going to ingest what's called the fire hose, this information from the relays of just all of the new stuff getting posted to the network. You decide what you like, and you output its ID for that user. And that's all you have to do, and then the user can really easily add it to their client and automatically subscribe to what you're posting. Similar story for block lists. So on Twitter, Elon Musk decides who shouldn't be seen. On Blue Sky, you can make your own decisions about who you don't want to see. So you can put people in lists. Anyone can make a list. You can make lists of people you want to follow because their stuff is good, or you want your friends to follow, and people you want to be blocked. So I'm on a list of GOAT posters because I post incredible GOAT content. I'm on a technology list for people who like technology. And I'm on a tech shit list for people who don't like technology and just hate Web3 and crypto and this entire thing, which is, I don't know, it may be wise. I'll carry on. OK, so let's talk about blockchain bots. So I make a thing called reality.eth. This is a question and answer system, basically an optimistic oracle. People put questions in it. They then have people post answers, and when they post answers, they put up bonds. And so there's an incentivized system to get the right answers. So the first thing we did with this is to make a bot to just post all of the questions that we see on the blockchain onto Blue Sky. Very simple. Once we've done that, it's really easy to put comments into our Dapp front end because we know the ID that we posted with. We did that in a deterministic way. So it only needs a tiny little bit of JavaScript to just pull those, all of the replies to that question in and show them in our Dapp inline. But we can also go the other way. We can take actions from AppProto and we can send them to the chain. So I wanted to do some stuff about misinformation for a long time with reality.eth. So this is just on testnet so far, but we've got like a bot that you can tag the bot, put in a question, and it will send the question to the blockchain and create it in reality.eth so that anybody can answer it. When we do this, we're creating a Gnosis safe on chain so that becomes kind of the user's avatar, like attached to their key on Blue Sky. We can also answer a question. So if I see a question I know the answer to, I can tag the answer bot, and I can put my answer and then put my bond. And that will create the on-chain transaction that will make that happen. Now, I've seen stuff like this on Twitter before. Other chains I've seen it done. But the thing about this is entirely trustless, right? Because the content is all on the user's PDS. It's arranged in a Merkle search tree, and the Merkle search tree root is signed. So we can take some content. We can recover the CID. We can find the CID in the tree, make a proof that it traces up to the root hash, and then we can check who signed that commit node. So a nice side effect of this is that since we're creating these automatic Gnosis safes, we kind of inadvertently create a crypto account for 36 million Blue Sky users, whether they like it or not. OK, well, let's talk about some new stuff, because everything I talked about so far has been about Blue Sky. But AppProto is a lot more than Blue Sky. So think about this. The basic thought behind everyone having this PDS is this. Everybody in the world gets a self-sovereign, cryptographically verifiable semantic data store. Everyone gets a self-sovereign, cryptographically verifiable semantic data store. This is the correct way to do the internet, right? This is what we should have done when we went to Web 2.0. So just looking at some stuff, and it's really easy to write to this store. So if you've got a decentralized app, you can do this. You don't necessarily need a server. You can do it with just a static front-end app. You can authenticate against the user's PDS via OAuth, and that will give you the right to write to their PDS and to save records on their behalf. There's also something in the OAuth flow where you can put in a host of PDSs. So right now, Blue Sky basically hosts most of the PDSs, but a few different people are now hosting them. So you can put in the PDS host, and then that will automatically onboard them onto AppProto, and then bring you back and allow you to write to their data store. So a couple of examples of this. One is Tangled. This is a decentralized GitHub replacement. Another one is Smoke Signal. This is an events management system. There's a really nice, in the links, there's a really nice thing by Liggy, who some of you probably know, who's written about why the existing hosted events management systems are not doing it for us. Another thing that dropped after I made these slides is that the Linux Foundation just did a thing called the Fair Package Manager, which is a package manager for WordPress. So WordPress recently had some sort of politics where the company that built WordPress has been kind of exploiting its control of the package manager used for plugins. So the Linux Foundation have built their own. So the way I see this, now we have two choices for kind of different purposes when we're building decentralized applications. Some applications will need like a consensus history, right? Some applications need a piece of data that everybody shares, and after you've written it, you can't necessarily delete it, okay? And because that's a commons, because it's got to have a consensus, that gives us a whole bunch of constraints, right? So we have gas costs we've got to deal with, we have potentially slow finality, we have just all this pain that we deal with as blockchain developers. But a lot of the stuff that Web 2.0 did was not like that. A lot of stuff in Web 2.0 is things where the user should have control over their own data. And the problem that we're trying to solve is we need to be able to easily aggregate all that data and show it in different ways to different people. So that's where I think AppProto fits in. When you've got user-controlled data, the user can do what they like with it. The user owns the data. You can put it on their PDS, and that will alleviate all this pain that we had to deal with if we have to do everything with a blockchain. And I don't want to do this sort of whole hype thing, but I feel like the use cases of consensus history are probably less numerous than the use cases of user-controlled history. So many things in Web 2.0 are user-controlled history and not consensus history. So I'm kind of really excited about having this new tool to do this stuff. So like I said, I put up a bunch of links. There's stuff by the people who actually built the protocol, Jay Graber, Paul Frazee. There's a starter pack if you're not on Blue Sky and you want to get started. There's some people to follow that I can suggest. And then a whole load of technical details, stuff to help you get started writing bots, all that stuff. Okay, so I feel like this has really kind of restored my optimism about the internet. I don't know if anyone else is pumped about this, but I'm really excited about this. I really hope people will give it a try. Okay?
Thank you so much. Let's open it up for questions. One question, 2 questions.
So I guess the easiest thing would be that you can take any of the existing open source clients. So really just depending how much of how different that is to the thing that you then fork, it will vary. Like, you could imagine you pretty much take an existing client, decide which records you want, and then it works. If you want to change a lot of stuff, obviously there's more work. But one of the great things about this ecosystem is that it really is a free software hackers ecosystem. And this is the difference to some of the other projects in the crypto space, is that everybody is committed to free software. So you can take the original Blue Sky client or one of a bunch of other clients and work with that quite easily, I think.
Thank you very much. For the personal data storage, data storing is also provisioning data to others, making it accessible as a general concept, and there's also then bandwidth, stuff like this. Do you have something like a payments layer for it, for a hoster then, or is this a concept that would be like the next step?
There's no payments layer. I don't know how people will feel about paying for PDS data. Right now, if you're doing just Blue Sky data, then you generally are not talking about vast amounts of data. I wouldn't be surprised if Blue Sky do some kind of premium thing with I don't know what features that will have. I hope other people will also do kind of paid services. As far as an actual layer goes, there are a couple of people now doing crypto integration. My friend Stella just did a really nice proposal where she's linking Ethereum addresses and putting in a whole load of kind of payment stuff. So we certainly could put in kind of crypto-based payments. I suspect it's more likely to look more like kind of traditional models of like somebody stuffs in some ads or people keep going, people sell other stuff. I don't think there's much demand for kind of micro payment type stuff. And one of the nice things about Blue Sky is that you don't really have to do that if you're just hosting a little bit of data. Again, this is the problem. If you're trying to do a data commons with a blockchain, then you have the problem of, okay, how do we prevent that being abused? So you need gas payments, you need storage rent, and all this stuff. But if it's just a little bit of data on a server, there's a lot of ways to get the little bit of money that you need to serve that.
Cool. Thank you so much. And let's welcome on stage the next speaker, Brenda from Teller.
Thank you. Well, hello, everybody. I'm Brenda. I'm one of the co-founders of Teller. And today I'm going to be talking to you about how to bring oracles to L2s and beyond. The two takeaways from my talk should be that to scale oracles, we need to implement layer security. And also, we need to find a balance between the fallbacks for those layer security aspect, your social layer, and credible neutrality. So over the last several years, we have been scaling through diversification, and we've seen a lot of ecosystems pop up. We see Avalanche, we see Cosmos, we see Solana, and even Bitcoin is jumping into the game. And so, as Teller, as we started seeing this trend, we wanted to make sure that we would be able to support all of this. And although we've done great strides, we still have a lot of work to do, but ultimately, we have been able to connect and do a lot of connect a lot of chains in general. We still need to work on interoperability, but I think it's more in optimizations than actually figuring them out. And to illustrate this point, I want to talk about this example that just happened a couple of weeks ago, where a trade was executed on Ethereum on a curve pool that caused a bunch of liquidations in Avalanche. And rapidly, people went off to say, it's the Oracle's fault, which I don't agree with, because if we look very closely to this example, we see that the liquidity, for the 24-hour liquidity was actually really low. Also, there's not a lot of sources for the information in general. And whenever you have a scenario where the cost to manipulate the asset or the cost of attack is so much lower than the actual gains, you're going to end up with something like this. So I went ahead and took away their original post blaming the Oracle, and I just said, when the cost to manipulate an asset is less than the gain, this is bound to happen. But here, we can see very clearly that the actual cross-chain communication happened very efficiently. It just led to unintended consequences. And that's where I'm going back to why we need to implement different layers of security to make sure that our oracles work properly. Because more often than not, we're facing these two choices, right? We want really fast data, but it can be more likely to be manipulated or in terms of assets. But if we wait for more robust data or more aggregations or more time, then we're risking settling with stale prices. So it's this trade-off that, as in the DeFi community, we know very well. And because of that, we need to continue to optimize, but also understand the implications of those optimizations and use that to also implement those layer of security. Teller, I'm going to tell you a little bit about my story or our story, because as the industry continues to evolve and all of these new ecosystems continue to emerge, you're going to run into very similar problems, especially if you started off as far along as we did. We initially started as smart contracts on Ethereum. It just made sense. Ethereum had the majority of DeFi, and it made sense for us to just deploy there and become an oracle there. And at the time, we actually had a system where all of our our data reporters had to be staked. And then because the way that we would come to the official value that was reported, it was the first 5 values that came in, got some minted rewards, and the median became the official value. And then anybody could dispute the validity of the data for 10% of the stake. And if they won the dispute, they would take the whole stake. Otherwise, the data provider would get some money for the fee for their troubles, for being wrongly accused. And so all of this was been done on-chain. And it worked, I think, just fine when we were only in one chain. The problem that we then were facing was, okay, we want to support all of these ecosystems that are emerging and all of these new chains. And it seemed like every week there was another chain that popped up. And for us to be able to go and support them, one of the things that we needed to have was an actual bridge for our token so that people can go and stake and dispute and tip the data reporter so they would know that they needed the information. So we had to make sure, the only way that we could expand is making sure that there was a token bridge that we could trust. And then once we did deploy into all of these different ecosystems, we were obviously faced with fragmented liquidity because everybody had to bridge their token, and we didn't have the same amount of security that we had in Ethereum. And one of the ways that we adjusted for that was basically, when you go to another chain, you assume their risk. You have to change maybe your parameters to be able to gain the same level of security as you do in other chains. For us, that meant changing some of our variables to adjust them to the speed of the chain. So for us, one of our security aspects is the whole staking thing. And so that's based that's a function of the speed of the chain, of how quickly a new value, a new price or pricing information or whatever other information can be replaced with good data. So if somebody provides bad data, how quickly it can be replaced. And so for us, that meant adjusting some of our variables. Even though we were deploying the same exact system that was fine for EVM, we had to change some of those parameters to be able to have or aim for the same security that we were getting on Ethereum. And that, could only take us so much could only get our security as close to Ethereum so much because even though we could adjust these variables, at the end of the day, if there isn't a broad enough network as it was on Ethereum, when people ramped up the demand, we wouldn't have the exact or all the network that we needed to be available. So with that in mind, we set out to build our own app chain. And one of the things that we really wanted to make sure that we had, one, we wanted to have an easier way to expand, so no more reliance on bridges, and also an easier way to deploy on different ecosystems with different languages. So instead of rewriting the whole system in a new language, we would just rewrite the like client bridge, and then we can bridge over data. And one of the main aspects that we wanted to have as well was a social layer. I don't advocate for forking all the time, obviously, or that's a last resort type of thing that you may hopefully never have to do. But we wanted to have that social layer as more of a credible threat to hackers that if we need to, we will use it. Granted, we hope we never have to, but we wanted it. And then we gained some efficiencies, and we went ahead and we created this whole other, we have our own chain and our own way of coming to consensus. But the takeaway from this is that no matter what oracle you use and what how they come to consensus, whether they're a peer-to-peer network or they have their own chain, you're not going to get away from the fact that you have all of this risk, off-chain risk. If you don't have a proper definition for the assets or the information that you're requesting, you're actually have a lot of trust boundaries that you have to address in different ways than just saying it's the Oracle's responsibility. When you have a market of something, of an asset that has really low liquidity, you're accepting that responsibility. So you have to come up with creative ways to come up with more robust definitions for that. You're also trusting that the APIs are not going to come down and that you're going to be able to collect the data efficiently and as fast as you need it for your protocol. But with creating our own system, we came, even though we gained some efficiencies, we have a social layer, we don't have to rely on the speed of Ethereum anymore to dictate how fast we can be or can't be. We do have to also take other risk. So now we have a different set of risk than before. Like if there is 66% malicious validators on any chain, not just on Teller or a peer-to-peer network, then that means that they can control the information or the things that happen within it or the state that happens within the chain. 33% can probably stop, 33% plus one can stop it or can stop the chain basically. And so those risks you assume in this ecosystem where it's so diverse, anytime that you're interacting with another chain, that's something that you have to deal with. And so aside from the risks that we already know that come with oracles and the external part, like the ones on chain and the ones off chain, now you have to deal with this extra risk. And so this is where the point comes of when you want to expand into all of these different ecosystems, you actually have to think about it security in layers. So the first layer of security for any Oracle to be implemented properly is going to be your data definition. And you can work with the Oracle to come up with something that makes sense for your market. Even if it's something that is low liquidity, you're just going to have more rails or more guardrails within your infrastructure, your architecture, to be able to handle that. And so that's the first layer of security that you have to address. Then the second, obviously, choosing your Oracle and making sure that you implement them correctly. We all work a little bit different, and there's a lot of flavors of us, from very decentralized to a lot more centralized. And it is up to what you are doing that makes it the correct decision. But once you do know what you're doing and what you choose, you have to implement them properly, right? And don't leave it to be the last thing after you do the audit. It should be part of your audit. And then after that, the next layer of security is making sure that you have fallbacks within your system. You want to make sure that you can either freeze the system, or you might want to do caps on withdrawals or limits, different ways of handling. What happens if you don't get any data from your Oracle? What happens if you get bad data from your Oracle? And what happens if you get stale data from your Oracle? And then obviously any chain that you deploy on, you're taking on the risks that come with that. From OEV, MEV, and chain congestion. That is something that you should be taking into consideration. We've all saw what happened with Black Thursday. And then within your own ecosystem, when something goes really bad, you also have to have some sort of governance or some sort of rules that determine what happens if everything goes wrong. How do you make it right for your community? So a couple of weeks ago, there was this hack. Cetus is an exchange on Sui, and they got hacked, or they could have been hacked for about 230 or 260 million, and they basically stopped the bleeding by all the validators from Sui decided to ignore the attacker's transactions. And I'm not condemning or saying, I'm not saying that this was right or wrong, but this is something that they were able to do. Hyperliquid is another example of of Hyperliquid taking over or making it right, or I don't know. There's a lot of controversy on what happened in Hyperliquid. There was also it was an asset manipulation type of hack. And then the Hyperliquid team basically overwrote the Oracle information, and they ended up making money off of it. And I think that's why it was very controversial. Also, the fact that they did it for this one hack and not for another one that involved North Korea was also very controversial. And these two examples actually, I want to illustrate my point of you do need layer security, but you also need to have a balance between the fallbacks that you implement, your social layer, and your credible neutrality. Because you don't want to undermine the very premise of why decentralized systems and networks exist and why they came about. The main premise is actually censorship resistance. So if you throw out credible neutrality and you're just going to control your system, there are better ways to do that, and better and more efficient ways. There's databases. We've been using those for many, many years. So that's where you have to strike a balance, and I know it's very difficult sometimes because I cannot condemn the previous teams from doing what they did because one, I wasn't in their place, and two, it has to be such a tremendous amount of pressure to either do things one way or the other that is just very difficult. But they both still have users, so if their community was fine with what they did, maybe credible neutrality for them means exactly that, keeping their community safe, and that's okay. I guess it could be a little bit different, but I think with Ethereum, right, if you deploy there and you get hacked, more than likely there's not going to be a fork, and that's fine. Like that's something that you're opting into, especially if you're doing a roll-up with them. But with that, I want to go back to my takeaways. Obviously, yes, we have the capability to communicate between chains. We have a lot of different ways of doing it. Some ways are continuing to be improved upon. CK proofs, I think once they get faster, it's gonna be, they're gonna be part of that as well, and they already are in some cases. But we're waiting for them to be a little bit faster, and because we already have that, I think we need to focus a lot on how to also handle unintended consequences of these interoperability and composability that we're going to be gaining as we see base rollups and native rollups and ZK proofs becoming better and faster and actually being implemented for some of these. And then between the fallbacks, the social layer, and the credible neutrality, I'm a firm believer that crypto is not just a technology, it is a movement, and we need to be able to hold or to stand for that ethos, because ultimately I know that a lot of people don't care when things are going well, but when things don't go well, this is technology that it's absolutely necessary. And you don't want to say, if you can do this and you can be choosing winners and losers, then there's no reason why a state actor can come and ask you to do something for them. And I think that it's imperative that we give that the importance that it needs to be given. And with that, I'll take any questions if you guys have any.
Thank you so much. Yes, let's go for questions. No questions? I don't see hands. No. Oh, there's one here.
So what was the biggest challenge from you guys deploying contracts on different chains to having your own chain and people staking on your chain but still connected to all the others? Is there any challenge you guys are facing in this new model versus the older model?
I'm thinking it's a very big optimization for us. I guess the biggest challenge is actually the risk that every other chain is facing, especially when you're a smaller chain. it's the risk, the cost of attack is lower, right? So that 33%, it's lower than a 33% of like Ethereum network. So that is definitely going to be a challenge, and that's why I think it's also important that we have all of those layers of security. But most importantly, that we admit it, because I think that a lot of the industry has just gone through, we've gone through a lot of DeFi, and we continue to go through DeFi hacks that involve generally a flash loan, and then some asset manipulation and liquidations, and then they run away with the money. And we don't have all of these things in place for people to be able to have better guardrails for their own users. So yeah, in terms of us, I think it just made it so much easier. I don't think that's the biggest thing, is the security within that 33% and 66%. And that's something that we're all facing. And I think as you see more app chains pop up, we're all going to be facing these different scenarios and assumptions in security. Maybe base rollups and all of that fixes everything, but until they're here, we're going to have to work with what we have. Yeah.
Right. Thank you so much, Brenda. Next up, we have Bianca from Chronicle. Please give her a welcome.
Thank you so much. Hi, everyone. Thank you for staying for the second part of the day. I hope you are enjoying DappCon and Berlin Blockchain Week so far. With this presentation, we are continuing the conversation that Brenda started on oracles. We'll be talking about the Oracle Renaissance, decentralized data for a trustless future. So what exactly do I mean by that? In this presentation, I would love to cover how we are basically going to the next iteration of oracles, from simple data feeds to real-world interoperability layers. Before that, I have a personal story I would love to share with you today. 2 weeks ago, I found this in my building. Apparently, a water pipe broke, and because of that, the whole building had no water. I tried to have a shower, but, well, you need water for that. Brush teeth, also not gonna happen. Make coffee, you need water too. This got me thinking. Suddenly, all the things that I took for granted were unavailable. Data in decentralized application is a lot like water. It flows quietly in the background, and most of the time, we take it for granted. But you really notice when it's gone. My name is Bianca Buzea. I'm head of DevRel at Chronicle. The team at Chronicle is the team behind the first Oracle on Ethereum back in 2017 at MakerDAO. In 2023, it spun out of MakerDAO. It continues today to power Maker, as well as other protocols in the Web3 space. So back to our Oracle Renaissance. So we're moving away from simple data aggregators. What we're building now in terms of oracles is infrastructure for real-world interoperability. So basically, we are connecting real-world with on-chain. And oracles nowadays help us answer questions which are a bit more complex, such as, is a tokenized asset actually backed? Is it appropriate for a financial contract to execute? Can users trust what they're interacting with? In terms of data feeds, or the main categories of data, we have 3 main categories. It's true that technically you can put any sort of data and get that delivered by an oracle, but I would argue that these are the top 3 most popular use cases for oracles and data. So number 1, we have crypto price data. Here we're talking about real-time pricing for cryptocurrencies. Then we also have non-crypto price data, such as prices for fiat, stocks, or commodities. And finally, what I believe is the most interesting use case nowadays is a testable data. And I'm saying that because we're seeing a rise in terms of real-world asset tokenization. When it comes to attestable data, here we're talking about any verifiable piece of information. Some very popular examples are proof of funds and proof of ownership. And now to kind of back my statement earlier about the growth of real-world assets tokenization, this is a screenshot I took in December last year. And the total RWA value was at 13.9 billion. I recommend this data is from rwa.xyz. It's a very good website if you're looking for insights about the real-world asset market. You can see it broke down by chains, by where the data is coming from, and some other insights. I did, a few days ago, the same exercise. I went to check this source again, and guess what? The value now is at 23.14 billion. If you do the math, that's a 66.5 increase in a bit less than 6 months. That's a lot, I would say. However, we're just scratching the surface. If you look at the total market for gold, currencies, real estate, and commodities, that's over $40 trillion. What does it mean? This means that there is a great opportunity when it comes to tokenization, but also this comes with great responsibility. So why tokenize, you would ask? What are the benefits? Shared system of record. Using tokenization, you can get an unambiguous view of asset ownership. At any given point in time, you know where the asset resides and who owns it. And also, it reduces information asymmetry. Then we have customizable asset custody. With tokenization, we can have various custody models ranging from self-custody all the way to institutional custody. Programmability is another benefit, and here we can achieve great operational efficiency via automation using smart contracts. Asset fractionalization is another one. We can now have micro units of ownership. This basically reduces the barrier to entry. So if you think about a tokenized real estate, for example, you can have units of a share of that. And this enables to have what we used to have as traditional illiquid markets become more dynamic and bring additional liquidity. Lastly, composability. Now we can package and repackage different pieces of collateral, making a more efficient use of it and increasing liquidity. However, as you can imagine, there are not only benefits. We have some challenges as well. In fact, I recommend this report by the World Economic Forum. It gives a great overview on the benefits, challenges, and how all this is evolving currently. And here I noted some of the current challenges when it comes to tokenization. The first one is legacy infrastructure integration. Another important one is the fact that we have inconsistent global standards. And probably, in my opinion, the trickiest one is that we need to ensure that we have compliance across different jurisdictions. However, while these challenges are definitely significant and we need to tackle those, I think as Web3 builders and people who are interested about the ethos of Web3 and decentralization, there is even a greater challenge we need to address. And that's about transparency. So the problem with tokenized assets is that unlike crypto-native assets, they're not inherently transparent. And also, they lack liquidity verifiability. So why is that happening? Well, the underlying assets resides in traditional financial systems. And as we know, those are off-chain, opaque, and siloed. So basically now blockchains have the problem that they can't verify that these assets are fully backed, and neither the protocols that are built on top of those blockchains around them. Therefore, users are forced to rely on the promises and the reputation of the protocols, the apps, and exchanges they use. So we're kind of back to square one. So what's needed? How do we solve this? Real-world assets will only reach their potential if the data behind them is verifiable. As builders and users in the Web3 space, we need to demand transparency by design and verifiability. It's also very important that we're not reintroducing the same systemic risk that currently we have in traditional finance. However, there are some good news. We have oracles, and as we know, oracles enable trust and transparency. They enable to verify off-chain creditworthiness, and they provide key data, such as purchase dates, yields, and maturity dates. Also, another very important property is that they allow the syncing of the lifecycle to the on-chain. So basically, you can clearly track how an asset goes through the different stages, such as issuance, transfer, and settlement. That's why at Chronicle, we're building the Verified Asset Oracle. This is our oracle for the real-world assets. And the way it works is that it connects directly to the custodian, so there is no middleman. And it provides real-time, independent, tamper-proof attestation of the data with what it puts on-chain. This means that basically we empower DeFi protocols to handle tokenized assets in a risk-appropriate way. And I'm sure now you're going to ask me, OK, what's a risk-appropriate way? What I mean by that, imagine, for example, a DeFi protocol that wants to check the underlying assets it's actually there. And if the asset is not there, or if the volume of the asset is less than what it expects, then they can take certain measures. It can do a circuit breaker, or it can do a liquidation or some other measure. What is important here is that builders have verifiable data that they can trust and make decisions based on that data. That's it on my end. I hope you found something interesting today. I would like to invite you to check the documentation portal if you want to learn more about the Verified Asset Oracle. Also, in about 2 weeks, we're launching the dashboard for the Verified Asset Oracle. It's going to be a good visualization of all the data the Verified Asset Oracle puts on-chain. So definitely something to check out when the time comes. Thank you so much. I hope you enjoy DappCon and Berlin Blockchain Week.
Thank you. Let's open it up for questions. One there.
Thank you. I have a question about custodians. What are those and what happens if they go bust, basically?
That's a good question. So the custodian is the one basically that has the assets. So the idea is that you don't have the middleman, so you connect directly where the assets are, such that you can have like an independent third-party assessment that, OK, the assets are actually there. When it comes to what happens if they're not there, like you verify, you have this sync. So you verify all the time that the assets are there, but yeah, this is like the promise basically. You have like this continuous syncing of the off-chain and on-chain, and you say like, okay, at this point in time, the asset is here, and so on.
More questions? No, we good? Okay. Thank you so much.
Thank you.
And we'll do a break of about 5-6 minutes, and we'll be back for the next speaker. Thank you. presentation, I invite on stage Julie from Chain Security. You're welcome.
Thank you. So nice. So I'm Julie. I use she pronouns. And to quickly introduce myself, I am currently a smart contract auditor with Chain Security. This is going to be a little bit relevant. And also, if I don't say it, the tax authority is going to yell at me in Swiss German. So we don't want that. I'm also a developer at Randamoo. and is a bit relevant, and a maintainer, one of the maintainers of Ethereum.nix, which is also a little bit relevant. So to get into this presentation, what does this title mean? Well, I decided to do a little experiment in my free time around how we build and distribute software. And the questions this presentation will answer are, what do we mean with software supply chain? How do we currently protect our supply chain? What I think we could do differently, and what I learned doing this experiment. Is this a Nix talk masquerading as a blockchain talk? Yes. Are the exits locked? Also yes. Now, let me ask you, how do you obtain your software today in the world? Maybe it comes pre-installed with your hardware. Maybe you go to an app store or a open source software distribution. Maybe you get it on CD-ROMs. It's a bit old. Maybe you get it through IPFS and torrents. Maybe you get it from books, you get it from T-shirts or QR codes. There are many ways to get software onto the end user's device, and all of these means are what constitutes the software supply chain. Now, what can go wrong in the software supply chain? Well, if it's unavailable, you will eventually not have the software you need. If there are bugs, you could get buggy software, and worst of all, if the supply chain is compromised by a malicious actor, you might receive compromised software from it. So it's important, it's a part of our infrastructure, and we should make sure that it is robust. Now, I divide the supply chain in two big pieces. One is the source code, and the other is the compiler pipeline. So the source code is the way we write software. It's mostly humans responsible for this, and they write software that should follow the requirements of the user. And to secure this, you need to decide who you trust. You need to audit the software or read it yourself. It really depends on your threat model. The other part is the compiler pipeline. It's almost entirely automatic. It's all the processes you use to take the source code and transform it into something that can run. So I'm going to refer to this mostly as a compiler, even though there are also interpreted methods to run software. Now, how do we make sure that the compiler pipeline has been run correctly on the software that we are about to use? There are currently in the world two methods, I think, to achieve this. One is re-execution, and the other is attestation. Now, the first one, re-execution, is very similar to how most blockchains work today. Basically, it is you re-execute every computation yourself, or you recompile everything from source yourself to make sure that everything was done correctly. Now, it's great because you don't trust anyone, you just verify yourself, but how many of us actually compile our software from source? It's not very practical, and it's also not very scalable for the purposes of a blockchain, and I will come back to that later. The other method is attestation. It's what a lot of software does. You have a big build server somewhere that will run the computation to compile the software, and then it will cryptographically sign the software in some way, and then it will distribute the software with the signature. This is very simple and very efficient to verify, but you get this big central point of failure that you need to protect very well so it doesn't get compromised. Now, concretely, compromises do happen, and I will show you 3 case studies, one of which is the SolarWinds hack, which happened in 2019. It happens that state-sponsored hackers were able to hack SolarWinds, and through that, because a lot of people used their software product, they were able to distribute malware and even managed to compromise the US government. The second case study is the XZUtil attack on the open source, in the open source world. So at some point, a malicious maintainer was trusted with operating this critical library that was used in particular by the SSH daemon on Linux, which is how you can connect remotely to your machine to administer it. So it has the ability to become administrator of the machine. And they managed to put malicious code into package releases, which are almost source code, but not really. It's a bit of a strange thing in the Linux pipeline. And many Linux distributions were affected. And we don't know that anyone actually got hacked from this. I think they were discovered just too early to be able to exploit the malware. But this happened and caused a lot of noise and concern in the affected parties for very good reasons. And the third case study, which we might be more familiar with here, is the Bybit attack in 2025. The web front end for Safe Wallet was compromised, and this was enough to trick Bybit's signers, which were responsible for their assets, into signing a malicious transaction that compromised their wallet. And just like that, $1.5 billion were gone. And in the pockets, I think it's North Korea. Yeah, it's North Korea that did it. And so this was a supply chain attack, right? The front end was, a malicious version of the front end was distributed through the Safe Wallet website. Now, there's also a theoretical paper that I like by Ken Thompson. It is a special version of the C compiler that has the ability to, when it itself compiles a C compiler, inject the backdoor into the new C compiler. And so through the generations of compilers, it can propagate malware. And this was never actually exploited, but it highlights how the trust assumptions are transitive throughout the supply chain, and you have to trust the compiler of the compiler, a bit like living beings are not purely the results of their DNA, but they also need to be gestated in order to exist. Now, let's look a bit at threat model. I'm not here saying that if you are vibe coding web games, you should be worrying about Ken Thompson or doing complex stuff. This is fine. This is a very contained piece of software that is not going to do a lot of damage, and you also don't need an audit from that. But a lot of infrastructure, especially blockchain infrastructure, has already been targeted in supply chain attack. So I think there's value in trying to understand how our supply chain works and how to make it more secure, maybe. Now, to introduce the part of my title, which was a verifiable computation applied to the software supply chain. Verifiable computation are all of these methods that we have to outsource a piece of computation to an untrusted party and be able to verify that the untrusted party actually computed the thing correctly without re-executing ourselves. For example, you have ZK proofs, you have certain crypto economic schemes that I will go back to later. And I noticed that a lot of people work on this, but they never talk to the people who are on the software supply chain. So there's kind of a siloing of research, and I think there's value in trying to connect those two areas to try to bring value from one side to the other. And that should bring us to my experiment. So in one phrase, I put a compiler inside of a ZK VM and made it work that way. So a ZK VM, if you may notice, it is a system that can run computation and produce zero-knowledge proof that they were executed correctly. So it is a form of verifiable computation with no trust assumption and just cryptographic assumptions. Now, what I would like to see one day is that people can verify those cryptographic proofs instantly and look at the source code without having to compile everything themselves. And this means that you can still have a build server, but it can be untrusted, which is an upgrade from the current situation. I use the RISC-0 ZKVM. It's a RISC-V ZKVM that I found off the shelf. I didn't choose it for any specific reason, but it worked for me, so that was good. And the compiler I started with is called Hex0. It's a project that is trying to make the smallest compiler possible, and it can just read hexadecimal with comments and output a program. The goal is to be able to bootstrap from this very small compiler all the way to much bigger compilers by compiling less minimalistic compilers as you go along. And there already existed a RISC-V Linux version, so this made my work easier. I could just port it and port those components to RISC-V inside of the R0 VM. So I made a little demo that, so there's no live demo, but I can explain it, which is almost better. So I had a tool that can verify bundles that contain source code, executable, and a proof that the executable came from the source code. And I made a hello world for Linux x86-64. So if you want to go see the demo, you can build the proof yourself. You can verify the proof that I give you. And if you're satisfied with the proof, you can also run the hello world. Now, the caveats of this approach is that currently it takes 10 to 20 seconds to generate a bundle with the proof, which is not great, of course, especially for such a simple program and compiler. And ZKVM teams are making new versions a lot. So I did this on ZKV on RISC-0 version 1, and they already announced version 3. And it's also not compatible with any other ZKVM that I'm aware of. So we have this standardization problem, which makes this approach a bit complicated at the current stage. Now, there are also alternative approaches that we could look into, because this idea of I'm just going to use zero-knowledge proof is a way to make something that is maximally paranoid, but we can find more pragmatic and incremental approaches to still improve security compared to the status quo. For example, we could compile inside of a trusted execution environment, like Intel SGX or something like that. There's still going to be a central build server, but it's going to be harder to compromise it because you have to compromise the TE. So strictly speaking, this is an improvement. And this also has very little performance impact, most likely, and probably less complexity also than doing this inside of a ZKVM. Something a bit more further along in the spectrum are those crypto-economic models, where you can assume that the majority of the build servers, you have multiple build servers or multiple blockchain validators, and you assume that the majority of them are honest. And so you can accept builds that were signed by the majority. You can also use these systems like ELVs, which is used in Polkadot, that can select a subset of validators and then check their work with another subset of validators and achieve some more scaling with that technique. And you can select your build servers either based on token stake, which is what we usually do with a blockchain, but you can also imagine a system where a bunch of individual human developers come together and say, okay, we are all going to each run a build server, and we're going to make a supply chain that way. This was an idea that was suggested to me by Jeff Burgos, by the way. Very, very interesting idea. Now, another last thing I want to point out is that we don't have to use one of those approaches. We can have models where you combine multiple approaches. This example is the proposed finality gadget for the Ethereum R1 rollup. And what it does is it combines ZK, TEs, and optimistic challenges in such a way that two of those systems have to fail in a very specific way for the rollup to accept an invalid state transition. So you could imagine doing something similar for a supply chain with, for example, a combination of TE and majority honest model. Now, let's do a little bit of science fiction. If you like trains, you might have seen one of these track laying machines that is able to lay down its own tracks and then roll all the way onto them. I think this is fascinating. And this is also something we could do in the blockchain space, maybe one day, where the blockchain itself, after it has scaled its ability to do verifiable computation a lot, can start compiling its own infrastructure, its nodes or its front ends, and hosting them that way and progressing forward while proving that its software is correct. Of course, this is a long shot, but there's a way you can start from hex 0 and compile yourself all the way to some of the Ethereum client software already. So maybe this is something we can do at some point. Now, I how do I conclude a talk like this with a lot of experiments? What I came up with is, you can just do things. You can just go grab an off-the-shelf ZKVM and do things like that without asking for anyone's permission. And I think it's fun. I think open source and the Infinite Garden are a nice place to do this. And with that said, I will leave you with the link to a page that has the demo that I said, and also a Telegram group where maybe if you're interested in this topic or if you want to give me feedback, you can come and we can keep discussing those topics after DappCon is over and we've gone home. And that's it for me. I am open to any questions you might have.
Thank you so much, Julie. Open, I see questions. Yeah, let's go for questions.
Yeah, I didn't get the example, the idea of the train laying tracks, and it seems very interesting, but can you explain maybe again?
Yes, so the idea is you agree that you can compute stuff on chain, right? So what if the computation you do on chain is taking the source code, which anyone can more easily than the binary read and verify, and then you run the compiler itself on chain, and you get an output. Now you have, this output is a client for the blockchain, so you can download it and replace your client with an upgraded version that, that can continue verifying the blockchain as you go. And so you put the track, and then you roll on top of the track.
Okay, yeah, a bit, it's interesting.
Right, more questions? Yeah, other one.
Do you think that this could be an interesting use case for verifying smart contracts?
I think smart contracts, I think it's even more doable because smart contracts are much smaller in terms of software than a lot of clients. And that's something I'm open to looking into in the future.
Okay, do we have more questions? No? Okay, all right, thank you so much. Maybe we'll do just a 2 minutes quick break. Don't run away, we'll be right back. Let's give him a welcome.
Hey, DappCon. Today I'll be talking about a new class of dApps that I've been looking into as part of the Ethereum Foundation's App Layer Fellowship, where we try to anticipate and unblock use cases that can drive new waves of adoption. So I think as we all know, crypto's adoption story kind of starts in the dark web, where Bitcoin was used through the Tor network to help people purchase usually illicit substances. But eventually, people kind of realized you'd be better off holding your Bitcoin rather than spending it. And then it just turns into a speculation asset, right, where people want to hold it. And I think that Ethereum has experienced a similar arc, where it started off with a vision of a world computer to enable e-commerce and the Internet of Things. But then very quickly, people realized that the highest ROI way to use the chain was to launch and trade tokens and create an ecosystem of tools around that. But it's starting to feel like 15 years later, we've kind of come back around to the origin of crypto as commerce. Maybe not as we expected it, but we have major fintechs and governments paving the way for stablecoin adoption, with PayPal, Stripe, Shopify, and many more companies on the way to offer stablecoins to the masses. And pretty soon, probably the key onboarding path for new users will be through stablecoins, buying or selling regular goods and services. But stablecoins are really just the first step. And it's definitely not the end state that was originally envisioned for Ethereum, enabling a whole world of commerce, Internet of Things, and basically disintermediated trade, disintermediated exchange of goods, services, assets for individuals, communities, businesses through smart contracts. And so we need to get into the harder stuff that a lot of people here have been working on. And the kind of adoption path that I'm arguing for here is to work on the increasingly difficult primitives beyond just payments that are going to unlock this future vision that I think a lot of us share. For example, identity, peer-to-peer reviews and ratings for reputation, dispute resolution for when things go wrong and you need refunds, reimbursements, insurance, which today is a common component kind of baked into peer-to-peer marketplaces, and embedded credit lines. And then once we do all of that, we can unlock the kind of holy grail of these more crypto-native, fully on-chain and smart contract mediated transactions that are not purely financial and self-referential. And so yeah, this is basically the process where we need to perfect and then embed these primitives into the mainstream system, the same way we've seen stablecoins succeed. And then more and more of those legacy systems go on-chain, and eventually they themselves are part of the smart contract economy. And it then opens the door to the more ambitious visions that smart contracts enable once more of the legacy system is on-chain. And this is just a small snapshot of what people have tried over the last 10 or so years in terms of decentralized commerce. But of course, these were all far ahead of their time because we didn't have these underlying primitives in the way. So Socket, has this sharing economy vision, universal IoT devices that are self-owned and enable access rights through smart contracts. District OX and Swarm City, which envisioned like a sharing economy and an interoperable backbone for marketplaces that would all tap into the same reputation system and inventories. OpenBazaar with a similar vision that more so leveraged Bitcoin and IPFS. And D-Travel is an example of the idea of decentralizing Airbnb. Trip protocol and many other attempts at decentralized ride-sharing ecosystems. But basically, all of these projects didn't really get anywhere. And here's why. So one, the most common thing I heard when talking to marketplace founders, people who attempted this, it was just the basics that we all know that have plagued Ethereum and blockchains over the years of complex onboarding, high gas fees, and then the fact of everything being transparent, just limiting the extent of real-world commerce that can happen there. The primitives that we spoke about, basically every one of these projects was needing to build the full stack of commerce in-house because they couldn't rely on existing systems of arbitration or reputation. And so they really missed a big opportunity to get shared network effects from different kinds of marketplaces, tapping into the same underlying inventories, liquidity, and so on. Also, there was clear strategic missteps from the way people thought about on-chain businesses early on. often focusing entirely on pure decentralization, having everything on-chain or everything in decentralized tech, which was not ready, right? So that it really degraded the user experience and didn't actually provide a superior alternative to the legacy marketplaces. And then tokens being another kind of part of this, people at first, every marketplace basically was using tokens as a means of payment. So instead of using stable coins, they were using their own token, and tokens as a means of governance, which has led to many messy situations. And even if all of the kind of technical problems are resolved, I think the hardest part for any marketplace, on-chain or off-chain, is obviously network effects. And so there needs to be creative solutions that actually help these new kinds of platforms compete with incumbents and create new marketplaces that the incumbents in Web 2 just can't serve. So where are we today? Well, one, Ethereum has scaled. The UX is far better with account abstraction, and soon all the L2s are going to feel like one unified Ethereum with cross-chain messaging and a variety of other initiatives to make chain interop more easy. This is just a small snapshot, of the experiences that we've all had and how dApps can actually work for us today. And then privacy. I think privacy is something that we often overlook because we feel like regular consumers don't care about privacy. But when it comes to everyday commerce, privacy is more of a practical security issue. People aren't going to use the on-chain Airbnb where everyone knows where they're staying, who they're paying, how much they're paying at all times, where they're riding to, what they're buying, what they're selling, right? So obviously privacy is having no privacy is a non-starter for actual marketplaces for real-world goods and services. And then I think one interesting approach here is fluid keys stealth addresses, where you don't necessarily need to have the whole transaction be private, but you have obfuscation and who the funds are going to. So you can have an address generated on the fly for every new transaction without them being linked to one another. And then we have different approaches at selective disclosure, where you can actually validate identity with several solutions, having a lot of traction there, and credentials, information about someone that you only prove a selective attribute of, rather than the underlying credential itself and who issued it and other details. And ZK-TLS has been one of the biggest explosive changes of the last year, where a lot of these solutions are actually usable to import credentials from Web 2. So instead of needing to create our own crypto-native ecosystems of attestations to build trust, you can just import them from the Web 2 world. So you can take your Upwork history or your Airbnb history or whatever credentials you're a superhost and just import them, and smart contracts can validate that you have those in order to unlock kind of rewards or just access to more users who want to consume your services. One interesting experiment recently was Cursive's private set intersection, which uses MPC to blind match people who have the same needs and wants. Next, open social protocols, I think, unlock a whole new wave of potential marketplaces that can tap into these. And so I think for the most part, people have thought of open social as social networks and entertainment. But I think the potential is way bigger, because once you have a social graph like that, you can then bootstrap actually marketplaces on top of it. So you can use the social graph as a reputation layer through algorithms like eigentrust or PageRank or just social proximity to understand the trustworthiness of an actor and the chances that they'll deliver on the service the quality of good that you want from them. And the social protocols also serve as a discovery service. So with Farcaster, for example, you have hubs, and so you can broadcast your offers or your requests as casts, as posts. And then the mini app kind of angle is another interesting, even more recent development that we've seen from Farcaster, World, where people can build an app and it can inherit all of the kind of integrated wallet notification system, and while also tapping into that social graph. And in World ID's case, you have authentication as well. Here are just some simple examples. Slice, doing e-commerce through a Farcaster mini app. And then Icebreaker, which lets you post for a job or look for a job, again, through the Farcaster social graph. They actually also use ZK-TLS to import your LinkedIn connections, creating a better network effect, bootstrapping externally. And these are just some examples of simple Farcaster-based apps that are market-focused. So we have a kind of Farcaster marketplace, which is basically looks like a Facebook marketplace. You just post in a channel what you're selling, and then the UI automatically turns that into like a familiar format of an e-commerce store. And then Bountycaster takes a slightly different approach. Instead of a Farcaster channel, you can just make the post, but you tag the bounty bot, and then it indexes you in their UI, which is a bounty marketplace. Then AI agents. So I think AI agents solve a more fundamental problem in marketplaces that actually gives us a higher chance to decentralize them. Because smart contracts are obviously deterministic, and therefore we can only verify objective information that's inside of the ecosystem itself. But with AI, we can kind of get subjective data analysis embedded into transactions. And so one example of this is just listings. So today we rely on the platform marketplaces, obviously to their databases are hosting all of the different offers. But then also they do the recommendations and the filtering and the matchmaking to help us find what we're looking for, because we don't want to look through millions of listings. But with AI agents, we basically supercharge the ability of people to do search client-side. Also, the process of pricing and closing a deal is also very subjective, right? I'm sure people have all used these marketplaces where there's a price, and you go back and forth to get the price to something that both parties agree on. And AI agents, this is just one example from Virtuals, can do this back and forth through basic human text messaging, through text, and then they can resolve it on-chain through smart contracts. And then on the actual payment part, we have a lot of new standards lately that are tailored towards AI agents so that they can use simple HTTP requests to make a payment. Coinbase has X402, and then we have Skyfire and Payman. And what these let you do is define these kind of conditions, limitations on who you can buy from, who you can send money to, how much you can send. And then beyond these primitives, we have some new experiments that I think kind of show the way of what's coming when it comes to on-chain commerce. So Slice, like I mentioned earlier, is basically trying to bring commerce on-chain. So it's an on-chain Shopify where your goods are on-chain, the representation of them, the inventory, the pricing strategy. You can implement custom smart contracts to price your hats that you're selling on a bonding curve or whatever you want, as well as referrals and all the other things that we can do with tokens. Keep, you can think of it like a Web3 Stripe Connect. And really what it does is behind the scenes uses account abstraction and stablecoins to handle payment orchestration in a marketplace without requiring anyone to have a license like you would in Stripe, because it's non-custodial. Then local is more focused on local services, so building a transaction graph and then deriving a reputation system from that they can then price insurance for transactions through an AMM so that the actual services that are rendered there, like food delivery, can happen reliably. And they actually already have a pilot live in northern Colorado with a food delivery app called Nosh. And then this is super recent. This is just last week. Coinbase and Shopify announced the Commerce Payments Protocol, which also uses Stripe, to really not just do stablecoin payments, but bring the authorization flow of payments that is typical in Web 2 commerce environment on-chain. And so they actually developed new smart contracts that handle this kind of authorization flow of you pay in escrow, and then the merchant's API or the merchant itself, approves the inventory is available, let's say, and then the payment goes through to the receiver, and then it reverts if that isn't done in a sufficient time frame. And this is super programmable. You can add all these different kind of hooks to make it work however a particular merchant needs. And so what I found is kind of some high potential, low-hanging fruit is to really make DCOM take off. One is to have a standard or some sort of way of abstracting over the different identity and reputation solutions out there. So we have loads of credentials, anonymous credentials, that people can assign to particular addresses and accounts, but really these don't talk well with one another. And if you're building a marketplace today, it's really not clear which one to go with, since none have a sufficient network effect. I also think there is a really big opportunity for the listings to be shared, the inventory. And this is what could really create a 10x better experience than traditional commercial marketplaces, where the inventory of Upwork or Fiverr is separate, and even like different kinds of services could interoperate their inventory if there's standards around what is a listing. And this can basically create like a way better liquidity between marketplaces and programmatic, like combinatorial auctions where you buy things from multiple places at once. And when it comes to reputation, I also haven't really seen reviews, which is a really critical primitive in all Web2 marketplaces. You know, you leave a rating score, you write a text review sometimes, and this really creates that web of trust that's relied upon. And I think you could simply do this, you know, on top of something like the Ethereum attestation standard. And risk management is definitely the most complex area, and that's why Web2 commerce has exploded, is because you know that you can rely on the platform in many cases to help you if you have some sort of problem. If you need your money back, they can have insurance baked into everything. And if you have an issue, you can talk to customer support, and they can help you resolve your issue. And like I said, with AI agents, I think there's a big opportunity to do this. But there's also simpler ways, like even just having a centralized company that's just like, hey, we do arbitration for all these different marketplaces, and they're just the third party that like checks if something goes wrong and, you know, hits the switch of whether to reverse the payment or not. And so a big question I get is what kind of marketplaces are going to take off first? So given that a lot of the pieces are falling into place, where should we focus? Because it feels like Web 2 has already dominated and monopolized everything, and we should just, you know, still just focus on finance and let Web 2 handle commerce. But I would disagree. I think that there's plenty of markets that are not served by the incumbents because they're either too fragmented, or they're in a regulatory gray area, or they just haven't been made legible because the transaction costs aren't worth getting them represented in these marketplaces that rely on fintechs that charge decent-sized percentages. Also, I think that there's a nearer-term potential to focus on markets that are higher margin with differentiated inventory. So basically, this is because when you have low margin and commoditized markets, like let's say Uber, where it's really just driver time is the key metric, like how long is it going to take to get you a driver and what's the cost. These are really better served by vertical integration, where you have some company that has a ton of data and they can really optimize the algorithm around like squeezing that extra margin. And eventually maybe protocols will be able to compete there, but I think there's a way greener space to start in. Just some examples, I think many more exist, but areas that you can't just off the top of your head think of, oh, I use this all the time for that and always have a great experience. Maybe these are a little more illegible by the current system. And so I hope I've made a compelling case for DCOM, for having interconnected marketplaces that are built on open building blocks and open standards. And if you want to read more about this, feel free to scan the QR code, and thank you.
Thank you so much. Let's open for questions. Raise your hands for questions. No raised hands. Okay, I guess we're... you.
Hi. So I was looking at the features that you mentioned about for identity, what we can use, and do you think circles can also be used? I saw the mention of world, so I wanted to ask.
Definitely, definitely. So I think Web of Trust is a powerful tool, as we saw kind of in Farcaster implicitly, but in Circles it's very explicit in the data model. And as we see network effect interaction there, not only I think you could use Circles for identity, but also for payments, because it's basically a decentralized credit issuance system. And so based on how much you trust someone, you can accept their Circles token. Yeah.
There's one question there.
Thanks for your talk. It's very interesting to finally build like the parallel economic world we wanted, like in the meme, like with Morpheus saying, you don't need any money, where are we going?
Right.
But I'm looking at it from the supplier side. Like, if I am a supplier, at some point, I need to buy in more stock, then I'm going to need, probably need, traditional fiat money, right? So I need to ramp off, or... And I have a feeling like if governments are feeling threatened, they might ring-fence this. So what can we do about this? I have a feeling that they are going to cut off the supply.
Yeah, so I think in peer-to-peer marketplaces, it's not as clear because you have, supply is one side of the market and the demand is also there. So the suppliers can just be, regular individuals, not necessarily big companies. And maybe what they're providing is, a service that has low capex, right? That's just your time. But when it comes to, anyone that would have costs, sure. Yeah, I don't think it's a problem if they're offboarding, if, Bitcoin miners are selling their Bitcoin for fiat all the time to pay for electricity, and, Bitcoin still works. And that's really what I was trying to make the case for with the progressive substitution, is that even if we're only substituting a small part of the stack at a time, the aggregate effect, I think, could get us to that future. Thanks.
Do we have more questions? No, I think we're all good. Thank you so much.
Thank you.
Let's just do a 2-minute quick break, and we'll be back for the final ceremony. Everyone, hope you had a great time at DappCon. If you've enjoyed, let's go for the closing ceremony. And to do that, let's welcome on stage Stefan from Gnosis.
Thank you. Thank you.
Go.
Yeah, thank you all for coming. Thank you for supporting us. This is DappCon 2025. And yeah, I would also like to, of course, thank our sponsors who made this possible. And especially also thanking Aman for organizing this and all the team on the ground. So let's give him a round of applause. So we have been doing now DappCon for a while. I actually started in 2018. And I thought like maybe it's time to look back and like explain again why we actually started this. So Gnosis, as some of you might know, like we started as a part of Consensus, building decentralized applications. And actually Consensus itself also had this goal, like Ethereum Foundation is building the core infrastructure layer and Consensus building the application layer on top. That was basically the idea why Consensus was started. And well, we were there from the very beginning, and in 2018, well, when we looked around, there were actually not that many applications. There was already a lot of infrastructure, but not many apps. And we always, for us, it was always very clear, like infrastructure has to be built for a purpose. It has to serve someone. And just building infrastructure for the sake of building infrastructure is not making sense. Someone has to build these applications. And also, we saw it as a big opportunity. If you're building applications, users will interface with the applications, and if you're building the applications, you are owning the user. There's big value capture there. And that was also one of the reasons why we started Safe, by the way, or previously the Gnosis multisig, not purely as a public good, but also because it's an opportunity. And yeah, surprisingly, I took a screenshot using the web archive. This was the state of dApps in 2018 when we did the first DappCon. And you see like the top application in this case was something called Hypersnakes, had 4,000 users. That was the absolutely top application. We had exchanges. Uniswap was not there yet. So we had like other exchanges like IDEX was the #1 exchange with 1,000 users per day. NFTs started to be sort of relevant. The CryptoPunks had 7 users in the last 24 hours. There was even already OpenSea, but yeah, it was kind of one of the top applications with like 141 users. And so yeah, it was very obvious like there's not a lot happening yet on the Dapp layer. We see the kind of the first seeds were planted, but there were not many users. And we saw by creating DappCon, we are putting in focus on application building, try to get builders together to understand what can be built in order to make the infrastructure more used and useful. And yeah, that was the initial idea of DappCon. We have done it almost every year with one exception during COVID. Yeah, I think now jumping ahead, where are we today? Then surprisingly, I would say there's still a very strong focus on infrastructure. Like this year is now DappRadar again, but from yesterday. And we see like the number of users in the last 24 hours. It's basically mostly Uniswap. And then 1inch, and I think somewhere there's CowSwap as well in number 10. And then there's something called Banana Gun. And then if you look at the infrastructure layer, meanwhile, there's L2B, this is the platform that lists all the layer 2s, as you know. There's 73 layer 2s that are currently being operational, and there's 82 more in the development. And this is all like all people and funding being applied to create even more block space that frankly nobody needs. And it's a misallocation of capital in the industry. And it's kind of a bit sad to see this, to be honest, because ultimately what we do is we're building a lot of infrastructure, but we do not serve enough users to actually justify this investment. And that's also one of the reasons why we try to kind of still focus on many things that are really where the user stance is in the focus and where we hope we can actually create a more vibrant ecosystem for people to actually do stuff that are not necessarily speculative. Yes, of course, mentioning 2 Gnosis projects, Gnosis Pay and Circles, have been created with this intention in mind. But there are also others that are quite exciting, like flywheels. They're also here. They're building basically, kind of Google Docs, but in a decentralized way, integrating a lot of the crypto primitives, which make it a unique experience. And So that's kind of where we are right now. Now, that's also not the full truth, because there are successful parties that are benefiting from all of this. And that is like companies like Coinbase. This is also, again, like from the same timestamp from yesterday, like how many people are actually operating on layer 2s that are the most successful. In this case, Base is right now the most successful layer 2. And we have about 20 times more users on Base compared to Ethereum today. And well, it is problematic because obviously like those are like basically like networks driven by centralized exchanges that are not necessarily value aligned with what we had in mind. And I think that was just something that just happened recently. Coinbase started sponsoring basically the parade of the US Army, and that's how this photo came about. And I think it's kind of cannot be kind of more obvious that this is not a credibly neutral platform like Ethereum intends to be. At the same time, there's an American company that hugely benefits from the research and development, literally billions of dollars spent on basically creating the underlying infrastructure that now they can benefit from. And to have another graph that kind of underlines this here is from the wallet report by Dune.com. They are tracking, in this case, your self-custodial wallets, and there are two charts here that I picked out. One is just the pure transfers that were done via these wallets. Again, they're all like self-custody wallets. And well, there's one big spike at the end. It's basically Binance. Binance changing their strategy to be doing things more on-chain again. And of course, they own distribution, they own the users, they can decide how infrastructure is being utilized, and that's why we have this insane spike at the very end. But also, if you would remove Binance from this, basically the market is mostly divided by centralized exchanges, which are directing the users to now use more self-custody solutions, which are obviously also mostly operational on their own networks. The second chart also underlines this, which is basically the volume that's being traded. You see here MetaMask by consensus. That was a really dominating wallet over the years. It's now declining comparatively compared to basically the wallets promoted by centralized exchanges. So TLDR, centralized exchanges are eating our lunch. And we have to do something, because otherwise we end up in a world where basically entire retail is basically owned by a few parties which are not really aligned with our own values. And just to explain like kind of an overview of what are the decentralized exchanges currently doing, we have Coinbase, obviously they're building Base based on optimism, same like Binance, built by Binance Smart Chain as a fork of initially Geth and Aragon. And yeah, basically all of the bigger centralized exchanges that have enough resources, they are able to piggyback on the technology that we built and basically have the value capture because they own the distribution. So now, I think Vitalik wrote a year ago or 2 years ago like this post in terms of like what do we need to do in order to get ready for mass adoption. And he listed like scalability. At this point, as we saw, we have basically unlimited block space available, so we can consider this being solved. User experience has drastically improved through account abstraction, also fine. Security, I think we made major improvements. If not North Korea is coming after you, it should be pretty fine. Privacy is still something that we are working on, but there are also many solutions which are being worked on, which will become viable. One thing that we kind of completely neglected is distribution, and that is obviously ultimately what matters if you want to be successful and actually also define, frankly, like how the future will be. And that's why I encourage every one of us to really think about how do we do distribution. There's not a silver bullet of how we do this. And honestly, it's also different, obviously, to compete with someone like Coinbase or Binance. And that's why you have to basically pick your battles. And you have to understand how can you be different from the competition? How can you do something that is better and fundamentally adds more value to your users than what Binance and Coinbase are trying to do, which is not easy because They're actually pretty good at building products, but it is possible. And that's what we're trying to do with Gnosis Pay and Circles as well. Like we try to understand, okay, what are the pain points of our users? Where can we go? And of course, like if you compete with someone who can operate globally, you basically have to go locally. You have to understand what can you do on a smaller scale, better than everyone else, and then kind of go bottom up in order to be relevant. Yeah, that is concluding my presentation today. I hope it is, again, like it's something where I hope we can be, let's say, optimistic about the future, but we also have to realize what the problems are. We have to realize what we have to tackle on, because otherwise we give it to Binance and Coinbase, and that's really not what I would like to do. So I encourage everyone thinking about distribution. There are a lot of people that are pitching ideas to me, and my first question is usually like, okay, this sounds all great, but it will be commoditized, and how do you distribute it? And I think that has to be almost the first question that we have to ask ourselves. How do we distribute what we build? Because otherwise someone else is going to benefit from it. Thank you.
Thank you, Stefan. So this was the last talk. So we just want to thank you, everyone, for coming and attending the conference. And everyone I've spoken to said that they love Berlin. So please come again next year. Thank you so much for coming to DappCon and making it a success.